Check, check. Welcome to Austin, Texas, everybody. I think I'm supposed to be looking at that camera over there, maybe. This is the first time. Thank you so much, everybody, for tuning in. We're just waiting for the live stream to start from Tesla for Investor Day. Shout out to everybody in the crowd here. We got a bunch of people that showed up at Clive. Thank you all so much for coming down. Love you guys so much. So this is what's going to happen for everybody at home. As soon as the live stream starts, we're going to switch over to the live stream. And then once Investor Day is over, we'll come back to Clive, and we'll have multiple panels where people are going to share their thoughts, and you're going to get to see everybody here hanging out as well. We're going to have a really good time. For everybody in Clive, once we finish this camera rig here in the middle, what we're going to do is we're going to move the ropes to the stage and then move everybody forward, okay? So just giving everybody a heads up. There's also a second level as well. Looks like we already have people up there in the mezzanine. Shout out to the mezzanine up there. Love you guys. Thank you so much. Awesome. And yeah, just giving you guys a heads up. I want to give a huge shout out to Mike and the Clive team. Please give them a huge round of applause. Thank you so much. Thank you. I also want to give a shout out to Matt Holm and Anwar Beck, who are the leaders of the Tesla Austin Owners Club. Thank you all very much. 10th year anniversary. And yeah, so is everybody ready? All right. All right, so we're waiting on Tesla now. Once they're live, we'll watch them for 2.5 hours. We'll come back, we'll do panels, and then we'll have a good time. Sound good? All right. Tip your bartenders, I guess. Yeah, go ahead. All right.
Good afternoon, everyone. Good afternoon. My name is Zach Kirkhorn. I lead finance here at Tesla, and welcome to our Investor Day. For those of you here in the audience at our global headquarters in Austin, Texas, we welcome you. Thank you for being here, and thank you for traveling in. For those joining us virtually, thank you for being a part of the day today. So as we reflect back on the history of the company, there's been distinct phases of product advancement, technology innovation, and rapid volume growth. The most recent of which has been the global expansion and localization of the Model Y program. And so today, we want to talk about the future. We don't want to talk about this quarter or next quarter. We want to go further out into the future. And we've divided today's presentation into 3 parts. The first of which, we're going to go macro. What does it take to convert Earth to sustainable energy generation and use? The second, we want to talk about Tesla's contribution to that global need. And we're going to go function by function through the company, and you'll meet our entire leadership team, and we're going to get into the details of what those teams are doing as part of the broader goal. And then in the third part, we're going to bring it back up and talk about what this all means for the company as a whole. So before we get started, statements made in this presentation are forward-looking statements that are subject to risks and uncertainties. More details can be found in our written materials. So with that, let's get started. Part 1, Elon Musk and Drew Baglino.
All right, master plan part 3. So as Zach was mentioning, the thing that I think is we wanted to convey, probably more importantly than anything else that we talk about here, is that there is a clear path to a sustainable energy Earth. It's not, it doesn't require destroying natural habitats. It doesn't require us to be austere and stop using electricity and sort of be in the cold or anything. The story, and I think this holds together quite well, and we'll be actually publishing a detailed white paper with all of our assumptions and calculations, is that there is a clear path to a fully sustainable Earth with abundance. In fact, you could support a civilization much bigger than Earth, than much more than the 8 billion humans could actually be supported sustainably on Earth. And I'm just often shocked and surprised by how few people realize this. Most of the smart people I know actually don't see this clear path. They think that there's not a path to a sustainable energy future, or at least there's not one that is sustainable at our current population, or that would have to resort to extreme measures. None of this is true. So we're going to walk through the calculations for how to create a sustainable energy civilization. Yeah.
And to set the stage, today our energy economy, let's be honest, it's dirty and it's wasteful. Over 80% of global energy, primary energy, comes from fossil fuels, and only 1/3 of that global energy actually ends up delivering useful work or heat. This is the problem statement, but we're here to talk about the solution.
Yeah, it's like some of this I'm going to elaborate because there's a very wide range of technical expertise out there, from people who are like, whatever, level 9 wizards in the subject, to people who do not do engineering at all. So, if you have a gasoline car, you're converting less than 1/3, often maybe only 25% of the energy in the gasoline is converted into motion. The rest is turned into waste heat. That doesn't do any good at all. And there's a lot of energy required even to get the oil out of the ground, to refine the oil, and to transport the gasoline to the gas station. So when you look at all that, for a typical gasoline car is actually going to be using less than 20%, fully considered, of the energy from the oil actually goes into motion. So this is when we see people doing calculations for what does it take to create a sustainable energy Earth, they assume that the same energy amount is required for an electrified civilization versus a combustion civilization. This is not true, because most of the energy of combustion is waste heat.
And even to get the fuel to combust in the first place and get it to the end use, there's a lot lost along the way. I mean, this is the primary energy consumption, 165 petawatt hours a year. Petawatt hour is a trillion kilowatt hours, so it's a large amount of energy. But the nice thing about an electrified economy, there's a better way, we're going to talk about it, is that through end-use efficiency and through efficiency along every step of the way, actually the total energy use halves. So this is one of the most enabling aspects of electrifying everything, is that the sustainable energy economy is that much easier to accomplish. It's actually half the problem statement of the fossil fuel economy.
Yeah, and we're being conservative here, so it could be better than half, but we're trying to have assumptions that are reasonable, not overly optimistic, in fact, slightly pessimistic. So it's really better than half, but just say it's easy to make the argument that we need half as much energy with an electric economy versus a combustion economy.
Yep. So how the master plan works? You want to talk about?
So the thing that is needed at very large scale that is not currently present is a vast amount of battery energy storage. Our rough calculations are that this is about 240 terawatt hours, or 240,000 gigawatt hours. This is a lot of batteries, but it is actually a very achievable amount. We'll go into details on that.
Yep.
So that's a combination of electric vehicles and stationary storage. So if you've got solar or wind, you've got to store the energy when the wind is not blowing, the sun is not shining. And so we're assuming sort of an 8-to-1 ratio of stored energy to power. So 30 terawatt hours of power, 30 terawatts of power. Our actual capital expenditure calculation for manufacturing investment is more like 6 trillion, but we made it higher to make it 10 trillion.
And this is across mining, refining, battery factories, recycling, vehicle factories, all the things that we're going to talk about needing to invest in to build this sustainable energy economy.
Yeah. Now, if you look at the total world economy, it's just under 100 trillion. So if this was spread out, say, over 10 years, it would be 1% of the global economy. Over 20 years, it would be 0.5%
Very
of
doable.
the global economy. So this is, not a big number relative to the global economy. As Drew mentioned, you need about half as much energy with an electric economy versus a combustion economy. And in terms of wind and solar, how much land would be used? It's less than 0.2% of the land area of Earth. Generally, people don't realize quite how much energy is reaching us from the sun. It's roughly a gigawatt per square kilometer. And the sun doesn't shine all the time, but it's if you multiply that by, say, 4 to get the continuous power, 4 or 5, then that gives you the land area of solar. And you can put wind and solar often in the same place. So a lot of places that currently have wind, you could have solar there, and you double your energy.
You can also put wind offshore. It doesn't even need to be on land, so wind is even more flexible.
You could put solar offshore, too.
Yep.
So Earth is 70% water. Anyway, the point is that with a really remarkably small amount of Earth's land area, we can go fully sustainable. And
from do the resources and raw materials exist to support this transition? We'll go through that in detail, but we do not see any insurmountable resource challenges at all. In fact, in the end, we should be mining less ore to accomplish this economy than we currently do with the fossil fuel economy, and we're going to talk through that.
Yeah, just to emphasize that again, the electrified economy will require less mining than the current economy does.
Yes.
Less, not more. Okay.
So this is the plan, and now we'll get into a little bit more of the details of the plan. Basically, 5 areas of work. First, renewable power the existing grid. Second, switch to electric vehicles. Third, switch homes, businesses, and industry heating to heat pumps. Fourth, high-temp heat delivery and storage for high-temp industrial and chemical processes, and a little bit of green hydrogen in there for chemical processes that need hydrogen. And finally, sustainably fuel planes and boats. These are the 5 areas, and we're going to go into detail on all of them.
Yeah, I mean, my personal opinion is that as we improve the energy density of batteries, you'll see all transportation go fully electric, with the exception of rockets. That's awkward. But you can make the fuel with CO2 and water. So you can make methane with CO2 and water. So
And you can do that with just electricity. So.
Yes, exactly. So, in fact, on Mars, if we hopefully get there at some point, the atmosphere is CO2, and there's water ice throughout Mars. So you can take the CO2 and H2O and turn that into CH4, which is methane, and oxygen. So ultimately, even rockets can be electrified.
So first, repowering the existing grid with renewables. And this is going to be a consistent theme. You'll see our estimates for the number of terawatt hours, terawatts, and trillions of investment at the bottom of the page. You know, this is already actively occurring in front of us. 60% of the generation added to the US grid was solar in 2022. And actually, on a year-on-year basis, solar deployment is growing 50% year-on-year as of 2022. So this is a serious upswing. And if we continue this trend, this is going to be behind us before we even know it.
Yeah.
Second, switching to electric vehicles. Again, 21% reduction in fossil fuel use by doing this alone. Obviously, Tesla is heavily engaged in this activity, along with many others. Overall, EV production grew 59% year on year in 2022, and EVs hit an amazing 10% market share. I mean, it's an awesome milestone. I'm super excited to see that. I gotta.
Yeah, I mean, this is obviously happening very rapidly, and I mean, I think really all cars will go to fully electric and autonomous, and so riding a non-autonomous gasoline car is going to be analogous to riding a horse and using a flip phone. That's basically going to be the situation.
And we actually took a somewhat conservative assumption here in terms of how many batteries are required, because the more the fleet is autonomous, the smaller the fleet needs to be, just from a utility basis. So we're not accounting for all of those benefits, or really much of those benefits at all in this number. And what does this fleet look like? You know, just rough view from our perspective. Of course, we could be wrong, but you know, you can see the sort of breakdown of the fleet by millions of vehicles. You know, our goal is to do 20 million electric vehicles a year. Yeah.
Fewer vehicles will be needed, at least passenger vehicles, with autonomy. So there's some debate as to what that number is, but it's some number less than the number of vehicles needed today. There's roughly 2 billion cars and trucks in operation in the world today. And
yeah, so what we show here is actually, I think, only 1.4 million or so. So we're represent 1.4 billion, I mean, or so. So a smaller fleet. And you know, the numbers here in this presentation are around 85 million vehicles a year produced, just to give you a sense of how we're thinking about this. Again, we're going to put all these assumptions up online and, you know, encourage people's thoughts.
Yeah. So, yeah, so we're basically heading rapidly towards an electric or autonomous future.
Exciting.
Yeah.
And one of the reasons why EVs are so enabling is this end-use efficiency point. Tesla Model 3, it's 4 times more efficient from the well to wheel than a Toyota Corolla. And that's all about the efficiency of getting the electricity into the car in a sustainable energy economy, and then how efficient the car is in transferring that stored energy to motion on the road. when compared to the engine in the Toyota Corolla and all the extraction, refining, transmission, distribution of the gasoline to the Toyota Corolla. And just for, this is a fun reference, Model 3 can drive over a mile on the energy it takes to boil a pot of water for pasta, and then it can drive another mile on the energy it took to cook the pasta. And that pasta is 1 pound, and Model 3 is like 4,000 pounds. Just to give you a sense of just like, it really doesn't use a lot of energy to move a Model 3, that 4,000 pound object, down the road.
Yeah, also, heat is a lot more energy than motion.
Yeah. Yeah. But people, you just boil a pot of pasta, you don't even think about it. It's just interesting how efficient these cars are. Next, switching to heat pumps in homes, businesses, and industry. Right now, heat pumps meet 10% of building heating needs. Install rates growing 10% year on year. It really needs to accelerate. Heat pumps can serve, heat applications up to 200 C in businesses and industry. And from an investment perspective, as you can see on this page, this is actually the lowest hanging fruit in terms of displacing fossil fuels. You might be saying, well, what exactly is a heat pump? So heat pumps don't move heat, don't create heat, they move heat. When you think about like the natural gas furnace in your house, like it is generating heat itself, but what the heat pump is doing is actually moving heat from outside of your house into your house. They're just an air conditioner or a refrigerator in reverse. So we're surrounded by heat pumps. There's like, they're all over this factory. They're in your house. And all this really is about bringing them to displace all the fossil fuel heating in all of the homes, business, and in the industry that we can. And from an end-use efficiency perspective, there's a three times reduction in the total energy required to heat these buildings. So a real obvious thing to do.
Yeah, heat pumps. They're in our cars, now as default. And at some point, we might make a heat pump for our home. So.
Yeah, maybe. Next, a little bit more detail on electrifying high-temp sort of industrial chemical processes. So over 50% of industrial heat is greater than 400 C. Cement, steel, fertilizers, chemicals, plastics, metals refining all need like 1500 C. So we need a solution here. Ultimately, it's purpose-built equipment that enables electrification. Carbon graphite is stable up to 2800 C. There's other options in the 1500 C range, like silicon carbide, other materials. So the idea here is you create and store heat when renewable power is available. If this is a sustainable energy economy, renewable energy is intermittent, peak of the day, you've got more generation than you need, you make a bunch of heat then, and then you transfer that heat into the industrial process 24 hours a day using the stored heat you created when the sun or the wind was blowing. That's the concept here. And then on the hydrogen side, we also need green hydrogen to decarbonize metals and chemical refining processes. This is things like ammonia, making steel. There's roughly 120 million tons of hydrogen sourced from fossil fuel today to do these things. And hydrogen can also directly replace coal, which is currently used in a ton of steel production, through a process called directly reducing iron. You can replace blast furnaces with a hydrogen-reducing direct reduced iron furnace. And this is the way to eliminate fossil fuels from these aspects of the economy and the CO2 associated with them.
Yeah, so some of this, there's like room to disagree, but some amount of hydrogen is needed for industrial processes. My personal opinion is that hydrogen will not be used meaningfully in transport, and shouldn't be. If you're going to use a chemical fuel, you should use CH4, not H2. But nonetheless, it is needed for industrial processes and can be produced just by splitting water, essentially.
I mean, something that's been done for decades and decades. Yeah. This is not, rocket technology.
Yeah.
And lastly, a small part of the pie, but a necessary part of the pie, is sustainably fueling planes and boats. Shipping accounts for 3% of global CO2. It's ripe for electrification. Even with lithium iron phosphate, long-haul ships can be fully battery-powered. So that's a great opportunity to electrify. Energy density is a little bit harder for planes, but short-haul is doable today. With some improvements, we'll get long-haul underway. But even in the meantime, we can leverage sustainable aviation fuels produced and stored using excess renewable electricity. There's a lot of work going on in this space, and it's not, yeah.
Yeah, I mean, to really get long-range aircraft and long-range shipping to use lithium ion, you need to redesign the ship not just
Or the plane.
and the plane, to take advantage of the fact that it is a new source of energy. It's a different architecture. So just like with an electric car, you wouldn't just take a gasoline car and stick a battery in it. That's very, very suboptimal. It's much more efficient to have the battery be the structure of the car, and make it mass efficient and optimized for batteries. The same, if that's done with aircraft, I think you can get long-range aircraft at around with cells at around 450 watt-hours per kilogram, which you can buy it right now. Actually, it's expensive, but I think that price will come down.
So when we stack up all of these efforts, we end up with the numbers we shared at the beginning of the presentation: 30 terawatts, 240 terawatt hours, $10 trillion. And you may be saying, like, I need some context. Is this feasible? Spoiler alert, it's entirely feasible. Just looking at it from a growth rate perspective, how much do we need to grow the deployment of these technologies? We're talking about only a 3x growth rate in solar and wind deployment. Solar is already growing at a breakneck pace, as is wind. This gap is going to be closed really quickly. When we look at the electric vehicles, they have to grow 11x. Well, they grew 60% year on year last year. That growth rate is also going to close pretty darn. That gap is going to close pretty quickly as well. And lastly, storage. Tesla's energy storage business has grown at 65% CAGR since 2016. The global energy storage business is accelerating pace as well. I mean, all these gaps are going to close, especially as this momentum of the transition to sustainable energy accelerates. And of course, our goal on this page is 20 million EVs per year and 1 terawatt hour of stationary storage per year, basically as soon as we can. And then, what about this investment? How do I have a reference point on this investment? Elon mentioned it's 10% of 1 year's world GDP. Another way of thinking about it is, how does it compare to what we're investing, like what we invested last year in the fossil fuel infrastructure? And it's 60% of that investment. So actually, building this sustainable energy economy is less than extending the fossil fuel economy from a year-over-year investment basis. So very doable. When we look towards, does this fit on the planet? Absolutely. Less than 0.2% of land. As a reference point, the total land area intensively farmed today is 12.5% of all land. So, I mean, you drive around, you see some farms, but you don't see them everywhere. This is an order of magnitude, more than an order of magnitude difference between farming and what we're talking about for sustainable energy land.
Yeah, and it doesn't need to displace farmland or forests or jungle or any kind of ecological preserve. It can be used in very sparsely populated desert regions.
Yeah. Barren areas. Yeah. Areas that are just not really fit for development or otherwise used. So
yeah,
I mean, 0.2% can fit into a lot of places.
Yeah, there's essentially no meaningful ecological impact. In fact, transition to a sustainable energy economy would result in a substantial reduction in current ecological impact.
That's a great way to put it.
Yeah.
And what about on the mineral extraction side? So this is a cartoon that sort of gives you a sense for all the ore and the extracted minerals that are coming out of the earth every year. It's about 68 gigatons. So each truck is a gigaton. What does this look like when we're in a sustainable energy economy? Looks like that. The fossil fuel extraction disappears. We replace it with the materials required to fulfill the sustainable energy economy. It actually reduces. Now, it's not to say that we don't need to continue to explore, bring on mining and refining for the sort of specific materials for the sustainable energy economy. We do. But the investment in mass flows are all very achievable, just looking at what is already happening on the planet. Like, this is nothing out of scale of what has been done and is already being done. And then when we calculate it on a sort of, element by element basis, the resources are there to support the transition. This is cumulative demand to move in the sustainable energy economy direction until 2050 relative to USGS resources today. We're not breaking the resource bank for any of these materials. And then when we look at what really happens as we move forward, history teaches the more we look, the more we find. What people think happens is, oh, there's this many resources, next year there's going to be less because we're going to extract them. What actually happens is, as we extract resources, we find more. And you can see on the right what has actually occurred with the key materials to the sustainable energy economy. Since 2000, as the sustainable energy economy has been growing, and Tesla's been growing, and all the industries around us have been growing, the actual resource availability has increased, not decreased.
Yeah, there still seems to be quite a bit of confusion about lithium. Lithium is extremely common. It's one of the most common elements on Earth. There's no country that has a monopoly on lithium,
Yep.
Or even close to it. There's enough lithium ore in the United States to electrify all of Earth. If the United States was the only place producing lithium, there's enough domestic material to electrify Earth. It's very common. The limiting factor is the refining of the lithium into battery-grade lithium hydroxide or lithium carbonate. That's the actual limiting factor.
And the same is true for these other materials.
Yes.
And this is, again, these are not like crazy technologies. It's just the investments need to be made, and the investments, they're not gigantic. They just need to happen.
Right. Nickel is maybe of them all the trickiest one to solve. But as we showed with the graph there, maybe need like 30% of the world's known nickel reserves. So.
And the nickel reserves have actually grown since
Yes.
2000. So.
There is more. Yeah, exactly. So. And you only need nickel for basically aircraft, long-range boats, and very long-range cars or trucks. But the vast majority of the heavy lifting for electrification will be iron-based cells. And iron is actually literally the most common element on Earth. So, a little trivia point: if you say like, what is Earth made of? By mass, it is made of iron more than anything else, and second, oxygen, and then everything else after that. So basically, we're a muddy rust ball is what Earth is. So an iron cathode is sort of, you're definitely not going to run out of iron. There's so much iron, it's insane. So that's, yeah. So.
Yeah, and ultimately, this resource extraction, we go through this effort, we build these batteries, and then we recycle these batteries. So ultimately, we're doing this to build this sustainable energy economy, but the maintenance amount of ore that we require is really an order of magnitude or more, less, because of recycling. So in the end, a sustainable energy economy is within our reach, and we should accelerate it.
Yeah, I mean, so this is really the main message of today. And I really wanted today to be not just about Tesla investors who own stock, but really anyone who is an investor in Earth. And what we're trying to convey is a message of hope and optimism. And optimism that is based on actual physics and real calculations, it's not wishful thinking. Earth can and will move to a sustainable energy economy, and will do so in your lifetime. Thank you.
Yes. Thank you. And I just want to welcome up Lars and Franz to the stage.
Hi. Hi, I'm Franz. I lead design at Tesla.
And I'm Lars. I've been doing vehicles with Franz for almost 13 years now.
So I joined Tesla in 2008 to vertically integrate design into the company. It didn't exist before. It was a pretty small team. It was tasked with designing the most beautiful, innovative, and well-engineered vehicles on the planet. No small task in 2008. There was not a lot going on in the EV sector then. Since then, we focused on constant improvement in cost, efficiency, innovation, things that you'll continue to hear about today, while continuing to design the most desirable cars. Today, we produce cars differently than we did 10 years ago. But the end result is always an exciting, futuristic, and desirable set of vehicles.
Back then, we only had a handful of designers and engineers like myself, but we had a great vision to radically change transportation.
So back in 2008, where we were designing Model S, we didn't have a factory. In fact, we had a really small engineering team and a tiny design team. But that allowed design to lead all the conversations. It let us innovate forward-thinking ideas, like how do you fit 7 people into a sedan? Or how do you make door handles disappear into the doors? Or putting a huge touchscreen into the center of the vehicle, something that had never been done before.
And then we won Motor Trend Car of the Year.
Yes, and we won Motor Trend Car of the Year in 2013. Our first, great award, first car. Pretty good start. Kind of a home run, I think. But that whole process resulted in a linear process that you see on the screen. We designed first, then we engineered, and then we figured out how to manufacture it.
Yeah, I mean, I think that's really important. When we were designing the car together, we didn't even know where we were going to build it. And so we came up with...
I didn't even know Lars when we were designing.
That's true. So once we got Fremont, we were very fortunate, and we figured out the manufacturing solutions sort of like we were flying a plane and putting the wings and building the engine at the same time. So we knew we had to do better.
Yeah, we knew we had to be better in order to scale. And as part of the master plan that you've read, Model 3 needed to be a smaller, more efficient, and more affordable version of Model S. But it had to be equally great. It had to have all the things that people loved in their Model S or Model X, but be much more affordable. And so we approached the process a little bit differently than the first time around. Now we had teams that we all worked together, so we were able to combine design, engineering, and manufacturing process all at the same time. But somewhere along the way, we changed the manufacturing process to be fully automated. And so we leaned into this whole new way of manufacturing a car, but we had already engineered it. So things didn't quite go as well as planned.
It was an amazing product, but it landed us in production hell. Many of us who lived through that carry those battle scars. It was a great idea, but it wasn't the right timing. Like Franz said, automating something that we designed to be built manually is super hard. And we have many, many failed examples of that at the Fremont factory that we ripped out. But some of them eventually still work. This is one I actually worked on with a small team of engineers. It's still running today. And some of the engineers that came by said we couldn't do it, are no longer with the company, but it's running, and it's running faster than ever. So we kind of self-imposed constraints on the design when we were doing it to be built manually, and we really didn't think about it. But despite all that, Model 3 is the best-selling EV ever.
Yeah, and Model Y, which is derived from Model 3, is about to pass that. But we knew we had to improve the process further. And with Cybertruck, we designed a vehicle around a vision that actually started with the manufacturing process. And in this case, the materials dictated the design.
Forming full hard stainless steel isn't rocket science, but it sure isn't easy, and it limited the way we could do it.
Yeah, absolutely. It really forced us to think about designing something in a way that you couldn't normally stamp panels, you couldn't form them in a traditional way. So you ended up with very linear bending processes that are just not in automotive kind of language of manufacturing today. But it actually created a very efficient process and one of the most dynamic designs ever, I believe. It's definitely something that's going to change the road landscape.
Hopefully you guys saw it down there and you experienced it. It's definitely real. Those are real trucks. We're on our way to build them. But what that stainless steel opportunity did for us, it has let us rethink the factory footprint. We don't stamp those. That's a huge part of it. We don't even paint them. So our footprint got smaller, and we started to think about innovative ways to take those constraints and make great products.
But that constraint didn't really change the end result of the truck. It's a super dynamic truck, and it has all the functionality you would expect out of any of the other competitive trucks. And the best thing about it, it's coming this year.
So ideally, after all that, we would design, engineer, manufacture, and plan for automation happening together. It gives us the opportunity to question requirements. This is something that is fundamentally only available at Tesla. and the places I used to work and the top manufacturing companies in the world, they don't sit together.
Yeah,
we are one team.
Nowhere I know has all these teams together thinking about these processes from the very beginning.
In fact, all of those engineering teams, manufacturing, design, automation, they're all in one org. They all report to one person. We can't point fingers at each other, so we have to solve them together, which is the best way to innovate. The traditional way of making a vehicle is this. You stamp it, you build a body in white, you paint it, and you do final assembly. And what's interesting is these shops are dictated by the organizational structures that exist. And they're dictated by the boundaries that exist in the factories that are laid out. If something goes wrong in final assembly, you block the whole line, and you end up with buffering in between. This is at the tail end of its manufacturing optimization. Henry Ford first invented this assembly line in 1922. It's been 100 years, and it's really hard to make a change after 100 years. And when you watch it happen, it's actually really silly to a guy like me. You take all these stamp panels, you put them together, then you put them in a framing station, you build a body that looks something like a car, you put the doors on, and then you paint them. Once you get the color, you take the doors off, and then you start putting the interior inside the car. It comes in through the openings that already exist. I wish it went in like this big piece like this, but there's actually people coming in and out of the car. There's awkward movements. Then we lift the car up, we put stuff from underneath it, we put it down, then we put the seats in the car, and finally, we close it all out with glass, and we bring those doors that went away for a trip, and we put them back in the car. Most of the time, we're doing this with a big, giant car and moving it and doing really nothing to it at all.
What's funny, though, in this kind of whole process is that just recently, Toyota just called this an engineering work of art.
True.
The Model Y.
That was humbling, but at Tesla, it's not good enough. If we're going to scale the way we want to do, we have to rethink manufacturing again. As part of the master plan, we have to make another step change in cost. We started this on Model Y when we made these huge gigacastings, and we deleted hundreds of parts. We simplified assembly with the Model Y structural battery, where we decided the floor should be a part of the car. The battery is the floor. We put the seats and the interior on the battery, and we bring it up through a big open hole, and we assemble it. And this allowed us to do things in parallel, fully rethinking the process and reducing the final assembly line by about 10%. And we thought, maybe we could do this other places.
Yeah, I mean, in a way, the constraints become part of the solution rather than a problem.
So when you think about what I'm trying to say, I really want to hammer this home. When you have a car that's about 5 meters long, and you have people working around it, like we did in Model 3, and we change that to this process where we take different parts of the car, and we can do more at the same time, like we did with the Model Y structural battery pack. What you see here is us doing that on the front part of the vehicle, or the rear part of the vehicle. That means we can get more people working on the car, or robots, working on it at the same time. That means we have better operator density, less time doing nothing. I call that space-time efficiency. It has nothing to do with quantum mechanics. We can have that conversation later. But we get 44% more operator density, which means more work, less time walking back to the station, 30% improvement in space-time efficiency. And because we're not building it in and out of the car with those slow movements of those robots I showed you from production hell, when we go to automate it, it's going to be a lot easier. In the end, that will probably look something like this, where we balance parallel and series manufacturing in a way where we only do things that are necessary, with a much shorter final line, blocking a lot less of the entire rest of the factory, so we can optimize material flow using the best practices. And what that means, it's going to look something like this, where we build all the sides of the cars independently, we only paint what we need to, and then we assemble the parts of the car once and only once. We put them where they need to go. The interior is attached from a bottom-up or a top-down strategy, so there's more access for those robots and people. We aren't moving heavy objects around and doing nothing to it, and it means we're doing more work on the car more of the time. And then when we take all of these tested sub-assemblies and we put them together, we finally assemble the car only one time, putting the sides on with all of their parts to a front and rear that was already assembled, carrying the floor in with the seats, and finally boxing it out with the doors one time, just like Cybertruck. So in the end, you get the same car, but it's not going to be a Model Y.
Yeah, this is not. Yeah. This is a Model Y for illustration, not the next-gen vehicle.
In the end, what does that mean? To increase the scale and adoption of electric vehicles on the orders of magnitude that we just showed you, we have to make constraints part of the solution. It leads us to greater than 40% reduction in footprint, which means we can build factories faster, with less CapEx and more output per unit. Faster, less CapEx, more output per unit dollar. Zach's going to go into more details on this later, but it also means through this innovation and some of what my other engineering colleagues are going to talk to you about in the future, we'll reduce costs as much as 50%. This is the 2-for-1 concept you hear me and Elon talking about on earnings calls.
Yeah, so I think our track record proves that we can deliver the best cars, and we deliver the best cars in spite of, because of these constraints. And I'd love to really show you what I mean and unveil the next-gen car. But you're going to have to trust me on that until a later date. And I promise we'll always be delivering exciting, compelling, and desirable vehicles, like as we always have.
Have we ever not? We always do.
But what else is Tesla known for?
Speed. So with that, I want to bring on Colin, who's in charge of making our cars go fast.
Thank you, Lars. Thank you, Franz. My name is Colin Campbell, and I have the real privilege of leading powertrain engineering here at Tesla. We make the fastest cars that you can buy for the money, whether they're electric or gas. And the Model S Plaid that we're looking at here, it has more than 1,000 horsepower, and pound per pound, the motors in that car are as powerful as jet engines. Our cars are super fun. People absolutely love driving in them. And the other thing that you probably all know about our powertrains is that they're efficient. Our cars go 25 to 30% further than other EVs in our class for the same amount of efficiency. But at Tesla, efficiency means more than just reducing how much energy the cars use. It's about how we develop, how we manufacture, how we refine, and how we scale the powertrain. Now, the Model 3 and Y powertrain is a great example of this broader meaning of efficiency. So since we launched it back in 2017, we've continuously improved that powertrain and the factory that builds it. So the drive unit, the engine of the car, is 20% lighter for the same power. We use 25% less heavy rare earths than when we started. And the powertrain factory, which is behind me today, is 75% smaller and 65% cheaper than the one that we originally built. And what I really want to emphasize is that we did all of this without compromise. Our cars are just as powerful, they go just as far, they cost the same or less, and the factories have the same output. So, how did we do that? We did it by designing the entire vehicle and the entire factory together as one company. And this sets Tesla apart. We have small and highly capable teams, and to make a critical decision, we can have the battery cell chemists, the mechanical engineers, the manufacturing engineers, the supply chain team, the automation designers, the software programmers, all in one room, working together in real time. And that allows us to make decisions that are best for the whole car and to make them really fast. And that approach is unlike traditional automotive engineering, which is really fractured. And if you were to go buy like a premium German electric car, the engineers who designed the drive inverter in that car, they did not work for that car company. They worked for a contractor. And at Tesla, we designed the entire car and the factory that builds it. And I want to highlight a few examples of what we've been able to do in-house thanks to that unique approach. So, inside the charger of your Tesla are transistor packages, and that's at the top of your screen here. And every electron that moves you down the road flows through one of these packages. We designed our own custom package, which is what you're seeing here, and we can extract twice as much heat out of that package as what we could buy off the shelf. And so what does that mean? It means that the silicon carbide wafer that's inside those packages can be much smaller. And silicon carbide is an amazing semiconductor, but it's also expensive, and it's really hard to scale. So using less of it is a big win for us. And then on top of that, orchestrating all of these transistors and making them switch in the right ways is computationally extremely intensive. It used to require 4 microprocessors, which are shown here in the bottom left. We have developed our own custom microprocessor. It's purpose-built for high-power electronics. It's half the cost, and it does, in just one, the job of all of those 4. And these are just 2 examples of many that I could use to showcase our expertise in high-power electronics. And that expertise has allowed us to take the cost of the chargers that were in our Model S when we launched it in 2012, both the cost and the mass, and cut both of those in half. And even more important, the power electronics, they're central not just to our cars. They're also central to our superchargers, and to our energy storage products, and Rebecca and Mike will be talking more about that. So in addition to the work that we've done in software and hardware, we've also done a lot of work in-house on software. So this is the drive unit for Model 3 and Y, and if we take a cross-section, we see the stator and the rotor, and they're responsible for the core function of the drive unit, which is converting electricity into motion. And our custom software lets us simulate the rotating magnetic field that is responsible for that conversion. And getting that simulation exactly right, it's central to the cost, the weight, the size, and even the sound of the drive unit. And now, you can buy software that will do all of this, but our tools are faster, and they're more accurate, and that was not easy to do. And that allows us to quickly iterate through millions of possible drive unit designs to find the best one. I want to highlight one more area where Tesla really excels because we integrate work that is often farmed out. So when you are making a new product, it's not enough to think about the product itself. You have to think about how you're going to make it at scale. So at Tesla, our powertrain and our powertrain manufacturing equipment is both designed under one roof. The engineers who are designing the motor, they are in the same room as the engineers who are designing the machine that's going to put that motor together. And that collaboration pushes us from day one to design products that are not only high performance, but are really easy to assemble. So, all of this expertise that we have in the powertrain team, in hardware, in software, in manufacturing, it's going to have a major impact on our next platform. In our next powertrain, so those silicon carbide transistors that I mentioned that are key component but expensive, we figured out a way to use 75% less without compromising the performance or the efficiency of the car. And of course, we know that battery cell supply is one of the constraints on the scalability of EVs right now. Our new powertrain is compatible with any battery chemistry. That will give us great flexibility in battery sourcing. If we want to make EVs more accessible to people, they have to be cheaper. We've reduced the drive unit cost to about $1,000, and we don't think any other automaker is even close to that number. Finally, the bigger a factory is, the longer it takes to build. If we can build the same number of cars from a smaller factory, we are going to be able to scale EV production faster. Our next powertrain factory is 50% smaller than the one that's behind me today, even though it has the same capacity. All of these improvements, I think, are going to be transformative for the adoption of EVs and our ability to scale them. There's one more thing that I want to highlight. So I talked about how we had reduced the amount of rare earth in our powertrains. And as the world transitions to clean energy, the demand for rare earth is really increasing dramatically. And not only is it going to be a little hard to meet that demand, but mining that rare earth, it has environmental and health risks. So we want to do even better than this. We have designed our next drive unit, which uses a permanent magnet motor, to not use any rare earth materials at all. So how does all this fit into the master plan? We can make lower cost products that are still efficient and compelling, and we can make them at scale. We're going to use less of constrained commodities, silicon carbide, rare earths. We're going to build them all in compact and high output factories that are easy for us to build quickly. We're going to make that easy to scale powertrains all the way up to the levels that Drew and Elon mentioned at the beginning. And this achievement, like all of the achievements that I mentioned today, it's only possible because of the incredible people on our powertrain teams. They are absolutely committed to the cause of sustainable energy, and that is why we can do what no other company can do. Thank you. So next, I'd like to welcome my colleagues Pete Bannon and David Lau.
Thanks, Colin. Good afternoon, everybody, and welcome to Texas. Pictured here is the low-voltage system of a Model S from 2012. This car was primarily designed with vendor-sourced controllers integrated by Tesla. There are over 300 low-voltage devices that encompass everything from the mundane, like the light in the glove box, to the complicated, like the infotainment computer, to the safety critical, like the airbags, steer-by-wire, and brake-by-wire. The low-voltage harness is built from individual wires, cut to length, crimped, and inserted into connectors, a manual process that is tedious, error-prone, and doesn't scale well. Going forward, we want to reduce the size and complexity of the harness and enable automated manufacturing.
And these wire harnesses introduce extraordinary complications, especially in the early stages of development and bring up of a vehicle, because when we're trying to bring up this entire system and we see that it's not working properly, we don't know whether it's a problem with the software, with the controller, the processor, any of the endpoints in this entanglement of wires. And so we have to go and debug everything all at once. And Pete's going to tell us about how we're going to make it better.
Mm-hmm. So I'm going to talk briefly about a few things that we've changed over the years since the Model S. With the Model 3, Tesla started designing an increasing share of our controllers by merging controllers together, and we were able to simplify the design with a significant reduction in wire count and weight. Going from S to 3, we reduced the wire harness by 17 kilograms compared to Model S. And this is a pretty big deal. And just to put that into context, our VP of Engineering, Lars, will deliver a bottle of your favorite spirit to your desk if you manage to save a kilogram of weight from the car. So this improvement cost him quite a lot. Did we skip one? Yeah. The original Model 3 controllers were enhanced and then built into Model Y. Those improved controllers were then moved back into Model 3 when we introduced the heat pump. At that point, we had shared controllers across both cars, which helped simplify our supply chain. Those Model 3 and Y controller designs were then updated and enhanced for the new versions of Model S and X that we introduced in 2021. For Cybertruck, we are now designing 85% of the controllers in the car. For the next-gen platform, we're going to finish the job and be designing 100% of the controllers to give us full control of the design and the supply chain at the component level. Having full control of the supply chain at the component level has been critical to Tesla over the last few years, as the supply constraints have hampered our ability to build cars.
And with that control comes control over all the software, which enables us to develop features and functionality that we never even dreamed of at the time we designed the hardware. So that's why you see software in your cars getting better and better over time in ways that we didn't even think of when we designed the hardware in the first place.
Mm-hmm. Yeah, Sentry Mode is one of my favorite last-minute changes.
One of my favorites.
With the introduction of Model 3 in 2017, we deleted relays and fuses from the car in favor of e-fuses. E-fuses replace moving parts with solid-state transistors. They provide fine-grained control of the power system to software and allow software to do advanced things like load shedding in the car under adverse conditions. E-fuses also allow for software-controlled retries for transient faults, and they allow for detailed monitoring of the power system over time.
Yeah, the theme you hear a lot about today is software-controlled hardware. And when I think about that in my team, software-controlled hardware is fundamentally about being able to sidestep what otherwise would have been static trade-offs between one attribute or another in a piece of hardware. We are able, with software, to instill intelligence, context awareness, and context-specific behavior into what otherwise would have been a piece of hardware that had to get optimized for one type of scenario. We get more of everything.
In 2022, we completed the transition from lead-acid batteries to lithium-ion batteries, and which use a new toolless connector. We expect lithium-ion batteries to last for the life of the car, so don't expect anyone to wake up to a dead battery ever again. This eliminates a major source of failures for our car. And the toolless connector makes it easier to service the car, and it also includes a software feature to allow validation that the connector has been properly installed at the end of a service event, which removes another source of failures in our cars. Obviously, the mass and volume savings are also significant, which is super helpful. At Tesla, we're always trying to improve every single component in the car, and a nice example of that is the 15-inch display that was originally shipped in the 2017 Model 3. Over time, the cost of the display has gone down 24%. We've been able to reduce the weight by 12%, and we've reduced the power by 33%. At the same time, we've increased the brightness of the display by 50% and improved the color accuracy. So this is one of our favorite things at Tesla, is to make a component cheaper and better. At Tesla, the drive to improve efficiency in the car is never ending. I think of it as like peeling a carrot. You just take a swipe at it, a little bit falls off, doesn't really make much of a difference. But if you just keep at it, over time, it accumulates into a pretty significant improvement. One of the changes that we're looking to make right now is to change something that's been steady for the last 60 years, 12 volts. 12 volts has been, as I said, for 60 years. The demand for power in the car has been steadily increasing to the point where we now have to have pretty large wires to drive over 200 amps of current around the car, which increases the mass and cost. With Cybertruck and all future Tesla platforms, we will be moving to 48 volts. This reduces the current needed by a factor of 4. And since power loss in the harness is resistance times the square of the current, a 4x reduction in current leads to a 16x reduction in lost power while distributing energy in the car. That allows for smaller wires, smaller E-fuses, and smaller controllers. It also allows us to make those heat sinks smaller, or in many cases, remove it completely, all benefiting the car in terms of mass and weight. 48 volts is the future for low voltage design at Tesla, and likely the rest of the industry in due course.
We welcome and encourage other OEMs and the entire supplier network to join us on this evolution.
You bet. The number of wires in the car is driven by the number of endpoints that need to be powered and controlled. In the past, centralized control has led for wires spanning the entire car. For Cybertruck design, we have moved to a local controller where the wire is connected to the nearest controller, and those controllers are connected over Ethernet. Wires are routed to the nearest controller where the data is converted into a network packet for transmission to the correct location in the car. To be effective, the network must be reliable, have low latency, and low jitter, and these are all attributes that we've been able to achieve with the current design. The design has eliminated most of the cross-car wires in Cybertruck, and with the next-gen platform, we're going to finish the job and eliminate all of them.
This consolidated vehicle network allows us also to make a whole lot more dynamic changes on the fly to how components in the vehicle talk to each other, rather than the traditional approach of separate CAN buses that are spread throughout the vehicle and fixed in hardware.
And one of the nice things is that you can see the entire vehicle through a single connection, which wasn't possible in the past for debug. For the next-gen platform, we're looking to optimize the controller design across the entire car and across all of the organizations, not just for a given subsystem. Simplifying the wire harness will enable automation. 48 volts will allow us to reduce the size, mass, and cost of the low-voltage system, and it's one of the key things to enabling us to scale production of the low-voltage systems for the Master Plan 3. David?
Cool. So I joined Tesla in 2012, and even in those very early days of the Model S, we already had the ability to update software over the air in all of the controllers throughout the entire vehicle, at a time when other cars were just starting to update software in only their infotainment units. And furthermore, we've had sophisticated, anonymized data logging and telemetry capabilities that allow us to understand how the fleet is doing, what customers are doing with it, and how it's responding in the field to that usage. These two capabilities combined, OTA updates and data insights, give us the ability to iterate quickly on our software and to maximize the amount that we learn and proceed and the progress that we make in every one of those iterations. We've used these capabilities to inform countless design decisions in both software and hardware.
Yeah, one example is that we were able to monitor and track the use of the sunroof in our cars and found that our customers never use their sunroof, so we made this easy decision to remove it.
Very barely, yeah. We haven't had sunroofs for a while. As another example, we are able to use our collision data to design our crash safety systems for what happens in the real world, far beyond what regulatory and consumer ratings tests prescribe. And then furthermore, we're able to use that data to recreate in simulation all of those crashes every single time we make a change to the vehicle's design or to the software that controls the airbags and other restraint systems. Here on this graph, the gray dots that show up first are specific crash tests that are prescribed by regulatory and consumer ratings agencies throughout the whole world. And the rest of the color that fills in around and on top of it, those represent the crashes that we've seen happen in the real world. Those are what we design for and what we test to.
Right. And last year, this data was used to change the algorithm for seatbelt tensioning to reduce injuries in the field, which was OTA to all of our cars.
Here are a few statistics that demonstrate how staggeringly quickly we gain new insights from the anonymized data that we've received from the fleet every day. Every day, 123 million miles driven, 1.9 million charge sessions, and those rates are only increasing as we deliver more and more cars into the world. As another example, we've analyzed patterns in the way the fleet drives and charges to optimally size battery packs for our next generations of vehicles. And you'll hear lots of other examples throughout the rest of the day about how we're using data to inform decisions in the product and in manufacturing. So you've heard a lot from Pete, Colin, and others about how important vertical integration is for us in hardware, but it's especially important for us in software. And this is extremely difficult from the way the rest of the traditional automotive supply chain is set up. In most situations, all the controllers in the car are delivered by different Tier 1 suppliers, whose software is written by Tier 2 suppliers, who farm some of that software out to different Tier 3 suppliers, and so on and so on. Making a change that spans multiple components takes months of coordination before any work can even start. And furthermore, integration of software in the server side with what's happening in our vehicles has always been a core part of our DNA and enables us to do things that nobody else can. Most engineers think about the vehicle as a complete, consolidated, fully contained system. But in the software team, we think about the system as including the vehicle as well as all of our back-end server-side applications and infrastructure and the resultant feedback loop from the entire fleet that informs all the decisions we make as an engineering team. For example, we recently released a feature in Model S and X that automatically, predictively adjusts and raises the suspension for ride comfort before the car hits a section of rough road. We do that by leveraging the fleet to generate a map of road roughness everywhere our cars drive. Sounds pretty simple, but requires coordination of software across a number of different components inside and outside of the car. The restraint control module, whose inertial measurement unit senses the road roughness, the autopilot computer, whose GPS module and localizer figure out where the car is in the world, our navigation server, which aggregates the anonymized telemetry from the fleet and annotates our map with things like updated speed limits, lane topology, and now, road roughness. The onboard navigation engine, which looks ahead of the route that the car is traveling on and determines whether things are about to get rough. And finally, the air suspension controller, which takes all of those factors into account and decides continuously whether it is appropriate to adjust the suspension for ride comfort. And before we released this feature to the world, we sent prototype versions of it to the entire fleet that ran passively in the background, sending us anonymous data about every time it would have engaged, which taught us exactly how it was going to behave in the wild, in every environment, in every circumstance.
Yeah, being able to test new algorithms in the background without impacting the car is really critical ability for us, especially for safety critical things like automatic emergency braking.
And we've used it to iterate on early versions of our stability control algorithms, which were introduced to the entire Model 3 fleet in 2017 with extremely high confidence, even on a very foundational and safety critical function. Okay, so far you've heard me talk a lot about how we leverage our software systems to iterate quickly on the customer-facing product. But what I haven't talked about, and what we haven't said much about publicly in general, is how we leverage these capabilities in our own internal operations. So for example, in the early days of manufacturing Model S, we very quickly realized that there are a lot of different ways you could misassemble a car. You could forget to plug in a wire, you could not fully set a connector, you could pull a part from the wrong bin. So when we designed our manufacturing processes for Model 3 and all of our other vehicles going forward, we took a page from the software playbook, which says, test early and test often. And we applied that mantra to every single car that we build at every step of the assembly line. So now, when a production associate plugs something into the car, the central car computer sees that connection, confirms that it's the correct part for the type of car that's supposed to be built, installs a software update if necessary, checks configurations and calibrations, and runs a barrage of tests on that thing and all the other things that are connected to it. And if it finds an anomaly that can't be fixed purely with software, it throws an alert immediately that is displayed prominently on the vehicle's display, as well as sent to back-end command and control systems, so that a human can come over and fix the problem before the rest of the car gets built on top of it. And we're taking a similar approach in service through a combination of onboard vehicle diagnostics, natural language processing applied to customer narratives when a customer schedules a service appointment, and a suite of internally developed tools. We are successfully diagnosing, scheduling, and ordering parts for over 33% of customer concerns in service.
Yep, and we also use testers built around our own controllers to test sub-assemblies before they get to the car, which will be even more important as we go to Lars's unboxed assembly strategy.
100%. We'll know with extremely high confidence that before those boxes get put together, that they are assembled, they themselves are assembled correctly. Okay. You've heard at lots of other events about all the awesome things that our autopilot and AI teams are doing to make the car drive itself, bringing us into the future of autonomy. But we've also been thinking for years about all of the other pieces that we are going to need to manage a network of autonomous vehicles. A lot of this has been happening behind the scenes in the form of platform-level functionality that we'll leverage later. But you've seen some of it surface already in terms of features that our customers and our internal operations teams can benefit from. Like in 2021, we built on top of our mobile app phone key and gave our customers the ability to share their car with anyone by sending them an invitation in a text message or an email. Last year, we introduced profile synchronization, which synchronizes your seat, steering, and mirror positions, as well as your settings, media favorites, and stored navigation locations across all vehicles in your account. Internally, we have an app that allows our personnel in engineering, manufacturing, delivery, and logistics to view, locate, and drive all Tesla-owned vehicles at their site. And when customers bring their car into service, when they receive a Tesla-owned service loaner vehicle, we are starting at some locations to automatically add that vehicle to the customer's mobile app account, so that combined with cloud-synchronized profiles and phone key, it's a completely seamless experience. As soon as the customer walks up to that loaner, it behaves and feels exactly like their own car. And all this is built on top of end-to-end encryption and cryptographically signed commands, so that customer data remains private and obscure, and the fleet only trusts commands from authorized parties. So that's a bit of a preview of all the pieces that we're building, looking ahead to our future of autonomous fleets. Synchronization, permissions management, security, and privacy. And that has been a whirlwind tour through some of the things that we're doing behind the scenes to enable the efficiency, cost reduction, and speed that we are going to need for our next phase of growth and for the next phase of the master plan. And so now, to tell us about the latest in full self-driving, I'd like to introduce Ashok.
Thanks, David and Pete. Hey, everyone. My name is Ashok Kelliswamy. I work on autopilot and self-driving at Tesla. I joined Tesla back in 2014, so I've been working on this problem for almost 9 years now. Yeah, some of you might be wondering, hey, what does this self-driving got to do with the plan to a sustainable future? But it's actually a critical part of this plan, and here's why. Currently, when the car is not being used, it is sitting idly in parking lots, not doing anything. But when autonomy is truly unlocked, this car, instead of being idle, can go serve other customers. This fundamentally now reduces the need to scale manufacturing to extreme levels, because each car is being used way more. But this is no trivial problem. Building a scalable self-driving system is, I think, one of the hardest real-world AI problems out there right now. Nonetheless, we at Tesla have made significant strides in making one of the most general systems at solving this problem. There are three main parts to get right to build a scalable problem. First is the architecture of the AI system. Second is the data. And third is the compute. We'll start with the architecture. At Tesla, we are betting on AI, machine learning, neural networks to help us build a general vision and planning system. In the early days, we used to have single camera, single frame neural networks that produced some outputs. These were stitched together in some post-processing steps for the planner. But this was very brittle and was not leading to great success. So what we did in the last few years is transition most of our stack into this multi-camera video neural networks. These neural networks take in the live feed from the car in real time of the 8 cameras in the car and produce a single unified 3D output space. There are many tasks that we produce, such as the presence of obstacles, their motion, lanes, roads, traffic lights, what have you. And this is one example output that you're seeing here. This is from our occupancy network that predicts the positions of obstacles and their motion. You can see that it precisely captures the swervy, violent motion of this truck next to us. And this helps the planning system to avoid a collision with this object. Some of the tasks, such as lane connectivity, are more complicated to model using naive methods in computer vision. So we don't stop at the computer vision techniques, but we reach out to techniques in other areas, such as language modeling, reinforcement learning, to model this task. This is similar. These networks use similar techniques, such as transformers, attention modules, autoregressive modeling of tokens, similar to what large language models like ChatGPT do out there. With such an end-to-end system of solving perception, we have really removed the brittle post-processing steps and produced high-quality outputs for the planning system. Even the planning system is not stuck in the old ways. It is now starting to use more and more AI systems to solve this problem. The neural network-based planners are needed especially in complicated urban planning when there's a lot of other objects interacting with us. This is, for example, an intersection where we have to turn left while yielding to crossing objects and to the pedestrians crossing the road. We have to do this both safely and smoothly while respecting everyone's right of way and preferences. If this was done naively, each configuration would take 10 milliseconds of compute, and there are easily thousands of configurations to reason about. This would not be feasible using traditional compute. But using AI, we have packaged all of this into a 50 millisecond compute budget so it can run in real time. The second big piece of this puzzle is the data. This is where Tesla has a unique advantage because it can tap into the fleet to access the exact data that can fix the problems. But raw data is not sufficient. In order to train these networks, you need labeled data. You need labels to supervise the networks. And if you only depended on the human labelers, this data would be too tiny to train these large multi-camera video modules. We need lots and lots of data to train these networks. Hence, we have built a sophisticated auto-labeling pipeline that collects data from the fleet, runs computational algorithms in our data center, and then produces the labels to train these networks. Here, you are seeing a 3D reconstruction that is happening by collecting various clips from different cars in the fleet and assembling them, all of them together into a single unified representation of the world around the car. You can see all the lanes, the road boundaries, curb, crosswalks, even the text on the road being accurately reconstructed by these algorithms. We don't have to stop at this kind of reconstruction. Once we have this base reconstruction, we can build various simulations on top of it to produce an infinite variety of data to train for all the corner cases. We have a capable simulator that can synthesize adversarial weather, lighting conditions, and even the motion of other objects to test all the corner cases that might even be rare in the real world. Here's an example of why this data is critical and how we can solve problems using data. So back in the days, for example, in this case, we had some false braking where we thought this car that's actually parked there was going to move into our path, and hence we were precautiously braking. But it is unnecessary because the car is truly parked. So how can we solve this? What we did was we mined the fleet for similar cases where the car had false braking due to some parked car. We added 14,000 videos to our training set. And then once we train the networks again with this new data, it now correctly understands that, OK, there is no driver in this car, hence it must be parked, so then there is no need to brake. And this is a systematic way to solve problems. On the chart on the right side, you can see that every time we add data, the performance improves. And then we can do this for every kind of task that we have in our system. And this is what we call as data engine. We identify challenging cases, such as the one you saw earlier. And there could be other different types of challenging cases, too. We mine the fleet for such data, put it through our auto-labeling system, and produce the labels, add it to the training set. And once we have the newly trained models, we deploy them to the fleet. If we rinse and repeat this process, everything gets better and better. The final critical piece is the compute. In order to train these large models in a reasonable amount of time, you need lots of compute. In addition, compute is also required to produce the labels automatically. This is just compute in our data centers. In addition, we also have high computers in the car, which can run up to like 150 teraops of compute. On the back end, we have a 14,000 GPU cluster, and roughly 30% is used for auto-labeling, and the remaining 70% is used for training. We also have a 30 petabyte of video cache, and this is growing to 200 petabytes. All of this is going to significantly increase once we bring Dojo, which is our training computer, on board into this. Just to give a reference, just the occupancy networks that you saw earlier use 1.4 billion frames to train these networks. We have already shipped our FSD beta software to pretty much everyone that has bought it in United States and Canada. This amounts to roughly 400,000 customers who can turn it on anywhere, and then the car would attempt to drive to the destination. It's still supervised, but it can already handle turns, stop at traffic lights, yield with other objects, and generally get to the destination. We have observed that people who use FSD are already 5 to 6x safer than the US national average. Like I mentioned earlier, the solution to scalable FSD is getting the AI architecture, the data, and the compute just right. And we have assembled a world-class team to execute on this. We are pushing the frontier on these three items. And as we improve the safety, the reliability, and the comfort of our system, we can then unlock driverless operations, which then makes the car be used way more than what it is used right now. With that, I'd like to introduce Elon back on stage to give some more updates. Yeah, this next slide is video.
It's kind of weird seeing the arms and legs just separate. We have a whole lab full of arms and legs. worth bearing in mind that when we did AI Day, this version of Optimus didn't walk at all. So the rate of improvement here, I think, is quite significant. It's obviously not doing parkour, but it is walking around, and we have multiple copies, I suppose, of Optimus. The thing that I think Tesla brings to the table that others don't have is that we have the real-world AI. We're the most advanced in real-world AI. So the same AI that drives the car, which you can think of the car really as a robot on wheels, and this is a robot on legs. So as we solve real-world AI, and I don't think there's anyone even close to Tesla on solving real-world AI. That same computer and software goes into Optimus. So it's not that helpful to have a humanoid robot if you have to program every individual action. It needs to be able to walk around autonomously and solve tasks. You should be able to instruct it in simple things by showing visually what the robot needs to do, or just telling it what to do. So I think that's a key advantage that we have. And then we also are good at designing things for manufacturing and then manufacturing itself. So the actuators in Optimus are all custom designed Tesla actuators. So we designed the electric motor, the gearbox, the power electronics, obviously the battery pack, and everything else that goes into Optimus. We were quite surprised to find how little was available off the shelf. Because there's a vast number of electric motors, gearboxes and whatnot, that are available in the world. And we found none of them were useful in a humanoid robot, literally none. So you have to custom design the actuators for a humanoid robot. And so the same team that designed the groundbreaking electric motors that are in, say, the Model S Plaid, designed the actuators in the robot. So, I mean, for practical purposes, what this means is that we should be able to bring an actual product to market at scale that is useful far faster than anyone else. And assuming that the things I'm saying are true, or at least you can put it, I think they are true. It's just a question of the timing. You start getting into interesting questions of what's the ratio of humans to humanoid robots? I think it might be greater than 1-to-1. Because you could sort of see a home use for robots, certainly industrial uses for robots, humanoid robots. I think we might exceed a 1-to-1 ratio of humanoid robots to humans. It's not even clear what an economy means at that point. Since an economy is output per person times persons, but if output is much higher and there's no limit on persons, then what's the actual limit on the economy? We're still pretty far from Kardashev scales here, but we're getting there. So anyway, it's probably the least understood or appreciated part of what we're doing at Tesla, but will probably be worth significantly more than the car side of things long term. So charging.
I think Rebecca's next for talking about charging.
Charge.
Thanks. Hi there. My name is Rebecca Tanucci, and I lead our charging infrastructure teams here at Tesla. And at Tesla Charging, we have understood since day one that a great charging experience is the linchpin to electric vehicle adoption. And that understanding has meant that we've always taken a holistic approach to charging. That's a word that you've heard a lot here today, but what it means for charging is that we've considered every use case. We think a lot about what it means to charge at home, even if that home is an apartment or condo. And we spend a lot of time thinking about what does it mean to charge away from home, including if that's for daily commuting or if you're going on a road trip. And this holistic approach has led to some pretty incredible results. In 2022, we provided 9 terawatt hours of charging across our various charging methods. Over 50% of that was supplied via convenient AC home charging. And when our customers are away from home, they can visit one of our 80,000 charging points. That includes 40,000 of our beloved superchargers. Now, getting here has meant that we've spent 10 years building charging infrastructure when basically no one else in the industry would do it. And while we certainly have a lot of areas that we want to improve, those 10 years have afforded us the opportunity to get pretty good at charging. First, we have the industry's lowest deployment costs. Our costs are often 20%, if not 70% lower than alternatives, and that goes for both our supercharging hardware and deployments and our AC charging product lines. A lot of reasons that we're able to achieve this, you've heard a lot of them here today. We're vertically integrated. We manufacture and engineer all of our own charging equipment. We share components across our different product lines. And on the supercharger side, we also install and operate all of our own sites. And that's led us to be pretty obsessed with finding new ways to innovate around installation. As an example, we have recently extended our excellence in manufacturing to how we build supercharger sites. We are pre-building 4-post supercharger units at our factory in New York. We load them on a truck, we truck them to site, and then we crane them into position. This method saves us 15% on our deployment costs, and we can install a site in a matter of days. Once we install a site, we also operate it really efficiently. Over the last few years, we've been able to cut our per kilowatt hour cost by 40%. Again, a lot of reasons for this, but one at the top of the list is we've focused on increasing our site utilization. Site utilization is just how many sessions or kilowatt hours can we push through a site or a post. And basically doing that allows us to spread our cost over more sessions, thus lower cost per kilowatt hour. But of course, that's easier said than done, because when we push up site efficiency, of course, the risk is that we have a poor customer experience and we have wait time at our sites. This is where Trip Planner comes in. Trip Planner is our in-vehicle routing or navigation system. Other electric vehicle manufacturers, well, some of them have vehicle-side data. Other infrastructure providers have site data. But at Tesla, we have both. And what that allows us to do is to use Trip Planner to route vehicles towards available sites and away from congested sites so we can balance our utilization without risking wait time. And the results speak for themselves. Over the last few years, we've been able to drive up site utilization by 30%. That means lower per kilowatt hour cost, while also cutting our wait time in half. And we think this can get even better. Today, we're feeding Trip Planner with real-time site information and information about vehicles currently at sites. Going forward, we'll be moving that to projecting site occupancy based on the understanding of what vehicles are currently routing to those sites. And ultimately, our vision for Trip Planner is that it's the air traffic controller for electric vehicle charging across all infrastructure on a global basis. And the last thing we focused on to get here is quicker charge times. We're really proud of what we've been able to accomplish here. We've shaved off 30% of our charge time, average supercharging site time, visit time, over the last few years. This has taken improvements on the hardware side, with our software, on our vehicles, and on our infrastructure, and we're really excited to continue pushing this trend down. Looking forward, the job does not get any easier. As you heard earlier, we aspire to a fully electrified global fleet. That fleet, from an industry standpoint, needs 9 petawatt hours of charging on an annual basis. And while Tesla charging certainly doesn't have to supply all of that, it does require that, for our part, we have a few new focuses in order to scale. First, if you want a fully electrified global fleet, all of those vehicles have to have a great and reliable charging experience. So as many of you know, recently we have started opening up our networks on a global basis. Over 50% of our superchargers in Europe are currently open to other electric vehicles. We've also opened up in Asia Pacific with our first sites in Australia. And just yesterday, we opened our first 10 supercharger sites here in North America and the US to other electric vehicles. We've also invested a lot to be able to make this a really easy experience for our new customers. All you have to do is sign into our Tesla app to unlock a post and start charging. We've also, on physical site changes, we've also added hardware to our sites. They're called Magic Docks. And basically, that is installed in areas where we have different charging standards, and they allow for other electric vehicles to come to our site without having to bring their own adapters or hardware. We've also just started installing our 4th generation supercharger posts. Those are being installed in Europe first. And while it's not a big mention, not a big thing to mention, they do have longer charging cables so that we can more easily reach the charge ports of different vehicles. The second thing we need to make sure we do when we talk about scaling all of this charging infrastructure is we need to make sure that it's powered from renewable sources. We're very proud that over the last 2 years, we've procured enough renewable energy to offset the amount of charging we've provided to customers. But as we look forward and we talk about this fully electrified fleet on a global basis, we really want to make sure that the demand for charging more closely follows when renewable sources are available. Now, this chart is on an aggregate basis for the US, and it varies based on what your renewable generation sources are locally. But basically, what this shows is we want to kind of move that charging curve, and for solar and wind in this example, it means more daytime charging. And we think the best way to go towards daytime charging is to install AC charging that is convenient and low cost everywhere vehicles are typically parked throughout the day. So that's really the plan. While supercharging and home charging definitely stay a big part of the puzzle, our teams are currently scaling to install AC charging everywhere vehicles charge during the day so we can power them from renewable sources. So summing it up, while we've spent 10 years installing infrastructure that is low cost, it's efficient, and it provides a great customer experience, we're really just getting started when we talk about supporting Master Plan Part 3. We've got to scale capacity on an industry-wide basis to 9 petawatt hours on an annual basis. We've got to open up to non-Teslas and make the charging experience for everybody really great, and we've got to power all of this via renewable sources. And one more thing, yes, we've got to scale our infrastructure, and yes, we want to power it via renewable sources, but we're Tesla, so we also want to make sure that we're continuing to focus on providing really incredible charging experiences. With that, I want to welcome up our leaders of supply chain, Roshan and Karn, to talk a little bit about that topic.
Thanks, Rebecca. Thanks, Rebecca. Hi, my name is Karn, and my team leads supply chain for electronics, powertrain, and battery at Tesla. And we've also got responsibility for indirect purchasing, construction procurement, and warehousing and distribution.
Hi, my name is Roshan. I've been with Tesla for over 14 years. My team manages vehicle commodities, solar, logistics, planning, and capital equipment.
10 years, forgot that. So today we wanted to provide you a quick overview of Tesla's supply chain and what really separates us from the typical automotive supply chain. As you've seen in presentations prior from Pete and Drew and some others, Tesla designs a lot of the subcomponents that go into our vehicles. So we're not buying things that are off the shelf from suppliers. So supply chain is not purely a commercial relationship as it is in most other companies. We actually have an arm within supply chain called Supply Industrialization Engineering. And the burden of taking a drawing, a design from concept and turning it into thousands of products produced at the right cost and at the right yield falls with this group. Of course, they work very closely with design engineering. But really, the level of detail that our engineers get involved in terms of building the capability of the suppliers is pretty detailed. So, once we get a new part, naturally, with electric vehicles, a lot of the supply chain doesn't exist. Our engineers would basically take the drawing, turn it into a manufacturing concept, do the equipment selection, and physically go to the supplier and stay there for weeks or months, however long it takes, to basically do the line bring up. Once the line is brought up and we're hitting the right rate, the right quality, at the right yield, then we work on things like automation and yield improvement and those types of activities. So there's a big group of mechanical, electrical, industrial, you name it, engineers within supply chain, and it's their responsibility to take care of this. Now, this is a huge strategic advantage because we manage every detail of our supply chain, because we're so integrated with our partners that we know about issues before they happen. It's almost live. We've got dashboards, we've got connections, and across the 10,000 or so factories across the world that are making our components, we have a pretty good view of the health of those suppliers, and this has been a key asset in how we've been able to kind of manage things through a lot of different issues over the past couple of years. So, supply chain is a game of perfection. Perfection is a passing grade. It's like if one part doesn't show up, that line goes down, and our CEO finds out about it in less than 20 minutes. Tesla is very different than Apple. They outsource manufacturing, we do it in-house. So supply chain is kind of right in the middle. And perfection is increasingly elusive and very expensive if you kind of look at all the issues we've had to encounter over the past year. And today we're just going to talk about how we got through the past, and then what are we going to do going forward, and how are we going to get there. So let me draw your attention to this slide. On the left, you'll see a portfolio, our existing portfolio of products. Right? At the top, you've got the S and X platform. In the middle, you've got the 3 and Y. I think everyone's more than familiar with those. And then the Tesla Energy platform, which is a very high rate of growth for us. And
don't forget the solar and superchargers.
And solar and supercharger. Thank you, Roshan. And you'll see a reduction in. So, and then we basically got the tier 1 and tier 2 parts. This might be boring, but a tier 1 supplier is any supplier that builds and supplies parts directly for consumption in our 5 factories. And our tier 2 supplier basically does the same thing for a tier 1 supplier. So they are the supplier to our supplier. And depending on the supply chain of any one of these products, this can actually go down to the tier 6 level. So for example, if you're talking about the battery cell, we really get involved with the mines of like where we're procuring the lithium, the cobalt, and all that sort of stuff, because we're procuring such high volumes of it. So you'll see a reduction in the number of parts on the S and X platform to the 3 and Y platform. And this is because of the great work our design engineers have done of making the car simpler and easier to manufacture. In parallel, we actually had a similar strategy in supply chain. We had cast a wide net to a lot of suppliers for the S and X platform. There was a lot of suppliers that we invited to partner with us. And we used that platform as sort of a filter to see which suppliers have the technical, financial, and cultural capabilities to match us, right? Who do we invite to the party when we really scale things up? And we really dramatically reduced the number of suppliers that we were dealing with for the 3 and Y platform. And this is an approach we'll continue to do for future platforms as they come along that are even more high volume. So this has really been our approach. It's made things a lot easier, and we could figure out the suppliers that were capable of moving at our pace, and then the ones that didn't have the desire to or the capability to. You need both desire and capability. Secondly, the complexity on the tier 2 level is very high, right? These are the suppliers to our suppliers, and there are a lot of components. So think about silicon, think about resistors, capacitors, diodes, all the little assemblies.
All the raw materials.
Raw materials, that's even further down.
Yeah.
But all these little sub-assemblies that have to come into Tesla, the complexity is immense. So even though at the tier 1 level we're talking about 8,000 parts total, it seems like a lot, but it's not a lot. The management of the tier 2 is really where we excel. And I'd like to illustrate that with an example. Meet the car computer. Very innocent sounding name, and it's anything but. This is an absolute monster to manage. So I think you've all seen the picture on the left of the autopilot board. That's the top of the autopilot board. The autopilot board also has a bottom, and the bottom is populated heavily with components. On the other side of the heatsink, you've got the MCU, the multimedia cluster board. This board is equally complex. It's also double-sided, 8-layered. And these boards, these computers run so hot at peak operation that they have to be liquid-cooled through a heatsink. So this assembly requires taking those two boards and then bonding them to a heatsink that's hermetically sealed as an assembly, of course, flashing the software and all that sort of stuff. And then that's one part number that comes to Tesla. So this is an example of one tier 1 part number that's a very complex assembly to manage at the tier 2 level. And there's more than 7,000 components here. There's as we stand here, a component's being assembled onto a car computer every 1.4 milliseconds. The line that builds this computer is the length of a football field. So it's quite complicated. And initially, when we first started building this board, due to the complexity of it, we had to rely heavily on labor. But once we dialed in the quality, the rates, and the yield, we started focusing on making this more efficient. The only way to control cost is by removing labor. The first step is removing labor. The second step is fully automating. The third step is turning off the lights and letting the factory run, ideally. And that's going to be the goal for us here. So 95%, but our work is not done. We're going to be going a lot further than this. So this illustrates the point that a part is not a part. A part has a lot of complexity underneath it. Supply chain is a game of multiple tiers. And what's made us successful is our involvement in all the details with our supply engineers that are Tesla employees. They're Tesla supply engineers. So they're like on our payroll that go and ramp up these capabilities at our suppliers. And then just managing each and every attribute of it. 7,000 a day through the chip shortage, through the pandemic, through all the other stuff that we had to deal with, was very difficult to manage. But because we had all the details, we were able to pull this off. Of course, supply chain is not just about parts. It's also about logistics and a lot of other things. So I'll hand it off to Roshan for sharing some stats.
Yeah, so talking about inbound complexity, just over the course of just last year, we moved about 16 million pallets from our suppliers to our factories. Just to visualize that, if you put those pallets side by side, it could cover the half the circumference of the Earth. And talking about, again, the tier 2 complexity, over 1 billion electronic components get moved every week to support the production that Karn and team manages.
This is right now, 1 billion components a week.
Right.
52 billion a year. This is going to go up, by the way.
And on top of that, we also have the responsibility to make sure the right component is supplied to the right service location to support the growing fleet of our vehicles. And we have about 685 service centers that these components need to show up just in time. And then we've also been, as a result of pandemic and even before that, we're working on dual sourcing and triple sourcing some of our critical components. As a result of it, we have suppliers around 45 countries in the world.
Yeah, our approach really has been to bring the manufacturing of subcomponents closer to the point of consumption. It makes the supply chain more green because you're not burning diesel, moving stuff around. And it also gives us the security of supply of having multiple sources in case one factory gets taken offline.
And that's how we got through pandemic also.
Yep.
So last 3 years were incredibly hard. Karn and I used to look a lot younger pre-COVID. But on a serious note, pandemic really changed the game of supply chain management. We were just not being a regular supply chain person. We were rolling up our sleeves and negotiating with state governments, city managers, mayors to help kickstart our suppliers to restart their operations. There are some really inspiring stories where our supply chain team really fought hard to make sure that the factories don't go down. And it's also a testament to the resilience of our supply partners. Having said that, it was not all about resilience and never give up attitude. We had also laid the foundation of having dual sources, and also, in many instances, we had many, things that we had simplified, the parts that we had simplified, the supply chain design that we had simplified, due to which we were able to get through the pandemic in much better shape than rest of the automotive.
It forced us to adapt. You know,
Right.
we encountered issues one at a time. It was really a team effort. We heavily relied on the government relations team. You literally had to, the COVID pandemic, as you're aware, happened in different countries at different times. But unfortunately, you need all the parts to make the car. So at any given point, there was one factory that was lying down. There was
Right.
one jurisdiction that was being, that didn't want to. They wanted to shut down a factory because you had an outbreak. So learning the rules, understanding, coming up with argument points, leveraging the team, and getting those. It was a difficult but good experience.
Exactly.
We learned a lot.
Yeah, and as we were just figuring out to work with COVID, then the port congestion hit on the West Coast. Logistics lead time went up by twice the amount, and we were operating with less than 35% accuracy in the system. That means at any given point, the ETAs of the vessels were 75% off. So we figured out how to work with that, and then the chip shortage hits.
Yeah, the chip shortage. That was a nightmare. But we got through it. I mean, I think it's a testament to the tenacity of the team and the resilience of our supplier partners. It's mostly behind us, and I think the results speak for themselves. Tesla was able to grow production volumes at a time where the rest of the industry had a hard time staying flat. I think they shrunk, actually, cumulatively. And we're often asked the question, how do we manage through it? And the answer is very much kind of baked through the presentations today. First, we design our own electronics. So in order to control cost, we really had to go and build relationships with all the tier 2 suppliers to negotiate them directly. So these relationships were formed, over 10 years ago, and we've really gotten to know them well. So when a shortage hit, we knew, who to escalate to, who to call, who to ask for help, and really kind of swarming the issue at the point of constraint. So the best team, strong relationships with vendors, and then we also have a pretty sophisticated capacity planning function. Tier 2 capacity needs to come on earlier than Tier 1 capacity. Tier 3 capacity has to be even earlier. And our team does a very good job of having that strategic alignment with all our partners to make sure that the capacity is ready before we need it. We're a mission-based company. Our goal is to put as many EVs out there. We did not let the pandemic phase us. We were full throttle. And it was pedal to the metal in terms of our demand signal. That also helped. The silicon industry has very long lead times. They invest billions of dollars in sophisticated fabs that take years to build. So that stability and demand is something they appreciated, and it's something that is very, very much a Tesla thing. So this was looking back, right? This is how we got here. This is how we got from 0 to 40,000 cars a week. Let's talk about how we get to 20 million. So the question gets asked, is Tesla going to basically break the chip industry if we grow to 20 million vehicles? The answer is no. But let me walk you through our logic on that. So as it stands right now, a Tesla enabled with a full self-driving computer has 4 times the silicon content of a regular vehicle. So at about the 2 million run rate, we're consuming about 700,000 12-inch wafer equivalents. That's the industry term that's thrown around for capacity in silicon. That's how much we're using, so a little bit below 1 million. And the global wafer capacity, based on the estimates we've seen, is about 135 million. So we're about 0.5% off the industry. Not a lot. Now, if you get to 20 million, when we get to 20 million, and if we don't make any simplifications in terms of part count, which is also a separate work stream, I think Colin talked about it, Pete talked about it, we're not going to have all these different components. We're really going to simplify the architecture because simpler is better. But even if we don't do that, and we take the most pessimistic case, we're going to need 8 million wafers, okay? And the industry is going to scale to 200 million by that point. So still, we're less than 5% of the market share. And if we run the same offense we ran all along and continue to work with our partners and invest in fabs and invest in capacity, we'll have the capacity ready by the time we need it. So I really don't see this as an impediment from a supply chain perspective to get to 20 million.
Now, I would like to talk about a page that we took out of the electronic playbook and applied it to the mechanical side. Our vehicles use currently the heat pump-based technology for the thermal system. But before heat pump, our vehicles used to have a dispersed thermal system connected by hoses. Engineering was inspired from circuit boards and then created a system which was extremely integrated, where 60% of the system was the size of a basketball, where it contained about 100 components, 50 sealing interfaces, and several different manufacturing processes, all were packaged into this tight size. Now, why are we talking about this? Well, we launched this system right during the outbreak of the pandemic in Model Y. The team was forced to manage 100+ components from different suppliers around the world remotely. So there are 4 videos playing at the same time. One is the video of the manual line that was created when we started the production. And this manual line produced a lot of quality issues, let alone throughput. So we quickly pivoted to a semi-automated line. But in spite of that, although the throughput was great, the quality issues sustained. So our team decided that fully automated is the only way to go. So before we automate the line, we created a 3D simulation. Now, not many companies or teams have this capability, where at this point, now when a part gets spec'd, we have the ability to create a 3D simulation of all the complex subassemblies that would be involved in making the part, and tell the suppliers exactly what equipment to purchase, what to test, and create an end-to-end line in simulation. And that's what we did here. So with the help of the simulation, we had a very detailed subassembly cell, which was juxtaposed with the supplier's factory layout. And then we, after a back and forth of iteration and optimizing the processes, we implemented this fully automated line in less than 8 months. And the results were remarkable. 99% reduction in labor force. So a line that would need 1,000 associates to build the super manifold in full volume now just takes 10 associates. And the quality also went up by an order of magnitude. We have a defect rate of less than 0.05%, and a super manifold rolls out every 7 seconds because we have created many automated lines. And these factories are the size of 2 football fields, by the way.
Roshan had to one-up me on that one. 99%, 2 football fields.
So why are we talking about this? In a world where labor costs are increasing, labor participation is decreasing, there is a huge turnover, and the cost of implementing automation is going down by 3x in the next 10 years. This is how we are thinking about complex assemblies, and we are going to push this type of thinking into our supply base more and more, who will be building our complex assemblies. This is the only way we think we can confidently scale to the 20 million vehicles target. To summarize, we have laid the foundation in getting ready to execute Master Plan 3. Our strategy is supply chain design simplification. We are going to make sure that we have more control into the tiers of the supply chain. We are going to grow responsibly and sustainably with our long-term partners, and we'll automate.
Yeah, it's like, going from 0 to 40,000 cars a week was tough. I mean, it took a lot of trial and error. It took a lot of learning. There was a lot of pain. There's a lot of mental scar tissue, as Elon calls it, through that process. But now that we're at that level and the foundation is set, going from 40 to 400 is not gonna. It doesn't really faze us. We have a capable team. We've got capable external partners that have gone through hell with us. Our leadership team is galvanized behind the mission, and we're gonna get it done. So I'd like to thank you for your time and hand it off to Drew and Tom for the next presentation. Thank you.
Hi, everyone. My name is Tom Drew. I'm now responsible for global production and sales and delivery service. I joined the company back in 2014, and I've been running the company's business in Greater China and APAC. Today, I'm representing all the Gigafactories and talk about how we can make more cars and faster. So right now, we have 4 vehicle factories on 3 continents to serve our markets. The total number of manufacturing employees is over 65,000. This is also including our amazing team in Rainey. They are making powertrains, battery packs, and drive unit for our vehicle factories. The total installed capacity in all these vehicle factories about 2 million cars a year. That said, we're always looking for opportunity to grow more capacity from the existing footprint. So you expect this number will grow over time. To build more factories is the start to building more cars, and we're certainly the expert of it. This is the before and after image showing you the progress we made back in 2019 when we built a Gigafactory in Shanghai. So in 9.5 months' time, we built a greenfield project to establish the vehicle factory. And 3 months later, we started to deliver our first customer vehicle. People always ask me, how Tesla can build a factory that fast. Really, we learned from our Fremont factory a lot. We talked to the survivor from the production hell and tried to avoid all the mistakes we made. We decided to design a straight line with the minimum number of up and downs and turns for easier manufacturability and easier construction. We also challenged all the assumptions that people ever know to build a vehicle factory. When we delete and simplified all the redundancies and the buffers, that's helped us to save a lot of time. Also, we have a very strong in-house construction team in Tesla. If there ever a job cannot be done by others better, and we bring this in-house. So we have this in-house construction team, have a full control over all the activities on site, from design, engineering to construction, site management. So this team didn't just build Giga Shanghai, they also built Giga Berlin, Giga Texas, and Giga Nevada, and they're really the hero behind the scenes. Like Lars shared earlier, going forward with the new platform, the more modular design and densified Gigafactory, we'll be able to make more cars from even reduce the footprint. And that also means we can build more factories at the same time. With the joint effort of all manufacturing teams around the globe, I'm happy to share, early this morning, we hit the 4 million mark for total Tesla ever built. And the 4 millionth vehicle actually built in this factory. When you took a tour on our shop floor, you probably walked past it. All right. So it took us 12 years to build the first million vehicle, and about 18 months to build the second million. The third million took us 11 months, and just shortly, less than 7 months, we built the 4 million cars. So we're getting better and faster.
Exponential growth.
Really kudos to the team. So what it takes to ramp a Gigafactory? Well, if you have 600 robots, 10,000 trained employees, or 5,000 human and 5,000 Optimus, and hundreds of processes, you can do it. Sounds simple, but it's extremely hard. So there's 2 key metrics that we predominantly focused on. It is the overall equipment effectiveness and the cycle time. In Tesla, we're setting the passing grade for our vehicle factories with 90% OEE and 45-second cycle time. What that means, the OEE really evaluates the equipment uptime, the machine performance, and the quality. Simply put, this is the actual production time on a good quality product versus the planned productive time. The higher, the better. The 45-second cycle time, that means you expect every 45 seconds there's a car running off the final assembly line in the factory. And the faster we ramp, the faster we can get the economy of scale. If you look at the chart on the left, Shanghai be able to significantly drop our labor hours per car during the ramp. The little dip there has happened in the last Q2 2022 because of the COVID shutdown. And on the right is the Fremont Model Y shop. Even this is a 6-year-old facility, the team there still be able to optimize the material flow, eliminate all the single point of failure, and drive higher output, hence reduce the labor hours. And actually, this factory keeps setting a new record. Yesterday, they just had a new factory daily record.
Congrats, Fremont team.
Absolutely. So, how can we reduce the cycle time, keep improving efficiency? We follow the philosophy Elon shared about building rockets, which is questioning, basically find the right problem to solve, and we start with delete, simplify, then we try to accelerate, pressurize the line, and find if the solution actually work. And at last, we think about the automation. There's one example in Gigafactory Shanghai. In the paint shop, we find that there's a overlap baking range between the PVC sealer and the top coat. It was done by 2 different ovens, and we decided to combine the 2 processes. Eventually, that helped us, didn't just help us to reduce the cycle time, but also save the 9% of energy consumption and the 9% of the CO2 emission. Also, we commonized the SNX design in Fremont. Right now, we have a common body and common headlamp. We eliminated about 40 parts and reduced about 10% of the cycle time. So all these improvements really help us to get to a faster ramp trajectory. And we didn't just learn from these high volume existing factories, we also learned from the new factories. Most recently, our Berlin factory team implemented a 5G private network on the shop floor, helped us to overcome about 90% of the overcycle issues for a particular process in GA shop. We're going to soon implement this globally. Right now, we have an integrated global organization from production all the way to sales and delivery service. This will help us to strengthen feedback loop between manufacturing and the service. We obviously want to bring a delightful customer ownership experience to our car owners. With this direct feedback loop, we be able to turn customer escalations and the feedback into quick actions, improvement on the shop floor immediately. With that effort, in the past 6 months, we'll be able to reduce the time in service and early ownership service, also service appointment wait time significantly. So, 4 factories, not enough. If we want to hit the 20 million car a year target, we're going to keep building new factories, new lines, and that will come up with new product as well. And with all Gigafactories now in one organization, we'll be able to replicate unified ideas across factories. Also, we will help the new factories that ramp faster and also produce a better quality at a lower cost. Now I'm going to hand over to Drew to talk about the cell manufacturing.
Thanks, Tom. Yeah, we're not just talking about new vehicle factories, but also new cell factories. And we're going to talk about how we follow the same model when we do so. But first, I thought I'd just provide a little bit of an update on cell production. So remember Battery Day, we showed this video with the spoon and how we went from dry powder to film. Let's just say there's no spoon now. So many of you in this room saw this on your tour today, but here is our dry electrode machine here in Texas, one of the lines we have installed here. Fully automated, no spoon, from powder and foil in to coated electrode out. From a peak productivity perspective, per tool perspective, this is over 20 times the productivity of the tools that we showed folks on the tour in Cato back in Battery Day. So we've made a lot of progress on one of the key parts of the cell manufacturing process. And we've also continued to focus on refining the way we make cells and the factories that the cells go inside. As you can see on this chart, from typical 2170 cylindrical cells to 4680, we made a huge leap, which is basically a 5x reduction in the factory footprint and volume volume and footprint. And then going from what we did in Fremont and our pilot line to Texas, we improved further, and we're improving again when we go into Nevada. And what this actually represents is a series of actions taken by a very integrated, holistic design team across the product design, the manufacturing design, the process design, the equipment design, and the facility design. They all need to work together to make this happen. And you can see on the bottom, just as an example of simplicity up, investment down, and scaling up. Parts, we've reduced the number of parts in the cell, the number of processes, significant reduction in the number of processes, and collaborating with those 5 design groups, we've been able to end up with a factory that's 10 times smaller volumetrically, which means it's faster to get built. It's much lower capex per gigawatt hour output, and we can go and scale, to our objectives of, 240 total terawatt hours, 1 terawatt hour a year of stationary storage and 20 million vehicles a year, with the scalability that is required to achieve our goals. And we're not just looking at the cell factory itself, but also upstream materials where necessary. What you see here is the rendering of the 50 gigawatt hour a year Corpus Christi lithium refinery that we've already broken ground on here in Texas. The facility will start commissioning by the end of 2023, this year. This is a good example of something where we're basically talking about breaking ground and starting commissioning within 10 months, and with actual production within 12 months. That's the target, similar to what we did in Shanghai. Again, the result of collaboration and internal execution of construction in partnership with local communities. This site is 30 minutes from the Corpus Christi port. It's located directly on rail. The process route we're taking is a direct soda ash leach of the input material, which means there's no acid roasting. We don't have any of the sort of waste products associated with an acid roasting step. We're designed to consume lithium spodumene, which is a very commonly traded lithium rock, but it is flexible to other feeds from primary and secondary sources. And similarly, we're working on our cathode facility here in Texas. Maybe you've seen it as you're driving around, which is a 60 gigawatt hour a year cathode facility behind the main building here. 10-month build time there as well. The equipment's being installed for the first line as we speak, and we'll be commissioning starting next quarter. So we are doing this where we need to. Our plan is not to do it always. There are lots of competent companies out there. But we are also trying to sort of accelerate the pace of the industry by trying some new things that are a little bit more scalable, and de-risking certain innovations that improve productivity in terms of capex per gigawatt hour and things like that. And with that, I think that sums up our efforts on the factory side. Mike, you want to come up and we'll talk about energy?
All right.
All right. Take it away.
All right.
Here, you can.
Hello, everyone. My name is Mike Snyder. I lead our Megapack organization. I've been with Tesla for almost 9 years. I'm excited to talk to you today about the Megapack product and the business and some of the exciting things we have ahead of us. From the beginning with this business, we have always focused on building successful projects for our customers, and not just the batteries in the box. We've built a hardware and a software platform that is able to adapt to environments all over the world, and that is able to scale from small island projects to large gigawatt-hour scale batteries. We've invested our time and our talent to best understand every aspect, every step in the process, and every risk of a project to ultimately provide a solution that is thoughtful, intuitive, provides great value to our customers, and is as plug-and-play as possible. And yeah, just looking at these projects, it's incredible to see them all come together in one montage.
Seeing the future.
Yeah.
Compressed.
It's 10 years of building these projects, and it's incredible to see the impact and to see what we have in front of us.
Absolutely.
We're on our 6th generation of our industrial product, which is the Megapack XL that we're building out of Lathrop, California. We've deployed over 16 gigawatt hours of industrial and residential products across 50 countries. And really, Megapack is a market leader. It's best in class in efficiency, reliability, energy density, and easiest to install, lowest cost to install.
And we call it XL because it is actually the largest, heaviest object that you can transfer around the roads of the world without having to shut them down and get crazy permits and things like this. So it is extra large, and there is not going to be an XXL. Let's just say it that way.
There's been incredible demand for the project or for the product. 2023 is going to be a great year. We have gigawatt-hour scale projects being built. The Lathrop factory continues to scale and ramp up, and there's new products on the near-term roadmap. So a lot to look forward to. How did we get here? Number one, a maniacal focus on all aspects of delivering stationary storage. What do we mean by that? What are some examples? As you see here, the Megapack enclosure, for one example, we designed the wireways directly into the base of the enclosure. So typically you need to install a bunch of conduits and cables under the ground. Now you can lift them up and install them directly into the base, increasing the speed of deployment and lowering the cost. Next, we see the batteries and the power electronics. And the power electronics is really the beauty and the elegance of the Megapack. So this is what converts the DC power to AC power on the grid. The brain is built directly into the product. It is able to connect to any grid in the world right out of the box. It allows all the Megapacks on a given site to work as one unit. And really, it's what makes it what it is. I think it's the most incredible feature of the Megapack. As you build out the full site, what we end up with is the most energy-dense solution on the market, upwards of 300 megawatt hours per acre. And just as a frame of reference, this solution is 2 times more power dense than a typical gas peaker plant. So this is the future. This is where we're going.
This is the product that retires the fossil fuels.
Yep.
One power plant at a time.
We talk about power electronics a little bit more. Tesla is a leader in power electronics. We've deployed over 1.4 terawatts across energy storage and vehicle. And we deliver more power electronics than the solar and the wind industry combined on a per annum basis.
And power electronics, it's hard to overstate how impactful they are. They are really the glue in the sustainable energy economy between generation, storage, and the end use. Those power electronics devices are switching, thousands of times per second, hundreds of thousands of times per second, to efficiently react to whatever is needed, either in the car or in the grid. And because they are so sort of software driven at their core, they can provide functionality that hasn't been available to the grid in the past. And it's one of the reasons why renewables and storage together are such a great solution.
Yeah. And one reason that we focus on power electronics and control so much is because of the impact that it has on the projects directly. So just as an example here, on the left, we have a firmware feature that we call virtual machine mode. And what virtual machine mode is it contributes to grid stability like a car's shock absorber that dampens oscillations or vibrations and keeps the ride smooth. So you can imagine if you don't dampen those vibrations, the vehicle could lose control or someone could get hurt. On the grid, you could have a blackout. We have one grid operator that's utilizing virtual machine mode and said they will not operate their grid at 100% renewables unless they have this feature, unless they have virtual machine mode working. Yeah, and they tried and it didn't work very well.
And why is it virtual machine mode? It's like synthetic inertia, where you turn the battery power plant into, through software, behaving like it's a giant spinning machine, literally, and that inertia stabilizes the grid.
Right.
But you don't need a giant spinning machine. You don't need a huge fossil fuel power plant or a giant hydro turbine. You can just have the battery do it. And you can program it to whatever you need at that part of the grid, or even have it be dynamically changing as the grid conditions change.
Right. And that's why we focus so much on it. We believe it's the future of how batteries are going to add value. It's going to be more about adding power stability, just as it is about energy.
Yep.
AutoBidder is another software feature I wanted to mention. AutoBidder is an autonomous energy trading platform that in its most basic sense is buying energy low and selling it high, and the owner can net the difference of that. But battery storage is actually very complex, needing upwards of hundreds or even thousands of decisions every 5 minutes. It's much more complex than a solar plant or a wind plant or a thermal battery or thermal generation plant. And it's mostly because of the versatility and the ability of the battery to provide so much value in different ways that these decisions need to be made in real time in order to optimize and get the most value out of the battery as it can. So there wasn't a solution that existed in the market, so we built one ourselves. In the markets we've deployed them in Australia, in Texas, and the UK, it has proven to be a market leader. We're continuing to invest in AutoBidder as we expand to new markets. Second point of how we got here, a relentless focus on speed of execution, and there's 2 points to be made here. First one is in building factories. What you're seeing here is a time lapse of the mega factory that was built in Lathrop. We took it from a JCPenney distribution center to a world-class manufacturing facility in less than 12 months, which is incredible. And really, the way that we did this is similar to what my colleagues have described. It's leveraging the vertical integration of Tesla. It's getting the vehicle manufacturing team in the same room as construction and engineering and making decisions quickly with all the stakeholders and decision makers. We're using the lessons learned from Lathrop as we speak, as we plan for our next factories. Second, it's about installing projects faster. I've mentioned this already, but plug and play is kind of at the core of what we're going for. Over the past 4 years, we've increased the installation speed by 4x, and we've reduced the total labor involved across both construction and manufacturing by 3x. We think that this is key to unlocking our ability to scale and our customers' ability to scale with us. We need to be laser focused on reducing that time from when the Megapack leaves the factory to when it is operational on the grid.
And it's not just about centralized storage, it's also about distributed storage, the future roadmap of well, at least here at Tesla. And maybe some of you know about this sort of retail plan we have here in Texas, and I just wanted to talk a little bit about how that all fits together. So Tesla Electric really unlocks the full value of distributed energy and storage products. So it enables our customers to become their own utility. The data on the page is from our South Australia virtual power plant, another Tesla Electric setup that we have. Over 2022, it's 5,000 customers that we have the data for. You can get a sense for what's happening. So just if they were being provided default utility service and you looked at the cost of serving them that electricity, on average, $140 a month. If they all had solar and Powerwall, but the solar and Powerwall wasn't interacting with the grid, wasn't participating in the energy market, the cost of serving that customer would go from $140 a month to $70 a month. If Tesla Electric is operating those assets in an intelligent way to benefit the grid, Tesla Electric being basically a software that we developed out of AutoBidder for the purposes of these distributed energy resources, we can actually pay the customers to bring their energy services to the grid. That's what happened in Australia last year. And Australia is a little bit of a special case. They represent the future, South Australia in particular. Solar and wind supplied 70% of South Australia's energy in 2022. That compares to 30% in Texas and 35% in California. But this is an indication of where this is all headed, of both centralized and distributed storage resources providing the key to unlocking fully renewable grids. And Tesla Electric is the retail plan that we're using to bring that to bear for our customers that have our products. And this is how we're rolling it out. First, as it exists, it's available in Texas for people who have Powerwalls in their homes. But we need to extend beyond that. Over 1 billion people live in markets with competitive retail electricity. And there's over $2 trillion in annual energy spend in these markets. This is a huge opportunity. And our intention is to bring this to market by market in the same way that we've approached Tesla Insurance, where we can bring value to our customers to reduce their total cost of ownership of our products. So actually what we're going to do next, and this is pretty exciting here in Texas, by this summer, we're going to offer a retail electricity plan to people who have our cars where they can have unlimited overnight home charging for $30 a month. This is part of reducing the total cost of ownership of our vehicles. And the reason why we can do this is because Texas has a ton of wind. And in Texas, the wind blows at night. So actually serving these customers with electricity at night for their cars is the best thing to do for everyone. And so this is a way to incentivize people to charge at home at night directly from renewable power. It's part of the grand master plan we talked about at the beginning. So we're very excited about this. And we do see this, similar to Tesla Insurance, as I said, as further reducing the total cost of ownership of electric vehicles. So putting this all together, We're really at the beginning of this massive ramp in energy storage deployment. And
yeah, reflecting back on the master plan, we talk about needing tens of terawatt hours of stationary storage. So we have our sights set on annual production rates of 1 terawatt hour, which is 25x our capacity at Lathrop. In the near term, we see really strong demand for the Megapack product, over 100 gigawatt hours per year in 2023, and growing by over 100 gigawatt hours per year over the next few years. So the demand is there, and naturally, as we continue to focus on cost and speed and value, the things that we've mentioned, it's clear we need to build more capacity and we need to ramp it quickly. So while the challenge is big, it's also a huge opportunity for Tesla. It's a huge opportunity for the Megapack business. And I'm excited to see the impact that it's going to make on our grid transition.
As am I.
Yeah.
All right.
All right. Thank you.
Thank you all. Yes. All right. And Lori, Brandon, come on up.
Hi, I'm Brandon with the legal team. Thank you, not just for coming, but being investors. Now, we have an active and engaged board and management team. We've met with you, and today is the culmination of that. We've heard you, which is why we're excited to share this Investor Day with you. Now, you will hear more from our board at the appropriate time, but for now, I'm excited to introduce Lori Shelby, who's going to discuss sustainability and our employees. Lori?
Thank you, Brandon. Hi, everyone. My name is Lori Shelby, and I lead the Environmental Health, Safety, Security, and Sustainability team. I've been with Tesla for 5.5 years. So I'm going to talk about Tesla's impact. And of course, that starts with our awesome team members. So you've heard a lot today about our amazing products, our process, our software. You've seen lots of numbers and lots of graphs. You've also heard a common theme, and that common theme is that Tesla's team is what drives our success and makes a difference. Whether you're in our factories, in our sales, service, and delivery centers, our warehouses, or in the field, you can see and you can feel the collaboration that's happening. And you also can see the pride that everyone has in working for Tesla. So before I go on, I want to give a big shout out and a thank you for our Tesla team globally. So let's. That was great. That was great. Thank you. So we are creating a lot of meaningful work through our jobs. We're a huge employer, and we're growing every day. We're at 129K. And more than half of our team works in vehicle manufacturing, and almost 60% of our team is based in the US. People want to join our mission, and we need to grow, and we need to hire the best people. Engineers want to work for Tesla. Look at number 1 and number 2, SpaceX and Tesla. In 2021, we got 3 million applicants. 3 million, that's incredible. And our culture at Tesla is anyone at any time can raise an idea or make an improvement suggestion across safety, people, cost, production, quality. Because we have a very simple process called Take Charge. And Take Charge is really employee engagement. And as take charges go up, as you can see in this graph, injuries go down. And you know why? People who do the work, the people who do the work know how to improve the work. Sustainability is everything. It's our mission. You've heard about it all day, part of our master plan. But at Tesla, we don't just tick boxes to meet a requirement. We really focus on the impact that our products and our software will deliver. In 2021, our customers avoided 8 8.4 million metric tons of greenhouse gas. That's equivalent to taking 1.7 million ICE vehicles off the road for a full year. Yes, yes. We're also focusing on doing really good work and driving sustainability into our operations. We have year-over-year reduction in our water use, in our waste, and we're growing and building a renewable energy program within our operations, just like supercharging, as you heard. So it's not just about our products, it's the way we make our products, both phases. Tesla, our company, is solving both sides of the clean energy equation. We've got the clean generation, the clean storage. We also have zero emission transport. As this slide shows, from 2012 to 2021, our products generated more energy that was consumed by all Tesla vehicles and our factories. It's amazing. Yeah, I like the claps. Yeah, I'll take claps. So, our vehicles use less emissions than gas-powered vehicles. Even in the worst case scenario, 100% coal grid, the Model 3 has less emissions than the average ICE car. And we're only gonna get better. You heard about that today. Every product we make is more efficient. Every factory we build is more sustainable. So it's only gonna get better and better. So as we build our zero emission future, we've been talking with our stakeholders, with our shareholders, about how do we improve our reporting framework. And we are aligning with the TCDF. So TCFD. So we're aligning with the TCFD, which I know many of you have been asking us about. I also want you to stay tuned because there's going to be much more coming in our impact report. So thank you all, and up next is Zach Kirkhorn. Thank you.
Thank you, Lori. All right, so this is our last section of our prepared remarks today. We'll kind of take what we've discussed today and summarize it at the corporate level for our financials. Maybe before I jump into the details here, we've never done an investor day as a company. We've never brought our leadership team out and asked them to talk about the things that they're working on. So, I feel very fortunate to be able to work alongside this group of people and support their teams. And I also just want to thank them, they're in a room in the back listening to this, for all of the work that they put into today and getting the company to where it is today. So thank you to the Tesla team. When we were preparing for today, folks were asking, well, Zach, what should we talk about? And really the only guidance we gave folks is, well, talk about the things that you're working on and talk about it in the context of the master plan. And what did almost everybody talk about today in great detail? All of the work that they're doing to take cost out. Because in this industry, in this business, you survive or you die based upon the ability to manage your costs. And so I'd like to talk about cost as well. If we look at our longest running scale production product, this is the Model 3. We reached 5,000 cars per week, which was our design capacity in mid-2018. And since then, we've taken 30% of cost out of this product. And there's 2 points I want to make about this. The first is that cost reduction, as you have heard throughout the course of the day, is deeply ingrained in our culture. And I think one of the most important reasons why we are here today as a company. The second point that I want to make is that when we're working on cost reduction, it's easy just to take cost out and make our products worse. But we have to take cost out and improve our products at the same time. This is the hard thing to do, but it's the necessary thing to do to continue to move forward. And if you look at a version of a Model 3 that we built today, and you compare it back to a Model 3 that we built in 2018, there's a long list of improvements that we put into the car while also taking cost out of the product. Cost reduction doesn't just come from one place. There's no silver bullet here. And we pushed the boundaries on volume with the Model 3 program, increasing volume 3x over this period of time. We've improved productivity. So in our Fremont factory, we are twice as productive now as we were in mid-2018. We've made a lot of progress on overhead efficiencies and product improvements, as we've discussed, and a long list of other things, including localization, our factory in Shanghai. And as we ramp up volume and as we find efficiencies, we work with our suppliers to do the same. And that leads to material cost reductions that improve the affordability of our products. And as we look forward to our next-gen vehicle, our target is to reduce 50% of cost, and we've talked about that a bit earlier today. Going from the Model S and X platform to the 3 and Y platform, we took out 50% of cost, so the task here is to do it again. And this is very important because as we improve affordability, the number of customers who have access to our products dramatically increases. And as we link this back to our master plan, it enables an exponential growth in our volume with linear reductions in the cost of our products. The second point I'll make here is that, and again, cost reductions don't come from any single one place. And so you can see the buckets here on the vehicle side, battery and powertrain, manufacturing cost reductions, and others. These buckets are relatively equal in size. And so in order to take 50% of the cost out of the product, we have to go through everything. But more importantly than just the cost of the car up front, when we're transitioning to a sustainable economy, particularly with vehicle ownership, it's really important to think about the lifetime cost of the products. And this chart here is showing what the total cost of ownership per mile is over the course of 5 years. And we have to think about financing costs, insurance costs, the cost of power. Drew talked a little bit about that with the plants that we're doing in Texas, wear and tear and maintenance on the cars, et cetera. And we're already at a place today in the US where a base Model 3 on a cost per mile basis is less than a Toyota Corolla, which is the highest selling car in the world. And as we move towards our next-gen platform, we will continue to reduce this. And as we work on robotaxi variants of this platform, this cost will come down even further. And so this is a product that we expect to have substantially lower cost per mile than the highest volume products in the world. The next thing on cost reduction I want to talk about is operating expenses. We spend a lot of time on our earnings calls talking about gross margins and product cost. We don't spend a lot of time talking about OpEx, but I think this is one of the really important parts of our story. So since 2018, we've reduced our non-GAAP OpEx 60% as a percent of revenue and 75% on a per delivered car basis. This is quite staggering, and I want to go into the details about how we've done this. The first component of OpEx, which is R&D, the single most important thing here is that we constrain the number of programs that we work on, so minimizing the number of programs that we're running in parallel. And the key here is to maximize the revenue and cash generated from every program that we work on, and also maximize the technology sharing between the programs. So we talked a little bit about how power electronics in our energy business is shared with power electronics in our vehicle business. If we look at the SG&A side of this, I think the story here is pretty dramatic. So we're showing here a comparison of SG&A per car delivered compared to the traditional auto industry, which is both an OEM and the dealership network. And our estimates are that we're 60 to 70% lower on a per car basis. And if you turn this into dollars, this is many thousands of dollars per car. This is part of the reason why on the last earnings call, I made the comment that we think about operating margin more so than gross margin as a company, because the integration that we have here on the SG&A side, particularly with vertical integration into our dealership network, this provides efficiencies that give us a competitive advantage from a cost structure standpoint relative to other companies. The other thing that I'll note here is that this wasn't always the case. And it wasn't that long ago where these bars would be inverted. And if we go back a little bit in time, and we talk about when we launched Model 3 in the Fremont factory, we went from 2,000 cars per week, which was S and X, adding 5,000 a week to that for Model 3 got us to 7,000 cars a week. You've heard some folks here today talk about production hell. What I don't think we've ever talked about as a company is back office operations hell, which also happened at the same time. And 7,000 cars a week, 350,000 cars a year, we want to go to 20 million cars a year, and we're struggling at 7,000. And we're saying to ourselves, we have to completely rethink the way that we're managing our back office operations if we have any hope of efficiently scaling this company. And so this began a process that we're still continuing to work on today, but it's something that we refer to as the Tesla operating system. So in the same way that we're vertically integrated into the software that manages our cars, we've also vertically integrated into the software that runs our company. And all of our major departments in the company are using, not all of them yet, but almost all of them are using our in-house software. Most recently, we removed third-party recruiting software, and we're now running our own recruiting software as a company. And this matters a lot because rather than having a complex web of third-party systems that are generic solution that take a lot of effort to customize for our particular needs, we've been able to put in place with an in-house applications engineering team dedicated lightweight software that does only what we needed to do and nothing more. And that team works very closely with process improvement teams that sit within the business, who are looking through all of the processes that we're managing as a company and following the exact same process that Tom mentioned in the manufacturing space to look at our processes, delete process steps that we don't need, simplify process steps that are existing, and automate what's remaining. And the results of this have been quite staggering, to be frank. I think it's exceeded our expectations as well. On the left side of this chart are some examples of the efficiency improvements that we've seen within our SG&A areas as a result of this strategy. The North American sales team is 4 times more efficient now than they were in 2018. Order operations team, financial services, I mean, these levels of improvement are large, and there's not enough pixels on the slide here to list out everything, so it's just a couple of examples. And then in the same way that when we look to take cost out of our products, we want to feature up the product or improve the product while taking cost out, the same has been true with the use of Tesla operating system and that integration with our process improvement teams within the company. And so we've increased performance and added capabilities while also dramatically reducing cost on a per car basis. There's a list of self-service functionality that we've put in place, which customers like. It also simplifies our operations behind the scenes. We've used the Tesla operating system to expand into our captive insurance space, which we are fully vertically integrated into. We run our own in-house software. We have our own agents, our own claims software, and claims folks who run our insurance business. This is also very important because as a technology company, data is very important. And we use these systems and the access to the data in those systems to pull out extremely granular and targeted reporting that enables us to see every aspect of our business in real time so we can make adjustments to our operations as needed. And there are sometimes examples where we say, man, I wish we were tracking this piece of data. Well, you know, it's a Teams meeting away from the applications engineering team to make a request, and then we can start tracking that data and make those changes. And so the feedback loop associated with process improvement inside the company is pretty astounding. The last thing I'll just mention here, which is something I'm personally quite proud of, we've made a lot of progress in our close processes within the finance team, getting our 10Q and 10K filed. It's amongst the fastest of the 20 largest market cap companies, so great work to the finance team here. So all of this work on cost reduction is extremely important because we have a lot of money to spend ahead of us to achieve our goals within the master plan. So we've mentioned over the course of the day today, 20 million annual vehicle production as our target, 1 terawatt hour of annual energy storage production, and then expanding cell production, service, and charging in line with the growth of those other businesses. And so we've estimated what we think the total cost to get there will be, and there's certainly error bars around these numbers as we continue to progress and innovate. But of this, we've spent about $28 billion of that so far in the history of the company. And Maybe this total investment looks large. I actually think it's quite small relative to our ambitions. And if you look at our 2022 operating cash flows and you just say, well, let's assume some modest growth to that, maybe not all that much, if you're being conservative, but the ability to pay for this level of investment from the forecast that we have is very achievable for us. I'm often asked about capital allocation. I think our strategy here is very straightforward. I touched upon it a little bit in our last slide, but just to be explicit about it, obviously the priority here is to ensure that we're using capital to run the day-to-day operations of the business. This is a working capital intensive business, and this has to be managed very carefully. And so, over the course of a quarter, there can be multi-billion-dollar swings in our cash balance up and down, just depending upon the timing of when we build and deliver cars. So we obviously have to have money set aside for that. Downside protection is another really important area where we have money set aside for that. And over the last couple of years, throughout the pandemic, I think this just highlights why being ready for downside protection is important. Preserving daily operations is the engine that then generates cash that allows us to reinvest into the growth of the business. And I'm very proud that over the last couple of years, despite the ups and downs in the macro environment and interruptions to supply chains, we have never once pulled back on our investments in growth, so that remains a huge priority for us. We do then, after investing in growth, we look at opportunistic ways to spend our cash. These are more financially oriented, where if a return exceeds a hurdle, then we can place cash in that. This is part of our story of cost reduction in the Fremont factory. And then on the excess side, this is where the board meets on a regular basis and they're thinking about what our cash flow projections are looking forward and whether it makes sense to do buybacks or dividends. So to wrap up the finance portion of the presentation today, a couple of key messages I just want to leave you all with here is that we use innovation at an intense level to drive costs down and improve the efficiency of the business. And the reason this is so important is it allows us to improve product affordability. And this is particularly the case when we move to our next generation platform. Improving affordability allows us to comfortably make investments that grow volume. That volume generates cash that then allows us to make more investments. And as we integrate that going forward, it's our belief as a leadership team here at Tesla that we're going to achieve unprecedented scale in the manufacturing space. And this is what's ultimately required to accelerate the world's transition to sustainable energy. So with that, this completes the prepared portion of today. We're going to take a short break, and then we'll resume with a live Q&A. Thank you all very much.
can talk.
All right, so, well, let's see. So this is probably the most significant announcement of the day is that we're excited to announce that we're going to be building a Gigafactory in Mexico. So, yeah, and we'll have obviously a grand opening and groundbreaking and whatnot. But we're excited to announce that the next Tesla Gigafactory will be in Mexico near Monterrey. So super excited about it. Now I do want to emphasize we will continue to expand production at all of our existing factories, so including California, Nevada, here in Texas, obviously, and Berlin, Shanghai. So we intend to increase production at all factories. So the Giga Mexico would be supplemental to the output of all the other factories. So this is not, to be clear, moving output from anywhere to anywhere. It is simply about expanding total global output. Yeah, so it's going to be good. So
peanut gallery.
Anyway, so I think that's, we're quite excited to announce that. In fact, I believe the governor is here. It's hard to see. Welcome. Secretary of State, I believe. Anyway, so we're looking forward to it and having a big event for the great groundbreaking and opening. So let's see. With that, we can move to, I guess, Q&A. We've obviously got significant bench strength here. Should probably have like a bench. And anyway, we maybe have too many people on stage, but we'll try to answer questions within reason. This is meant to be kind of more of a long-term sort of discussion as opposed to what will be the production for the rest of the quarter type of thing. So let's try to orient our questions towards long-term value creation. And with that, fire away.
Rob?
Hi, it's Rod Lash with Wolf Research. Very exciting plans about the next generation vehicle and powertrains and batteries. I was hoping you can maybe talk to us a little bit about the timeline for deploying this. And it sounds like it's more than just a vehicle. This is a kind of a paradigm change on how vehicles are assembled, how batteries are put together and everything. And does that also just get reconfigured into everything that you do? So the Model Ys that are being built here will be built very differently in the future. Maybe just give us some feel for what happens from here and what's the timeline for implementation.
Well, I'll talk a little bit about that, but broadly speaking, the most profound architectural changes will be in future vehicles. Retooling a factory means bringing the factory down for an extended period of time, and that would prefer not to do that, I think. But there are variants in how Model Y is produced. So we've got variants where there's rear casting, where there's a front and rear casting, and we have the structural battery pack. And then there are a number of smaller improvements that occur. But I think for really, really big changes, those would be future vehicles. Yeah, I don't know, you guys want to add? Lars, maybe?
Me? Yeah. So I mean, as far as I agree with you 100%, Elon. It's really easy to put innovations in new vehicles, but long term, we'll obviously bring them back. We've always talked about that, but we don't want to take our factories down. As far as the timeline goes, we're going to go as fast as we can, left to right. As always, Elon alluded to the fact that Mexico will build our next-gen vehicle, but we will also be doing that in our other plants. And so it's really about getting them all up and running. We expect that to be a huge volume product, and yeah, we're going to move that quickly over the next couple of years.
Let's go to Adam.
Thanks. First, enhorabuena, Mexico. Vamos. That's great. Congratulations. Elon, a question on applying first principles thinking and innovation to an area that up to now has seemingly been outside of your control, and that is on mining and extraction of some of the key materials. I believe a couple years ago you had a patent on sodium chloride to extract lithium from some clays and spodumene clay and things of that nature. How does that fit into the plan of maybe bringing real innovation into a mining sector that could use a little, maybe waking up and getting those costs down? Because that could be a real gating factor, it seems.
Well, we're going to address whatever we think the limiting factor is at any point in time. So we would like to do the least amount possible. So we don't want to get into the mining or refining sector. We will do that if we have to. I do think the focus really should be on refining capacity. We need to make just a very giant amount of anode cathode lithium hydroxide, lithium carbonate. It's really the refining capacity that is the biggest choke point. Yeah, so that's why we're building a lithium refinery in Corpus Christi.
In terms of the mining companies that are out there and looking at that part of the value chain, so we do have large suppliers of lithium right now, and they are aware of how we're approaching the Corpus refinery and the technologies we're trying there. And the reason we're making them aware of it is because we think they're fundamentally more scalable, and as we prove them out, we plan to share that with them. Because as Elon says, it's not really like we want to do these things. We're doing them because it's not happening fast enough. So if we can prove that it can be done faster, the intention is to transfer that knowledge to our current suppliers. And the same is actually true. It was actually a clay process that we're playing with and we continue to work on. Same is true on that. So we've worked with our suppliers as well on trials, and we're sharing knowledge there. And the intention is just to help the whole world do this better. And ultimately, this here is getting the lithium out, or whatever it is, out of the ore.
And we're obviously building a cathode processing facility just adjacent to this building. So a little further down the road, you'll see another large construction. That's for cathode refining. But like I said, we'd really prefer if others did that. We're doing it because we have to, not because we want to.
Yeah, and in that case, there just isn't really any large-scale cathode production in the United States, and it needed to be done. And again, if we're going to do it, we're going to try to do it from a first principles perspective. So we have tried a bunch of new things there. We're confident that they will work. And as they prove out, again, we want to bring them back to our suppliers so that they can build new facilities more quickly with less investment.
All right, let's go to Ben.
Hi, Ben Kaler for Baird. So similar on the renewable side, is there more that you can do in Tesla to nudge the rest of the renewable industry to speed up, since it's such a big pillar of the Master Plan 3?
Well, I don't know what more we can do, but I can say that if there's entrepreneurs out there that want to have a guaranteed chance of success, it would be refining lithium or anode and cathodes or any materials whatsoever for lithium-ion cells. It's a no-brainer. Yep. I think we're doing everything we can. So.
Yeah, on the renewable energy thing, the thing that we can do, Tesla, is the more we reduce the cost of storage, the more we reduce the cost of stationary storage, and the more we bring like flexible load to the grid in the form of like cars charging at the right times, the more valuable renewables are. Because in like Texas right now, I wasn't joking, like there's a lot of wind, and at night, there's like almost too much wind because they don't want to turn the nukes off or whatever. So bringing really low-cost storage onto the grid makes renewables more valuable, which ultimately will accelerate their deployment. So that's how we focus on it, I guess.
Yeah, Felipe?
Thank you. It's Philippe Bouchot at Jefferies. I've got two questions. The first one, when I think about in this industry, everybody wants to be Tesla. Every car maker is trying to emulate what you're doing. Well done. The one thing they don't do is focus on having as much growth as possible with as few models as possible. So I'm just trying to understand, as you aim for 20 million units in 2030, how many models do you think you need to get there? And how does it fit into your drive to hyperscale? How do you manage this? And also the fact that probably consumers at some point don't want to see a Tesla or the same Tesla at every street corner. So I'm just trying to get your sense of that. And my other question is on bidirectional. I mean, you talked a lot about making a world more renewables and better usage of cars. I think bidirectional charging is one way of better using cars, but you seem to have been reluctant about doing that in the past. So I'm just wondering what your latest views are on the topic.
Sure. On bidirectional, it wasn't like a conscious decision to not do it. It just wasn't a priority at the time, I think is maybe the way to think about it. As we continue to improve the power electronics in our vehicle, we've found ways to bring bidirectionality while actually reducing cost of power electronics in the vehicle. And as at all things Tesla, the goal is usually to get more for less. And so we are in the middle of kind of like a power electronics retool, I would say, that will bring that functionality to all of our vehicles over the next 2 years, let's say. But yeah, I guess that's how I'll say there.
Yeah, I don't think very many people are going to use bidirectional charging unless you have a Powerwall, because if you unplug your car, your house goes dark. And this is extremely inconvenient.
Yeah, most of the value, it comes in charging the car at the right time. It's not really about sending energy the other way.
Yeah, I mean, if you have a Powerwall that can take the house load, then you can use your car as a supplementary energy source to the Powerwall, and then you're not going to drive everyone crazy by unplugging your car and having the house go off. So I think there's some value there as a supplemental energy source down the road, where if you have a Powerwall, you've not diminished the convenience of the people in the house.
And the question of number of models?
Sorry, the what? Oh, how many models? Oh,
vehicle models.
Not that many. Really, 10? I don't know. Not that many. I mean, what's happened with conventional cars is people have run out of things to do. So if you run out of things to do, they just end up reshuffling the deck, and you have pretty much the same. I mean, how many variants of car are there on the road? There's like hundreds. But are they good variants? No, mostly not. They're just variants for the sake of variants. But look at how have things converged with the phone? I mean, there used to be hundreds of flip phones. Now what do we have? It'll be like that.
George?
George Generikas from Canaccord Genuity. Just had a question about your plans to grow market share in China, and also whether or not the political tensions between the United States and China impact your long-term ambitions there. Thank you.
I don't know. Hey, Tom, not to put, don't sweat too hard.
Yeah. Well,
Well, we're still growing our market share in China quite strongly, actually. Especially early this year, we had this price adjustment. After that, we actually generated a huge demand, more than we can produce, really. As Elon said, as long as you offer a product with value at affordable price, you don't have to worry about demand. That's basically the philosophy that we follow. We try everything to cut cost from supply chain, from improve the efficiency in the factory, and pass down that value to our customers. I think as long as we continue to do that, I'm not too concerned about the market share in China. And the second part, geopolitics, no one knows. We do our best. We actually create a lot of jobs to the local community, and we generate also at our suppliers' factories, we'll create a lot of jobs as well, and we'll contribute a lot to the local economy. I think as long as we're needed in this country, I don't see there much of the risk of that.
Colin?
Colin Rush from Oppenheimer. One of the things I was struck by in the presentation was the operational efficiency metrics that you guys are talking about. Could you talk a little bit about the velocity of learning cycles and how you guys track that and think about that as an organization as you work into a variety of other areas from an innovation perspective?
Anyone want to try that?
I mean, I'll say one very high-level thing, which is you can't improve something you don't measure, and we're like ruthless measurers at Tesla. And once you start measuring things that contribute to operational efficiency, you actually have a path to doing something about it. So I guess the key is a good measuring stick.
Okay. It's something I should say with respect to demand, which I've said a few times over the years, but it's sometimes it needs to be said again, which is overwhelmingly there's the desire for people to own a Tesla is extremely high. The limiting factor is their ability to pay for a Tesla, not do they want a Tesla. It's easy for people in this room to lose sight of that. If your income is far in excess of what a car costs, then you look at value for money, but you do not consider affordability. But for the vast majority of people, it is affordability driven. This is why we cannot simply double the price of the car. Or you could say and think about things in the limit, where if you had an infinitely desirable car, but it costs $10 million, it wouldn't matter because most people do not have that. So demand is very much a function of affordability, not desire. Very important. One of the things we weren't sure about was the price elasticity of demand for Teslas. So like, as we lower the price, how much does demand increase? And we found that even small changes in the price have a big effect on demand, very big. So that was a good thing to learn. Yeah. And then as this autonomy question is very, very big, because you could potentially have, 5 times the utility of the asset that you currently have. So if a passenger car is 10 or 12 hours a week of usage, plus a lot of parking expenses, an autonomous car could be 50 to 60 hours a week or something like that. And you could get rid of a lot of parking expenses. So, if this is true, then as autonomy is effectively turned on for the fleet, it probably will be the biggest asset value increase in history overnight.
Emmanuel?
Thank you so much, Emmanuel Rosner from Deutsche Bank. So as you
start launching this next generation vehicle and ramping up volume, what will be your nearest term priority in terms of segment or vehicles focus? The slide that you showed with 2 vehicles on the wrap seemed, based on form factor, one of them maybe looks like a van, another one looks like maybe like a smaller vehicle, like potentially a Model 2. I guess, what is the nearest term focus for you in terms of ramping up the next gen vehicle? And how do you make sure that by lowering the price point so much, because the cost is going down 50%, you're not cannibalizing demand, for your existing vehicles?
I mean, demand for our vehicles in terms of desire to own them may as well be infinite. It's indistinguishable from infinite at this point. So affordability is what matters. So as you make the car more affordable, we will have demand go crazy, basically. The issue is, how do we build the cars? The hard part is building the cars. I can't emphasize that enough. The hard part is building the cars and the entire supply chain that goes with the cars. This is a logistics challenge of extraordinary difficulty. All the things that have to go into the car have to scale with the car, while everything is doing an exponential ramp. And if you miss even one of those things, doesn't matter why, earthquake, flood, fire, revolution, I thought I've heard them all. I mean, any part of that supply chain gets interrupted, then you have a seizure. The hard part is building the cars by far, and the supply chain that goes with it. Do you guys want to talk about supply chain stuff?
Well, they might.
I think, in the presentation I'd mentioned perfection is a passing grade. We really need everything to happen perfectly, and the strategy for mitigating the different risks, some of which were anticipated and some weren't, is really bespoke to the situation. And really you need subject matter expertise and a deep knowledge of the particular supply chain you're managing to come up with those strategies. So we've seen everything from, as Elon mentioned, first the tariffs that flew back and forth, then the ocean logistics issue, a chip shortage, COVID, floods. There was a fire in a fab in Japan that knocked down. There was a massive COVID spike in Malaysia where a lot of the chips, the back end of a lot of chips was down there, and more. This was one that Elon was involved with as well. And it's nerve-wracking, but somehow it works.
Yeah, and although it's difficult, I think we have been laying the foundation to be as intimate to all the tiers of the supply chain, building that control and directing the different tiers of supply chain. That's the way we are trying to mitigate the risks that come with it. Again, dual sourcing, triple sourcing, having redundancy is the way we've been trying to mitigate for it.
Yeah, on that point, when we think about vehicles, when you think about 3Y as an architecture, SX as an architecture, our next generation platform is more than one segment, and really we're thinking about all the segments that are available that we haven't captured and where the market would be, and designing it with our supply chain partners so that we can go quickly through those segments for where we need. But to Elon's point, if you make a car desirable and affordable, oftentimes it doesn't necessarily matter what segment it's in, because it's one that you want. And we've seen that with Model 3 when a lot of people thought the sedan was not going to be a great hit, but we sell tons of them. So the next generation platform is not one vehicle. It is multiple, and it's on a segment that we will really try and focus on that affordability and desirability point moreover than where we started.
Yeah, I mean, there's I think, it's an old saying, like, battles are won with tactics, wars are won with logistics. The logistics challenges here are enormous. And when you start being a very significant percentage of an industry, you can't overcapacitize. It's not realistic. And some of these things, like you say, you dual source or triple source, you can do that maybe for small things, but you can't do it for big things, because if you're triple sourced
And it's like having a plane with 3 engines, where if any of the 3 engines fails, you crash. It's like, so and you have to either overcapacitize, which drives your CapEx up, and it has idle suppliers somewhere and big warehouses, or you design to some overage that's, reasonable, and then you have expedite costs because inevitably something goes wrong somewhere and you've got to fly things around. So it's really just the rate of progress is the rate at which we are able to scale 10,000 logistics problems. The most significant of those is the cell production. And so we actually deliberately try to overdo cell production or cell supply to have that exceed what is needed in vehicles. Because if it goes below what's needed in vehicles, then the factories stall. But then what do you do with all these extra cells? It's like, well, okay, so the much easier thing to scale up and down is Powerwall and Megapack output, stationary storage. So we can then overcapacitize in cells and packs and scale production of stationary storage, which is much easier to scale than vehicle production. So that's strategically, I think, a good thing. Yeah, I mean, the CapEx for Megapack is tiny compared to CapEx for vehicles. Also, Megapack demand is quasi-infinite. It basically, as long as we are competitive with utilities, we can sell as many quasi-infinite demand for that, really. Or many terawatt hours. And we got a long way to go to get to many terawatt hours per year.
Dan? Let's go to Dan.
Thank you. Dan Levy, Barclays. I think we know competitive dynamics differ significantly by region. We know cost dynamics differ by region. We saw that with your China Gigafactory, far superior cost to what you had at Fremont. I realized it was a new factory, but there are clearly different dynamics. So to what extent are the cost strategies that you've laid out today, do they differ by region, or is there more of a global one-size-fits-all approach on reducing cost?
Yeah, I think we're pretty consistent on the strategy here. We'll try to as much localized as possible. Like in China, over 95% of our supply chain are localized, all the way from the first tier, the second tier, even to the third tier. And that gives us, generate a tremendous savings on COGS. We also have a very localized labor force. We have access to skilled labor force in the region, and Yangtze Delta region in Shanghai, I'm particularly referring to. Among over 30,000 of employees in China, we have probably less than 20 expats. So it's very deep localization we have done there to be able to have such cost structure, and we try to replicate this approach elsewhere in different gigafactories. Of course, supplier bases are different. The labor market are different, region by region and country by country. But we try our best to localize. Yeah, and I think that's absolutely give us an advantage to compete with the auto OEMs around the globe. Another thing is, we have this direct selling mode. Like Zach said, we save a tremendous money on OPEX as well. We have full control over all the expenditures across the company, and we don't spend money on marketing or advertising. Everything we saved will become the value we can offer to the consumers. So on that part, we also follow pretty consistent strategy over the years.
I mean, certainly the manufacturing stuff that Colin, Pete, and myself talked about, whether you make it here, or you make it in Europe, or you make it in Asia. It applies everywhere. We think about that from the ground up, not specific to any region.
Yeah, just one thing I would add to Tom's point about localization and to Lars's point here. I would actually say that we're moving in a direction of more standardization in terms of our factories and our processes and our cost reduction approaches. So as we've been thinking about the next generation platform, we've been thinking about the volume that we aspire to build against that, how many individual factories do we need to build, and what is the fastest possible way to expand that footprint around the world. What we've done with Model Y is each factory is an incremental improvement of the previous factory, which requires engineering hours, engineering spend for each factory design, and then you end up with factories that are slightly different from each other. And as we move towards the next generation platform, I think the term you use, Lars, is copy-paste. So to get it right from the first time, certainly there will be things that we learn and we replicate and we make adjustments to, but try to have as much standardization and commonization as possible, which allows us to go as quickly as possible with expansion.
Overaka on this side.
Thanks. Two questions, one for Zach and one for Ashok. So for Zach, how do you think about the long-term growth and operating margins for the business? And when we look at 150 to 175 billion in CapEx, is the remaining balance of that, is that essentially the CapEx guidance through 2030? For Ashok, the multi-trip reconstruction that you highlighted, how is that different from what Mobileye does with the REM map that they have? And can you give us any color on the AP4 hardware?
So with respect to operating margins, we intend to continue to improve operating expenses as a percentage of revenue over time. And we're continuing to take cost out of our products and try to keep gross margins at a place that's healthy as well. And so, from the hardware perspective of the business, it's our expectation that we'll continue to stay in a healthy place over time. And then there's a software portion that's added on top of that. And so Elon has commented on this many times about the impact that full self-driving software can have on the economics of the business. And in that space, profitability, operating margins would be impacted dramatically. Specifically to your point about CapEx guidance, the intent of that slide was not to provide specific guidance, but to just be transparent about internally what our rough estimates are and to provide context that we think getting to 20 million vehicles per year and 1 terawatt hour of energy storage is very feasible relative to our expected cash generation for the business. That's a number that will move as we learn. We may choose to vertically integrate more into things. We may find efficiencies elsewhere. To the whole conversation we were having earlier about do we do mining, do we not do mining? But the entire point is to say that this is something that's entirely possible based upon our forecast.
Regarding the multi-trip reconstruction, my point I was trying to make was that we want to auto-label most of the data, and we can collect data from the fleet and then reconstruct local areas that can act as supervision for those clips. Since we want to build a scalable self-driving system, we don't want to really rely on HD maps or anything, even though we could trivially build something using the same technology. But this is mostly for auto-labeling, and this provides precise 3D labels for all the video sequences involved in the reconstruction.
Something that's, I don't know if we touched on this much, but in terms of training, we have one of the biggest neural net training systems in the world, and that we expect to increase that capability by an order of magnitude by the end of this year, and probably another order of magnitude by the end of next year, with some combination of NVIDIA and Dojo. So I'm not sure the scale of that is quite dawned on people. It's enormous.
Maybe the final two questions, one from Alex and one from Chris.
Okay, Alex Potter with Piper. So I definitely want to ask Drew or anybody else up there for an update on dry battery electrode, right? So if you're going to try to overcapacitize towards cells, scale a lot of this. Clearly, there's a lot of moving pieces, and it's a complex sort of orchestra with the supply chain, but a lot of it comes down to dry battery electrode, at least to me. So how are you trending? That was the most fascinating part of the factory tour for me, and looking through that window and seeing that this is clearly not a science project, but anything that you're willing to disclose, yields, progress, where you are today versus where you thought you were going to be. Yeah, thanks.
Yeah, I mean, as you saw, right? Like, this is a real factory making a lot of dry electrode in an automated fashion. We've made a lot of progress. It's a spectrum. Like, we're perfectionists, and we have clear end goals, and we are every week that goes by making progress towards those end goals, whether it's speed of the tool, yield of that process, or the downstream process. We haven't stalled out yet on the rate of progress either, and that's both on the anode and the cathode side. And I think the great thing about where we are with the overcapacity that Elon mentioned is it's giving us the opportunity to experiment as we go, rather than just being like stuck to something that we happened to kick off a year and a half ago and it is here. Something that Elon has said to the team many times is it's okay to scrap equipment or money. It's not okay to scrap time. So the way we've been approaching it is probabilistically, what do we think is the most likely thing to succeed? And even actually in the factory here, you saw more than one anode line. They are actually operating two slightly different versions of the final process step of the powder entering the tool. And it's a competition, you know, which is going to be higher yield, which is going to perform better. And we have the luxury to be able to do that. And we're taking full advantage of it to advance the technology as quickly as possible.
The dry electrode problem is really quite a hard problem. I mean, we acquired Maxwell really just for the dry electrode technology, but just illustrates what a gigantic gap there is between something working at small scale and at large scale. And we've had an extremely talented team of engineers working on scaling the dry electrode process and having it be reliable and consistent. And we've been grinding hard, literally and figuratively, on this for quite a while. It seems likely that we will be able to scale it to volume this year.
Yeah, I mean, we're basically increasing the output week over week, like roughly 1K a week per quarter is our internal target, and we're tracking to that. I think what you saw is effectively like a ton of material per hour per tool. It's kind of like hard to like rationalize like what that really means, but it's different than like, oh, something works in a lab. It's like, well, when it's tons of material per hour, there's just different kinds of problems. Like, even if you have like 0.1% escape of like fines into the enclosure that your equipment is in, now you have a dust problem, and like that could short out some electronics. It's like just things like this, where when you're on a lab scale, you don't even notice it, but when you're doing thousands of tons over the course of months, it's like, oh, a new failure mode we found, and that's where we're at. But we're knocking those out, though, and the team is grinding through it, but progress every week.
And the last question from Chris.
Thanks for taking the question. I have a few follow-ups on the next-gen vehicle. First, when do you think we'll get a look at it, maybe a prototype? Second, are there any details that you think you can share in terms of the size, the content, the performance? And then third, I think you mentioned that you would produce it in other plants in addition to Mexico. Should we take that to mean that you can launch it at an existing plant before you're finished constructing the new plant in Mexico?
I think we'll actually have to probably decline that answer. We will have a proper sort of product event, but that we would be jumping the gun if we were to answer your questions. Maybe another question, if there's, yeah, I don't know, anyone?
Will Danoff?
I have two questions. This has really been a very impressive afternoon. Thank you so much. Elon, I'm curious, as you've doubled and you'll double again, what you've learned about sort of managing a larger enterprise and what you might have to, do to manage a bigger enterprise. And then secondly, I'm curious on your thoughts on how, generative AI and, these rapid breakthroughs in AI in the last months could help you make cars sort of, less hard to make. Thank you.
I don't see AI helping us make cars anytime soon. At that point, I mean, at no point any of us working, I think.
Big problems.
So we'll just chill out. I mean, I'm a little worried about the AI stuff. I think it's something, I don't know, which we should be concerned about. I don't know, I think we should need some kind of like regulatory authority or something that's overseeing AI development and just making sure that it's operating within the public interest. And, it's quite a dangerous technology. And I fear I may have done some things to accelerate it, which is, I don't know. So, I mean, some of the AI stuff I think is just obviously useful, like what we're doing with self-driving, which is, some people think is an AGI type problem. I don't think it's quite an AGI problem, but it certainly requires very sophisticated neural nets because the road system is designed for eyes and biological neural nets. So naturally, the analog to that is cameras with digital neural nets. The thing we found is just there's if you actually look at our neural net architecture in the car, it's kind of insane, frankly. Nets upon nets upon nets upon nets.
Yeah, the visualization tool crashes when you open.
Yeah.
It's like so complicated that no one can visualize this right now.
Yeah, it's hard to just like literally, it looks insane. So I guess something like that's happening in our brains while we drive around, which is pretty wild. So, I don't know. Like Tesla's doing good things in AI. I don't know. This one stresses me out, so I don't know what to think to say about it.
Okay, given it's 7 o'clock, I think that's all the time we have. Thank you very much for coming, and
thank you.
I'll see you later.
Yeah. Chef, can you see me? I can see you. Oh, okay. How's it going? My brain hurts.
Yeah, it's one heck of a day, huh?
I don't even know what to talk about. I got some scattered notes. I'm like,
Hey, there
Check,
they
check.
go.
Okay.
You guys
Hey,
hear me?
Xander. Yep.
What's up? What's up?
We can
Hey,
hear
Xander.
everybody right now. Oh.
Hey, guys.
Yeah, I can hear you.
Oh,
fine.
hello. How's
Hello.
it going? Can
Great.
you see me?
What's up, Prasad?
Hello. How you guys doing? You guys look
Now
sharp
I
up
just
there.
see Xander. But my brain
All
hurts
right.
after that.
So what we're going to do now, I'm going to give a brief summary of what I heard, just for the folks at home that are watching this live streamed on my channel and on Herbert's as well. In a few minutes, we'll bring up Matt Holm and Anwar Beck, who are the leaders of the Austin Owners Tesla Club, to just give a brief statement. It's their 10th year anniversary, so congratulations, you guys. That's amazing. Can't wait to hear from you. Then we'll have Herbert, Brighter with Herbert, come on and lead a panel for about an hour and 15. And then depending how everybody else is on their route back from Giga Texas, we'll start our panel either on time or slightly behind schedule, given on where Tesla's at. So Giga Mexico, obviously, is something we got at this event, which was awesome. It's super, super cool that we heard that. Looks like the compact car is going to be in addition to the Mexico production. We got a very top-level presentation of what Tesla's really about in this presentation. I feel like it was something where it was more geared to people that perhaps weren't as in tune with what Tesla's really about as far as all the other stuff they have going on. I think Tesla did a really good job outlining that a future where we have sustainable energy as the core component is super possible. And it's not impossible, it's actually very, very doable. A lot of talent on that stage. I think it's another trend for Tesla where they're really sitting down and doing a lot of that, where they're just highlighting all the different people they have at the company and giving them some time to breathe. I think that was super, super cool. A lot of simplification, doing more with less, focusing on costs, all that stuff. Another theme that we saw with this thing, which was really, really great. Let's see, what else? And I feel like with these last few presentations, if you take out the semi presentation, it's been just so much information, so dense. Sometimes with this presentation, I feel like we've heard things that we've heard before. It looked like at the beginning we were going to get the Gen 3 car, and then we didn't, which was kind of a bummer for me, to be completely honest, but it's okay. It is what it is. But I think I'm excited to hear what Sandy and Corey have to say about the Gen 3 platform. I think that's going to be a very big deal. Very, very big deal. We saw the Tesla bot walking around, which was super cool in video, but we'll see if we see it in person here soon. That would be cool. And it appears like Tesla is really one of the very few companies, at least stateside, that's really pushing charging as a priority. I mean, we know Electrify America exists, but it seems like Tesla is really, really investing very heavily into that, which is really, really cool to see. They talked about how COVID really changed the dynamics around the supply chain. My time at Tesla, I was in the supply chain team, and I can tell you firsthand it was a absolute disaster, and there were a lot of things that were learned through that period. And the fact that they used that data, that time to get better was super cool for them to talk about. Supply chain is the least sexy thing in the world. It sucks, but it's so important, you know? And it was cool hearing them talk about that a little bit. We got to meet Tom Zhu for the first time, which was awesome. I thought Tom Zhu came across really well. He seems like a really good guy. Drew talked about how they're 20 times above their battery day tour production capabilities on the 4680 side. So they're showing some actual progress from that side, which is great to see. Again, they talked a little bit more about energy, this virtual machine mode that kind of emulates a peaker plant type thing was kind of cool to see how they're using software to emulate something that's done right now by something that's not using batteries. And then we had Zach sort of towards the end there, really focusing on taking out costs. From the one graph they had, it looks like Gen 3 will be about 20 to 25% cheaper per mile than the Model 3, just based on that graph. I have to go back and look at it again, but that was very interesting to see. So perhaps thinking about it as half is not the best way, a fourth to 1/5, maybe it's better or cheaper. And it's benchmarked against the Corolla, not the Camry, which is another really cool thing to see here. So yeah, man, it's just, I think my really top level takeaways is that it's obvious. I hope it's now obvious to more people that Tesla isn't just a car company. I hope. And that the depth of talent that Tesla has, to me, is, again, just, it's pretty incredible. They can just trot anybody up there and they're like, hey, this is what I'm working on. I almost killed my phone. Did you see that? Holy shit. But almost cursed. So yeah, I'm really curious to see what y'all think as well. I know Herbert, when he comes on, he's going to do a little bit of he's going to gauge some interest from y'all. So it's going to be very cool to see. But what I want to do right now, before we go on to Herbert, I want to bring on Matt and Anwar Beck to sort of speak about this event a little bit. Please come join me on stage. Here's Matt Holm and Anwar Beck. Welcome on, y'all. How you doing? Just make sure you eat the mic.
Hello, can you hear me?
Check, 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 check.
Check, check.
Check. Yeah,
Check.
just keep saying check in there.
Check, check.
We need audio. It's got to be. Hello?
Check, check.
Maybe I'll do a dance until we get it on. Hey.
Check.
Hello, hello. Thank you guys so much for coming. Who came from out of state to be at this event? Holy shit. Who came? Anybody outside the States? From where? From where? Where? New York? Anybody outside the United States? Canada? Amsterdam. I think he wins. Wow. Thank you guys so much. My name is Anwar Beck. This is Matt Home. We are your hosts, the Tesla Owners Club of Austin. Matt actually started this club over 10 years ago. So we thought we would piggyback with Investor Day, throw the after party. We haven't even got started yet, by the way. Elon is done, but the real party is going to be ahead of us. So pace yourself. This is a marathon. We've got amazing speakers coming. Sandy, a bunch of the other guys are on their way from the Gigafactory. They're coming in hot. But I'll let Matt speak for a little bit and give you guys a little bit of the background story about the Tesla Owners Club. Here's Matt.
Thank you guys for coming. This is really exciting. Appreciate you guys. And cheers to 10 years. And this club started with about 20 or 30 of us that got an invite from Elon in 2013. All of us had gotten our Model S within the last month. And they said, come to the Capitol and help with direct sales. And we'll push this through and we'll give testimony and it'll be a slam dunk. So I got up early, I gave rides to press, and then I sat behind Elon for 9 hours. And a lot of us, explained the kind of silliness of not having direct sales. And at the end of that day, we thought we won. Well, here we are 10 years later, no direct sales in Texas, so work to do. But the cool part was Elon tapped me on the shoulder on the way out and said, hey, I saw you on the news today. Can I do anything for you? And I was a little forward, I guess. I said, can you sign my sun visor? My license plate takes some selfies with me. So I wasted his time for about 10 minutes. And I left that being super enthused for Tesla. Elon obviously cracked with intelligence. I cut off the conversation because I'm like, I have nothing to add. You're going invent cool shit. I got nothing to say. But that started the Tesla Owners Club. We gathered for happy hour that night, and we decided we needed to kind of cross the ties. And at the time, 10 years ago, not many people had these, so we gave rides to strangers in grocery parking lots and did cars and coffee events, and we've grown it from about probably 30 of us in town at that point to about 3,000. So this is a fun club. Yeah, so if you're local and haven't joined, TeslaOwnersAustin.com. We'd love to see you at some events besides this one. And I just want to say thanks for coming.
Let me also give a massive shout out. You see all the crazy audio video equipment? These are our friends. Noah, come out here. Corporate Streams. Oh my God, dude. These guys are next level. Everybody, please give a hand to these guys.
Let me tell a little story about this.
Okay, go for it.
So these guys are like, do you want to host a panel for the 10th anniversary? I'm like, of course I do. And then he gets, I'm telling him about it. I can't remember if you told me or I told you. But he's like, I'll be in San Antonio, I'll be producing this movie. This guy has produced like the Oscars and the Grammys or some crazy stuff with all this equipment here. He's like, I'll come down and I want to produce for y'all because I just love this stuff and I love the community. So this is the kind of, I feel like strength and the magnet of this community brings so much talent together. And honestly, Noah, thank you so much. Because this is a lot of work. Thank you. Corporate streams.
Earlier, I'm sending a bunch of the Tesla execs videos of our audio video setup, and they're like, oh my God, I think you guys have a better setup than we do. So all those guys are actually on their way here. We have a ton of Tesla employees, just kind of mixing, mingling. So introduce yourself, say hi. If you want a job at Tesla, there may or may not be some recruiting people here. Yeah, thank you guys so much. I just want to finish off by saying thank you so much to Matt and the guys that founded the Tesla Owners Club. This dude for 10 years has been supporting this club on his back. So thank you so much, Matt, for doing that. If you guys need an amazing realtor, it's one of the best realtors in Austin. I know a ton of us are thinking about moving to Austin, but hit up Matt, get his business card. He's the #1 agent at Compass and sponsors everything that we do. So just a little bit of a way to thank you, man. Appreciate it. Yeah. We'll let Farzad take it away. Yeah, thank you guys so much. Enjoy your time.
Thank you, guys.
We're going to be here till 2 a.m. So again, pace yourselves, have fun, let's have a good time, okay?
One drink, one water. One drink, one water. Okay. All right. I don't listen to my own advice. Tell you what. Okay, cool. So this is what we're going to do now. We're going to get Herbert up on stage here. He's going to host the panel with the wonderful Alexandra Mertz, and we got some folks here remote as well. So please welcome on the stage Herbert and Alexandra.
Hey guys. Hello. Yep. Ready. All right, man. Thank you so much, Farzad. My name's Herbert, and just before we go and start, want to give Farzad an incredible shout out. He is the most professional. He is a pillar of our Tesla community. Thank you, Farzad, for doing everything you give. So that's what I wanted to say, and then I found out that he's only good because of his producer wife, Cindy. If it wasn't her, I might be just about as good as he is. So I have a YouTube channel called Brighter with Herbert, and because you guys are calling Cindy producer wife, my wife wants to be called Brighter Wife, and she wants to meet you, producer wife, yeah. Okay, so what we're gonna show you is a panel. It's a podcast that we do every Tuesday. It's called Cyber Bulls. And it is about people who love Tesla, who love investing. So we're going to talk about that. I'll introduce the panel members. But before we get started, who here loves Tesla? Okay. Who here, raise your hand if you have an investment in Tesla. Do you own Tesla stock? Okay. Now, there's several kinds of investors, and each one of us represent a different kind of investor, and we kind of debate with each other whose style is better. I want to know from you guys, and you don't have to raise your hand if it doesn't fit your style, and you can raise your hand multiple times, okay? So the first kind is, are you a long-term investor? Are you a momentum investor? Just wait. Long-term investor, momentum investor, or you're an options trader? Okay, let's get started. Raise your hand if you're an options trader. If you trade Tesla as options. Just a few folks, okay? Do you believe in momentum trading? So if Tesla was high, like it was last year, did you sell Tesla? Ryan, no way. Okay. So very few people would sell Tesla in this room, okay? Because I think if you buy Tesla in the morning, when it's low, that does not mean you're a momentum investor. Okay, who here is a long-term investor? Like you will just hold it forever. Okay, wonderful. Okay, so let's get started. Let me introduce you to the Cyber Bulls. This is Alexandra Mertz. She is known as, I guess you guys all know her. Yeah, she is Tesla boomer mama, and we call her the Power Bull. And the reason why she's a Power Bull is because she gets shit done, right? I mean, she is the person that single-handedly got investment-grade credit rating happening. And so she went all in on Tesla a few years ago. And so she started to follow who are the big whales, investment firms. So if you want to follow her Twitter, you'll know who's doing that. And she also has an amazing Substack, and she keeps track of all her latest one is a full deep dive on all the board members of Tesla. So thank you, Alexandra. Welcome.
Thank you, Herbert. Thank you for having me here. And thank you for being also nice to me, because that really helps. I was super nervous, and I think this is going to go just well. Thank you very much.
Okay, next up is Christian. There he is. Christian is our momentum investor. We call him the Stoic Bull. So the guy thinks that he can buy when it's buy when it's low and sell when it's high. He's been timing the market, he told me, since he was 5 years old. Is that right, Christian?
That's a long time ago, Christian.
We can't hear you, Christian. Okay, so he's actually an ex-financial advisor, but do not take anything we say today as advice. But he's amazing. He's actually done well that he's actually retired. He's a little too young to be retired at this point. Okay, next up is Xander. We call him the YOLO Bull. You only live once. He's young, And the guy, now that's a real all-in, okay? You tell me if anybody sold your house to buy Tesla. And tell me if you actually bought a Tesla Semi. Anybody in this room have owned a Tesla Semi? Yeah, one guy, right? Earlier this morning, we had one guy. This guy bought a Tesla Semi. So he has 5 yogurt shops, and he's busy, but four yogurt shops only. Once the 5th one come in, and he is the expert in options trading. So both these guys have been teaching me about momentum investing and option trading. And then we have Jeff Lutz. Jeff is the rational bull. When you hear him talk, you'll hear rational thinking, okay? Not like us. So Jeff is this guy is a senior executive at all the big name companies you can think of. You name them, he's been a consultant for them. He's actually consulting now with some big names that we're not supposedly allowed to talk about. He's an expert in supply chain, factories, anything to do with quality. He's the guy that knows what to do. Okay, let's get started. This is Cyber Bulls. Go ahead and play it. Noah, go ahead and play. Can you play? Okay. Should we get going? Yeah. What?
Still the same company. Company is still executing.
The energy is bigger than the auto business.
I'm the young bull that talks a lot of smack.
All right. That's great. That's okay. We'll get going. All right. So the first question is going to go to Alexandra, right? So we just watched an incredible Investors Day presentation. It was a long presentation, right? My first question to Alexandra, the perfect person to ask is, was this the right presentation to the right audience, right? So we heard that there's 250 people there. 200 of them were institutional analysts, and 50 people were retail. Was what we saw the right thing for them to do for this audience?
I don't think it was 200 analysts. I think that some of them were actually institutional investors straight away. I can't. Better? Okay, there I am. I'm sucking it up. Okay, so I don't think it was 200 analysts. I think it was about half of them analysts and half of them real investors, institutional investors. Now, I was a fund manager before. If I would have never known Tesla, I think this was very interesting. Much too long, no doubt about it, but once you're in there, what do you do? So they really retraced the whole history of Tesla and the whole future vision. So for somebody who wants to invest on the long term, and that's what Tesla is after, having long-term investor, I think this was the right presentation. Now, was it really lots of new news for us retail investors who are, very motivated and know so much about Tesla and breathe Tesla every day? Probably not. But for that public, for those investors, I think it was exactly what was needed. A little bit too long, but hey, that's it. But the content was there, yes.
Okay, fantastic. Xander, are you here? All right, so this guy made a big, giant bet before today. So most of us here, we said, is long-term investors, right? So we don't care about what happens this week. This guy made an options bet. Can you tell us what you think is going to happen to the stock tomorrow and this week? Can't hear him. He's muted.
This is technically challenged.
Can you hear me now?
Yes. Good.
Awesome. So I don't know anything more than you guys do. I just trade around the margins. Most of my portfolio is very long. I haven't been very active, but I sell puts and I sell calls against my portfolio to generate some income. And so I had a put open, sold a put of 180 earlier or last week on Friday, and then I closed it out on Monday at about a 75% gain. It's not tremendous money, but it helps pay for any margin interest that you might have if you're playing around with that. But you said options expert. I would not say that at all. I learned this stuff on YouTube, for crying out loud. So don't listen to me. But I did sell some calls out to 250, 250 and 260 for this Friday. So I don't think we're going to get this crazy pop. I think that the investing world still doesn't understand that this is it isn't just a car company. So until they get it, we're going to continue to trade sideways for a little while.
What's going on? Okay, so that's a good time to ask Christian then. Christian, is Tesla still a car company? Did what we hear today convince the world that maybe by now we're actually an energy company? Is this finally going to change the momentum and we're going to see the re-rating of Tesla's PE? Because you've been very upset with the PE ratio. Tell them everything. Tell them about how it compares to Chipotle. Come on, tell us.
So yeah, hey everybody. I love it. I love this conversation. So I think this was, I think Farzad summarized it well, and I think Alexander summarized it well. If you don't know Tesla and you don't breathe it and eat it every day, this was a great introduction of what they are. And I absolutely think, of course, I don't know if the market will get it that they're not a car company, but I think more investors will, more institutions will. I thought it was fabulous. My brain hurts after this, I have to say. But I thought it was a fabulous presentation. We got to hear from everyone. We got Tom Zhu. I loved him. He was clear and concise. We heard from, and what I heard, just for the audience, I heard 40,000 a week, which if you equate, that's 2 million vehicles this year or close to it, 52 weeks, right? We kept hearing 40,000 per week. We heard Franz reiterate Cybertruck. That's a big deal, right? And he said it's coming this year. He reiterated that. We've heard that numerous times now. Cybertruck is coming this year. We don't know the exact volume, but that was huge. So we heard some little nuggets that we know, but other people might be hearing, and they get the sense of that this team is confident that Tesla is more than a car company. They talked about their mega packs. They talked about FSD. They talked about the bot. I love the bot. I think that's a game changer for labor. We need labor. And I was thinking maybe a hammer in the hand. We saw it with a motor tool in there. So I love that. I would love to see it in person, but few high points right there. But I thought it was a great presentation. I think it'll take some time to sink in, but I thought overall it was well done.
Okay, surprisingly that you actually got moved by this presentation, because I have a little different opinion on that. So as we were watching this presentation, we were chatting with each other, okay? And a couple of big points happened. One was when Tom Zhu came out, Alexander was like all over googly eyes, loving Tom Zhu. And I'm like, I'm supposed to be the love of your life. What happened there, man?
Sorry about that, but I was really happy we saw him. I mean, we've been waiting for such a long time, and I think he made a really good impression.
Oh, he did. So, and then the second part that happened was, as soon as we started talking about supply chain, that's when Jeff Lutz got all excited, and he started talking about, oh my God, this is the biggest thing that's ever important for Tesla. What did you hear about supply chain and demand?
What I heard is every company that makes auto products or energy products, they have engineers that do industrial design. They have engineers that do vehicle engineering. They have engineers that do factory design. What you heard differently here is they're organized fundamentally differently than other companies. And they bring in-house things that are done at multiple different companies and subcontract it out. And then when you kind of put that final product together, it may not be exactly optimized the way you want it, or you may not be able to recover from a pandemic the way you can at Tesla. So analysts and investors should really take away that this company, and this is very hard to copy, because these other incumbent companies, even newer companies, they're organized fundamentally differently. I would say the newer startups, if they can stay capitalized, they have an opportunity to be more nimble in how they're organized and to be more functional in terms of how they're organized. But this company is organized fundamentally different. You just did not hear just engineers speaking to slides. And they have metrics on themselves around simplification, and around simplification that enables scale, and it permeates through every person in the organization. You heard it in the presentations. It was clearly tied together. I thought it was fantastic.
So I've got a question for everybody here, but I want to ask the panelist members first. Quick 1-minute answers, okay? Did you guys think you heard something new? Okay, other than Giga Mexico is official, was there something new? Let's go down the list here, and then I want to ask the audience what you guys think.
Well, I would need a minute because there wasn't much new for me. But I mean, then again, we're every day on Twitter, we're every day on it, and this wasn't for us. You know, anybody that was hoping to get in and didn't get in, now it's very clear why we were not there because we knew all that. This was not for us. This was for educating institutional investors because Tesla wants that money in for the long term, and that's normal.
All right, go ahead, Christian.
Yeah, I agree with Alexandra. I don't think there was anything per se that was new. I mean, I look at my notes. I don't think anything that hit me is, wow, that was completely new. So I think it was geared to the institutions and people that are not invested in Tesla to show what this company is about.
Okay, Xander.
What stood out to me was the slide that had the van and the smaller car, the 300 million and the 700 million. So that was the numbers that were communicated is what I geek out on. So trying to wrap my brain around the scale of the energy requirements, all of those things are. That was the message that I saw, was that we're not just a car company. We are all about energy, and we're very mission driven and very focused on the long term, not just, they said it several times, not the next quarter.
Okay, Jeff.
Yeah, a couple things stood out to me, actually. I was pleasantly surprised. One, I think I predicted, but anyway, a lot of people thought the Gen 3 rollout was going to be a car type. Vehicle type, and what they said is that Gen 3 is a way of engineering and making cars at a much reduced complexity, and it's actually going to permeate in multiple form factors. So Gen 3 is not just a lower tier car; it's going to permeate into multiple form factors. I think that was new to hear, and I thought the energy ramp on the energy side, the Megapack side, it looked a little steeper than maybe others have been talking about in 24 and out. So those are a couple things that stood out to me.
Okay, so let's ask the audience. If you guys raise your hand, did you guys feel like there was something new other than the Gigafactory Mexico? If you thought something was new, raise your hands. Okay, that's very few people. And I actually agree with you guys. See, these panel members, they're like lost in their own world. I was disappointed. Okay, I mean, what I was expecting was they were going to show the Gen 3 platform. I thought they were going to talk about the margins for the Megapacks. They talked big picture, but I think as long as they talked about how they're going to reduce margin and operating margin, improve operating margin over time, that's what possibly could make the investment firm wake up. And the question is, are they going to piece that together? You know, no? People are shaking heads? No. No trust on that. So are we here happy with what we saw? Are we still excited, or were we dejected? Or are we just, Tesla bull fans who are expecting, the robot to come walking and do, flips after 6 months?
I would like to add something to that. I was actually surprised how confident they are already in executing Master Plan 3. I had imagined that Master Plan 3 would give some enormous goals that were, a real unattainable objectives. And they were reassuring from the start, saying, we can get there. We'll make this happen. This may take 10 years, 30 years, but we'll make it happen. So I thought that was quite surprising.
Yeah, but let me ask you this, okay? The very first part of the presentation, they talked about the macro, right? And they talked about Master Plan Part 3. But when I heard it, they were talking about like what the whole world needs to do and that it's achievable. And what I didn't hear is what is Tesla's part in achieving that. They weren't saying we're going to do all of it, were they?
No, they were not saying they would do all of it, but they're going to be a major player in that. There is no doubt about it. But I think it was important to show that that's where the world has to get to, and that's where the world can get to, so that other people do the investments too. Every slide showed the trillions of dollars that need to be invested. I mean, it's not going to be Tesla by itself going to invest all those trillions. These needs governments, these needs a lot of institutional investors and all that. But I think they laid out that this is doable and this is now.
So the panel members on remote, what do you guys think about the demand question? I mean, I thought it was already settled. Wasn't it already settled? Why was that continue to be asked? What do you guys think about their answers?
Well, I think demand, we've already been established that we don't have a demand issue. They reiterated 20 million how many times did they keep saying 20 million? They're still their goal, right? 20 million, and they reiterated that, so that was a sign of confidence to me. Zach was great talking about, cost, taking cost out, right? This was, I think people, and I saw this on Twitter, this was not announcement day. This was investor day. They were giving a broad vision, right? Elon already said, this is for investors and investors of the earth, right? They're trying to get to a sustainable future, right? And how are you going to do that? They can't do it themselves, but I think Tesla's going to be the biggest player getting us there, right? So they laid out a very general and very specific framework on how they're going to do it. And now they have to implement it. They seem confident. Drew Baglino said this is nothing that's out of reach. They showed the scale by saying this is 1% investment over time. We can do this. There's nothing holding them back from lithium and nickel. They can get it. They're going to do what they have to do. And now when you invest in Tesla, you have to trust in them that the team's going to get the job done, right? So that's essentially what they laid out. They laid out for you how they're going to get there. They gave you specifics and they gave you generalities. And now we just have to wait and see how the next few years play out. And I'm confident they're going to get done what they said they're going to get done.
Okay. Yeah, we'll put Christian. Go ahead.
Oh, sorry. Go ahead, Xander, please.
I just thought this was a great vision casting, and they did give little nuggets as we're discussing it, like the permanent magnets in the motors. I thought that this was a call to arms for the entire world and the entire industries, or all the industries, to step up, as this is something that needs they need help with. So I don't think it's a product announcement, as you guys mentioned. I think it's a very broad view, and to get people to invest, that's what was necessary. Go ahead, Jeff.
I think Christian said, well, it's not announcement day. This is how they're going to get there. And my thesis has always been is that they're going to show the way to scale through economics, and they're going to show their approach internally and how they're organized, how they do their work, how they have their goals and metrics. And when they achieve those goals, how it brings down the total economics of what they're building and makes it more available for people to buy. It's like, it's pretty clear. It's not putting the vehicle out there and then saying, we'll figure out how to build it. I think they kind of said, like, that was Tesla 10 years ago, and maybe even a little bit on the Model 3. And now they're more about, like, here's where we need to be at in terms of in economics and in volume. And this is how we're methodically engineering. We're organized as a different company with a different approach than other companies that make this stuff to get there. And whatever roadblock is in the way, we're either going to partner with somebody in the industry, and if they can't figure it out, we're going to do it ourselves. So I think as an investor, those are pretty powerful messages, and they're well thought out. They're very well thought out. And finally, I'll just say one thing. I've been in leading supply chain and at mega cap companies for 20 years. I've never heard a head of engineering or a head of industrial design like Franz on the ID side and Lars. I've never heard talk like that in terms of simplification, in terms of bringing the factory team in concurrently. I've never heard that. Does it happen? Yes, it happens at other companies. Does it happen to the extreme, and is it as natural as it is in Tesla? Probably not.
I agree with that. And I think one thing I really kept in my mind was that sentence, no buffers, no waste, right? When they compare it to the OEMs, and I don't even compare anymore, it was just, that's the old way of doing. We did it that way 10 years ago. That's how we do it now. No buffers, no waste. And I also like the little nugget when they referred to Toyota, where tear down the Y, right? I mean, they had to slip it in, and they were clever in doing it. I loved that one.
Yeah. Well, let's talk about the team, guys. Was it my imagination, but was Drew Baglino like kind of taking over, like having a lot more of a presence? Zach Kirkhorn had a bit more presence. They presented Tom Jew and then all the others. What'd you guys think? I thought it was good.
I loved Rebecca. Who loved Rebecca? Yeah! I mean, isn't it great that we have the ladies now up there? I mean, she did a great job, very relatable, talking about the charging network. I absolutely loved that. The depth of the bench was great today. I mean, I needed to see that depth for a long time. We always had only Elon, and obviously lots of the earnings call, you don't have any images. So I really liked that we saw them all today, that they all had their part to contribute. I mean, some of the stuff I didn't understand the word they were saying, but it all looked impressive, and everybody seems to be so passionate about it.
Okay, it's just a little bit controversy here, guys. I'd have to kind of give another different opinion, sorry, but as much as I like Rebecca, she talked about superchargers, and I was hoping that a third of the presentation is going to be about electric vehicles, a third is going to be on batteries, and a third is going to be on energy generation. I didn't want to spend 20 minutes on superchargers, although it's a massive business, it's an incredible competitive advantage, but...
I guess where you were disappointed is you were hoping that we already would have the plans for solar farms and for the windmills and all that.
Yeah, I want the solar farms, guys, and I didn't get my solar farms.
I mean, the thing again is, there was no particular product announcement, and so there was no particular solar farm. You just have to get over this. This was not about a particular... I think we'll have a Cybertruck day this year. I think we'll have solar days when they come up, but this was not today's date.
What do you guys think?
Big announcement that apparently we're not talking about. That modularity of like that slide that showed multiple people working on different components, that's a change, and I'd love to hear what Jeff thought of this. But like the way that you manufacture a vehicle, this is the production line being completely changed. Like I noticed that as you could make components off to the side, right? That to me is the big innovation here. Is that you're able to, if there's trouble, you can do things on the side without having to, stop the entire line. So, Jeff, what do you think?
That was great. I mean, they're focused on, it's like supply chain 101, but you don't hear it much at companies anymore. They're counting the number of parts they buy. They count the number of parts they make. They count the number of process steps, the number of robots, and they're focused, you even saw that in the 4680 slide. They're focused on maniacally reducing process steps or eliminating them, reducing them in time, reducing them in complexity, or eliminating them. And yeah, their approach to manufacturing and basically having a kind of a parallel process running is smart. I mean, Lars, again, the head of engineering, broke down very clearly that they're focused on velocity and output per square foot or per square meter in the factory. And they know how to measure themselves. And Drew said it, he goes, if you don't measure it, you're not going to focus on it. You're not going to fix it. And they have, if as an investor, I feel very good about what they measure, because what they measure is going to enable the economics, one, and two, it's going to enable the scale.
Okay, let's get back to investing, okay? I'm going to do another audience survey. So everybody, just, if you have Tesla stock, raise your hand. Now keep your hand up, okay? And only lower it if you bought Tesla before 2020, okay? You keep your hands up if you bought Tesla before 2015. And then keep your hands up if you bought Tesla at 2012. Only like 3 of us, 4 of us, 5 of us. And who here, ooh, kilowatts. There you go. Keep your hands up if you bought Tesla at the IPO 2010. Good
job.
We have one guy.
Well done.
Okay. One guy. And the other person that I know that did this is Amy, and she's going to be joining us. She's actually at the factory. She's one of the top 50 with a golden ticket. And she not only bought it at 2010 at the IPO, but she went all in at 2012. So that is commitment. So for people like us who's invested, do you guys feel like, I mean, we had a rough year, 2022. What were you expecting 2023? Are you guys happy with where we're at? It's flat. Okay.
I think you should ask the question, who thinks it's going up, who's going sideways, what's going up?
All right, go ahead. Well, let's have Christian. Why don't you ask that question to the group?
Yeah, so, you want me to ask a question? What? I'll respond. Here's what I think about. So yeah, Tesla from 2019 to 2021, 2022 even till we sank. We had an epic run, right? Like a 20x, amazing returns, amazing. You know, the market was full of liquidity, and I get all that. And then we came back to earth. A confluence of events happened with a lot of things going on that I'm not going to get into, but it caused the stock to be depressed. Now we've rallied off the bottom hundreds. I was buying in that area. I saw great value. And now we kind of doubled off that bottom. And now we're kind of consolidating. Now, who knows what's going to happen? But if Tesla can execute this year, and I think a lot of people are thinking their earnings per share is going to go down. So that's why I think the stock has come in. If they can get that earnings per share, grow it, I think Wall Street's at 4. If they could get to 5 or 6, that would be huge growth in the earnings per share, like 25%, 30%, 40%. Then your multiple could stay around here in these 50 area, 50, 60. And if you just throw 5 on 60, you got a $300 stock. So we could still see a nice return into the end of the year. So I think it all comes down to, can Tesla's operating margins hold up? Can they deliver close to 2 million cars? And if they can, and with the mega packs growing and energy being more of a consistent driver of the business, if they can do that, I think they're going to be fine. And I think the stock will hold up well this year.
Okay, what is everybody's estimate of the earnings per share for 2023? We know that the analysts are saying $4, but with this Investor Day, I felt comfortable that they're showing that they can keep the margins up. Bradford, what is your estimate of earnings per share for 2023? And has it changed based on what you saw today? $5.50. And did it change based on today? Not really. So you are, okay, there you go. That's an analyst for you right there, right? Because you are an analyst. You are an investment firm, right? But I'm still at 7. What are you guys at?
Well, I hope they get to 6. This is going to be a tough year. They had to reduce prices before they could really cut the operating capex. So let's wait. 6, I think, is a little bit high, but let's hope we get there.
Okay, and what do you guys, Andrew, what's your thinking?
It can easily be over 5. I agree with Alexandra that there's things that this year are going to be a challenge, but I really look forward to the Fed making some sort of pause, and then that will hopefully allow Tesla to shine. There's that big. It's scary, right, for an investor in this climate. So that's what I think about.
I'm saying though, right, because we heard Tesla talk about the operating margin. That's what matters. They just spent a whole 2.5 hours telling you about all the ways they're going to lower the cost of the car, and they shared that to you, but that went over everybody's heads, and we're thinking, no, it was perfect, right? It was perfect. So if the analysts heard that, Larry, you got to come up here, buddy. You can't hear you at all. So
taking the long term to the medium term.
Louder.
Can you hear me?
Yeah.
Yeah. I think you're mistaking the time scale. There's short term, medium term, and long term. Everything tonight was focused on the long term. Somebody asked me at the bar as the presentation was ending, what do you think? I said the market's going to go down $10. Yes. And it did. Why? Because everybody's looking for the next big thing today. It's not going to happen. I mean, what they're talking about is medium to long term. And people are not looking at that. But that's the value. So you're talking about what's going to happen to the stock this year. Who cares? Really, who cares? It's what's going to happen to the stock next year and the year after. And we're going to see some really massive rise. Listen, I lived with Amazon down in the bunker fuels state for years. Yep. And we're going to go through that process with Tesla. But I mean, what they're talking about today was classic Elon. It was all strategic, not local, not today, not tomorrow. Yeah. It's all strategic. That's what I think.
Yeah. I mean, totally agree with you. We are all in this room long-term investors. We all feel the same way, so I agree with you. So I guess there was two things that I wanted to hear, right? One is change the narrative that we're not just a car company, and they talked about energy, but everybody says long-term, long-term, long-term. So forget the impact of the stock this year. And the second thing is margins, right? Can we lower it and stop calling us a car company? We've been re-rated as a car company this year, and I can't stand it that people are saying, yeah, this is the right price. 200 is the right price. It's not. So yes, I agree with you that, you know, we're talking long term, but I also don't agree with you that it should be 200 today. So that's just my own thing. I mean, we have this kind of debate every day. What do you guys think? Come on. Christian.
It was Larry who said we kind of just went down to the bunkers. You know, we hit almost like 75% down off the high. So, you know, we've taken a beating. So I agree with him, you know, long term. But here's the thing now. We're going on, you know, we've been around these prices for 3 years now. Overall macros, the stock's had a great run. But, you know, if you go 1, 2, 3, 4 years, I know everybody talks about 2030, but we need to see some progress in the next, you know, I would say 2 to 3 years, right? You don't want to just be languishing for too long, especially if you're executing, right? Because then the market's not understanding what you're doing, right? If your earnings is coming through like Tesla's has been, and we're not getting rewarded for the earnings growth, and we're not getting rewarded for the multiple businesses that they're scaling, and we're not getting rewarded for the innovation, and we're not getting rewarded for the AI talent, we're not getting rewarded for anything. You know, we can sit there all day, but, you know, at some point, you need to recognize value. And they talked about buyback. That's one way to do it, right? Buy back your shares if you think they're undervalued. That's a great way. Long term, Apple's done it over the last, you know, decade. That's where a lot of their earnings growth has come from. And people like Buffett love it. You know, buy back your stock, right? They've talked about Elon's in favor of it. That's a great way, medium term to long term, to really give shareholder value. So I don't know. I just think these are things now that we're becoming a cash flow machine that Tesla has to think about a little bit more. I know they have grand designs of getting to 2030 and 20 million cars, and I'm on board for all of that. But you also have to look at it from a shareholder value perspective. And, you know, people that hold the stock for 5 or 6, 7 years want to get some return over that period of time. But I agree with the long term, and I agree with what you're saying.
Okay. So, Alexandra, what do you think about capital allocation? You're the person to ask. Were you happy with what you heard?
I didn't hear enough. Right? I mean, we were really waiting for certain numbers that institutions can refer to. It doesn't matter to me today, but hi, Sandy Monroe.
If you can.
There you are.
We're going to steal you. We're going to steal him. Sandy. Woo! So, Sandy, did you?
Remember who I am?
What?
I'm the financial analyst.
Yes, yeah. Okay, I saw you, Sandy.
Sandy, come on, come on. We're live. We're live.
Is everybody happy? Here. I just asked if everybody was happy. But I really, what I want to do is brought some trinkets. So I've given some of these away to folks that I know. Here's one for somebody.
Yes.
Whoa! Very good catch. Okay, now, how many people here are shareholders?
Yeah, we all are. What's this? What are you giving?
These are what you need.
What is it?
Money clips.
Oh, they're money clips. Money clips.
Money clips.
For shareholders.
For shareholders.
You gotta throw it farther.
Wow, that guy should be in ball. I'm telling you. Woo! Okay, what else we got?
Take off your shirt, Sandy. That's what you did last time.
I'm not taking any shirts off. No way.
One more, yeah.
Woo! Did you get it? Try again. Okay, last time. There you are. Oh, wait a minute. I got two more. 1, 2. Oh, and I got one of these. Who wants a thumb drive? There you go. All right.
All right, Sandy. So when you saw...
There you go. Okay,
all right.
Now I can... Where'd my beer go?
Let me hold your beer. hold my beer.
No, I don't trust you. But anyway.
All right, Sandy, when you saw that, when they showed you how they can collapse the Gen 3 platform, that they're going to change it so that it's all like coming in together and totally redesign that, did you have a conniption? Did you go crazy, or were you like, yeah, I knew this was going to happen?
I was hoping it was going to happen. We've been, as you probably know, I don't know shit. Just ask any of the guys that are regular OEM kind of people. But we proposed almost everything that they were talking about. I'm telling you flat, Elon Musk, I mean, I can't get anywhere with the other guys, but
You proposed
Elon
this
Musk,
to Elon, you think?
No, I've been proposing this for like 15, 20 years, but I couldn't get anybody's attention. And now Elon Musk, I'm telling you, that he's like magic. Even if you've got a good idea, you can't get it through with some of these guys. So your shareholders, I'm going to start the day off the right. I think that in probably about 3 years, maybe less, your shares, based on what I saw, are going to be worth about $1,000 each. No problem. No problem. Yeah. Oh.
Now he's going to have to drink your beer. Drink your beer.
Yeah, there we go.
What?
We used to be sitting here. We're all, yeah, so you
He has to
gotta
drink
get
his
you in
beer.
this
When he says a
green here.
statement like that, he's got to like take a drink, take a swig.
Yeah.
Do we trust Sandy? $1,000? He's not a financial analyst, guys. So were you? How much margin reduction did you see by hearing the whole presentation, which was designed to tell us how they're doing operation efficiencies? Do you think that it's going to actually reduce margins this year, or like everybody said, oh, that's like 3 years from now, that's a year, 5 years from now?
They said 50%, and I believe it.
When?
I believe next year. So at the end of the day, everybody's saying, "Oh, Tesla won't make any money." Oh yeah, right. Tell me another. They're going to make tons of money. I'm telling you flat, and they're going to just gobble the market. And if I'm pretty sure there's going to be a couple of early adopter OEMs to jump into the fray with Tesla charging stations, and those guys are going to survive, and the rest are going to be fucked, and that's all there is to it.
Okay, tell the truth. Okay, you got to tell the truth. Were you expecting a reveal of any vehicle today? Gen 3, compact car, the robo-taxi. Did you expect the bot to make an appearance like some people were talking about?
No.
Bull, come on, tell the truth.
I did.
Tell the truth.
No, what I was expecting was the Mexican thing. That's the worst kept secret in the EV world, and that came to pass. And that's really the only way that you can hit a $25,000 B-size vehicle. That's number one, and number two, I can tell you right now because I saw it in the video. So they threw out a bunch of hints.
Yes.
So we walk through the factory. We got the factory tour. And they had hints laying all over the place. And Corey and I, where is Corey anyways? Must be drinking, yeah. Oh, he's over there. There he is. Okay, good. Okay, so Corey spotted that we were walking by this inspection booth / prototype production kind of area. And Corey went over and he said, hey, that's not the same inverter. That's got 24 MOSFETs. I see, and he says, that can't be. That's not the right thing. So we walked over, and they have guards, and Corey walked over and counted them to make sure that there wasn't 16 like you normally see, and then I went over and I tried to find out what else was going on, and I saw this casting that didn't look like anything I ever saw before that came out. So that was one thing that was a big deal, and that's for. That inverter will be for something big, like it may be for the what do you call it, the cyber truck, but I bet you it's more for something bigger than that. Maybe the semi, yeah. So and then my best thing, I've been talking on my channel or our channel for quite some time about, hey, you know what, Tesla should go to hairpin motor design. And I'm sure that means nothing to everybody here, but at the end of the day, there's two kinds of motor designs. The one they got right now is like a wound motor, but a hairpin motor increases the power by 30%. And, yoo-hoo, yes, and on top of that, we were supposed to not talk about it because it wasn't public domain, but they showed it on the video being, all the tabs being welded together. So now it's public domain, woohoo! So I'm really happy about that too. So those are the three things that I really am excited
And
about.
it sounds like it's real, not something that's going to happen 3 to 5 years from now, like some people kept saying. So I don't know. Maybe margin might be impacted this year? No? Okay.
I'm telling you what, they're going to make a shitload of money. I'm not allowed to buy Tesla stock straight out, but my agent who takes care of my money, she said, "Oh, Sandy, I think that we're going to invest in Tesla stock." And I said, "Well, if you must." So that's hands off. I didn't do it. So.
All right, man. That's
I may be able to retire one of these days with Tesla stock. Yeah.
Yeah. That's secret information. Did you see the potential induction charging? So in one of the photos.
Charging, I know that they're going to do it for sure because everybody is looking at it and figuring out how to make it happen. And but I think that the big deal is when they said that they were going to lengthen all the plug attachments, like for charging. When I heard that they were going to extend them by, I think, 2 meters, 6 feet, that basically told me that the next stage will be an induction charger. Instead of pulling in and muscling through the winter weather, if you happen to be in Michigan, this way you just drive up, stop, have a coffee, and then get charged up and get out. So.
Can we have a shout out for Ryan? Ryan, kilowatts. Hey, buddy. You've done an amazing job with chargers, superchargers everywhere. You found bugs. You found the secret information. Oh my God, that guy's brilliant. You know kilowatts?
Yeah, I can barely see. All I can see is that big bright light over there and this one over here. Totally blind. I have no idea. I could see that one guy waving, looking for a prize, but I don't think he got one. Did you get anything? Oh, what did he get? I cannot tell what it. What?
I don't know. Money clip.
Oh, money clip. Oh, very good. Okay,
so
good.
Do you not get as Monroe Associates? Don't you guys get private tours of the Gigafactories? Why? No.
Are you shitting me? Okay. So let's talk about why I'm here.
Yeah.
And who got me into Tesla.
Who got you into Tesla?
And Rebecca, right there.
Oh, yeah. How did it? What?
And Matt.
How did that happen?
Here's the deal.
Yeah.
Here's the deal, boys and girls. He got us in, but he did not get in himself. Thank you.
Oh, right.
Sincerely.
How did you pull the strings?
There's the other half. And by the way, if anybody wants to buy a really expensive house, just call Matt Home. Matt Home. Yeah. He sells really expensive, and he's letting us sleep in his condo that Corey and I couldn't afford the living room in. Yeah.
What? Yeah, but so you mean you have to get somebody to give you a ticket? You don't have like special one, bat line with Elon. Hey, Elon, I'm coming.
Hang on a second.
Bat line.
You need to know the real story behind this. What? What that?
Corey's saying no. Don't say anything.
No, that's for another time.
No.
That's for another time. No,
all right.
Really?
Don't say anything. All right. This
What?
is on the internet. Don't say anything. Corey said your boss. Corey's your boss, right? He's the president of Monroe Associates.
I got a shitload of bosses.
No, he's your
I got
boss.
a wife. I got Corey.
Your
I got
wife.
the finance people.
Your
Everybody's
wife.
my boss. Everybody
Okay,
says
don't
shut
say
up.
it. Corey said don't say
Yeah.
it. Okay. Corey. Hey, I have to have a picture like this because you did it with Farzad. Okay, look at that. I did more for you than Farzad did, right, in my video?
Is this?
Hey, so Corey, what was for you when you were walking and
Check,
getting
check.
that tour? You saw things, right? What were you
Check,
looking
check,
for?
check, check,
You guys
check,
are
check.
nerds, man. You're
Check,
looking
check,
for
check,
things
check, check,
that I
check,
would
check,
look
check,
for.
check, 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 check. Check, 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 check.
Well, first of all, we kept getting stopped. Sandy got stopped every 50 feet by institutional investors. It was wild. So the tour was supposed to go along, and Sandy and I are looking at every little thing. So that thing he described, that inverter that we saw, is something I've never seen. We've torn down every single Tesla that's been built. So we were literally sketching what it looked like. We were writing down the form factor.
It's been a long day. Yeah. Anyway, in my pocket, I got my little sketchbook. Corey sketched it out, and that's where I got all of the all my notes.
So, and the biggest takeaway I saw was the announcement of transitioning to a 48-volt architecture for the whole vehicle, particularly because they're going to insource 100% of the electronics. That is huge, absolutely huge, because the entire Tier 1 and Tier 2 supplier base has been 12 volt for the past 50 years.
More than that.
100 years.
Yeah, 100 years in.
So being able to control all the electric architecture and shift to 48 volts is going to cut so much weight and waste out of the vehicle. They're essentially departing from the entire automotive industry and saying, do this or fall behind.
Wow.
Right. The other thing that you should know is that I'm doing this from memory, but this will save 50% of the weight. 50% is a big number in harnesses and whatnot for communications anyway, for the 48 volt stuff. There's a lot of low voltage stuff that's inside your car. It doesn't matter to you, but it makes a big difference when you start saying, I want to go to 40. Higher voltage means smaller diameter wires, basically. And that's kind of like what you're going to see coming up really quick. And here's the other thing. When Elon takes Tesla into the 48 volt system, guess what? He just created a new market. The new market will be selling those switches and solenoids and everything else that's now in 12 volt. These clowns that were in the tier 2s and actually 2 guys, they're going to get left in the dust. So not only are you going to make money basically on cars and on the electrification of the rest of the fleets inside of the United States, and the what do you call it, power generation systems that he's putting up all over. Now you're going to be in the tier 2 supply community. What a genius, I tell you.
What was your reaction or thoughts about the software controlling the hardware? And they spent a lot of time on saying that they can actually measure everything that's happening, and they can now control the hardware if they improve the software.
Well, that's the way it works right now. But what they actually said was there's something new that they're doing with software. So what they're doing is they're taking a module, and instead of having a harness that goes here and it has a connection that goes over there and there's a little jumper cable or something like that, what they're going to do is they're going to use little isolated modules, and they're going to bring, it's basically going to be direct. And so anybody that knows something about efficiency knows that when you go direct, it increases the efficiency of everything. So that means that you're going to move faster. And you think that, wow, I switched on the light, and the light switch, but when you start looking at how quickly you need to have reaction time in an accident and things like that, this is what do you call it, edge computing, and that edge computing is really going to increase the speed that the rest of the computers can use. Plus, it's lighter and it's a lot cheaper. It's a lot cheaper.
Okay. I'm gonna broker a deal right now. Okay, Xander, get ready. Xander bought a Tesla Semi. I'm gonna let you guys buy it off Xander so you can rip it apart.
How much is it gonna cost us, Xander? Did I tell you I like you the best?
Oh!
I really do. Yeah. I don't care about anything.
I'm the agent, okay? Xander, sell it to them.
We don't even know how much it's going to cost yet.
Say it again.
I said we don't even know how much it's going to cost yet. When we booked it, which was on the last day in the last few hours, which was a total coincidence, but it was the 180,000 price. But if you look at it, you're just getting in line with the reservation, just like the Cybertruck. So, but hey, we have some plans for it, but we're open to discussions.
Sell it to them. Bradford. Okay, who owns a Cybertruck and who's got an early reservation for Cybertruck and who's going to sell? Okay, then who's going to sell it to them?
I thought you were talking about the semi. Sorry.
Oh, no, we weren't talking about semi.
Oh,
yes.
yeah, he's talking to semi.
No, I'm not talking about Cybertruck
I got
now.
5 of those. We got 5
Oh,
of
you
those
got
on
5,
order.
yeah, but who gets the early reservations? You want to give it to them? Sell it to them?
No,
Nobody
we
wants
got,
to sell it to you.
We were in on the first 5 minutes.
Wait, Ryan from Kilowatts has 52 Cybertruck. Who here has more than 52 Cybertruck reservations? No one, except for Ryan.
Wow.
So you give it to them.
Grace, where's Grace? Grace? Oh, sorry, never mind, Grace. Aaron. Aaron is looking for a really hot guy, and you obviously are, that's got a shitload of money. Aaron is one of our gals, and I was going to mention Grace because she was looking for a prince.
I'll stop him.
You don't quite look at
Your
princely
boss
enough.
just told you to stop it. This is on the internet. The boss just said so.
Inappropriate.
Yeah, inappropriate. But you know what? That's my middle name. Alexander Sandy Inappropriate Monroe. Yeah.
Wait, your name is Alexander too? Yeah. Because we have Alexandra, we have Xander, and you got Alexander.
Exactly.
All right.
And actually, I just met an Indian guy. His name's Sikandar. And
Sikandar?
Sikandar and Alexander's the same. That's why I got Sandy. It's a long story, but a lot of guys from Scotland went to India and
All right,
on and
so
on.
Corey,
Yeah.
how do you handle this guy? What is he like working with, man? Does he listen to you, or like, are you the boss, or he's the boss?
He's the boss.
You just have the label that says president.
He owns.
No, he's the president.
Yeah.
So it's tough. It's every year I add about 3 to 5 years on my life. I'm
You're
actually
looking
getting
good.
some gray hair.
You look fit.
Oh, thanks. Yeah, I appreciate it.
Yeah.
No, but dealing with Sandy is really a joy because I spent 18 years with this guy, and I spend more time with Sandy on a yearly basis than my wife and children.
Oh God.
We were
Which
on the
is
road.
inappropriate.
We were on the road for 100 days last year. Vietnam, Japan, our road trips, 11 straight days in a car, 20 hours of driving most of those days.
How did you experience the other people there today? Did they know something about Tesla? Did they ask the right questions? You know, the institutionals around there, how did you feel about them? Yeah.
I found that the institutional investors were asking basic questions. And clearly the presentation, particularly the back half, was geared towards convincing them to invest for the long term. Elon even qualified the Q&A with, hey, don't ask any like quarterly projection numbers. We want long-term investment. And my favorite part of the presentation was actually when they went over the operating expenses, particularly how they have their own internal software team that applies the same methodologies that they do on their cars on how they operate their actual business. And that struck a chord with Sandy and I because we use all sorts of third-party softwares to process our AP and our everything, our HR, and it's a huge pain. And if we had an internal software team that developed elegant software solutions for our business, that'd be phenomenal. So hearing that is not something that you would hear a large OEM bragging about because they just don't do it. They rely on third-party companies to develop software services. So I really like that portion.
So when you, seriously, when you start fooling around with CapEx and your internal operation systems like AR and AP and whatnot, most people just, they don't care about that. But here's the deal. A well-run company knows the big shots will know exactly how much money's in the bank, how much their AP and AR are exactly. And quite frankly, I have to take my hands. Okay, so another thing that I've been criticized for by not just the automotive OEMs, but OEMs in general is vertical integration. I'm a huge fan. When Elon started talking about vertical integration and what he's doing, the general population basically said that's stupid. You don't want to do that. You want to hand stuff out. But here's the deal. When you hire a tier 1 guy, he has to make money. He has to buy from a tier 2 guy. He has to make money. He has to buy from a tier 3 guy. He has to make, and all the way down to tier 6. And what I was really shocked with was, I can't remember what the guy's name was. I can't remember which. Anyhow, I'm not really good with names. But anyway, one of the guys that was making their presentations today said, we're dealing with tier 6. These are guys that basically have gravel that they grind up. That's tier 6. And Tesla is looking all the way down so they don't get caught in a situation where, you've got children in what do you call it, Congo, scraping around with a trowel trying to get cobalt out of the ground. I mean, this kind of stuff, that shows real leadership and real humanity. You don't see too much of that when you've got I hate to say it, MBA kind of people. You got to focus your attention on the world. In fact, that's what the whole topic today was. What can we do for sustainability in the world, not just a car? And that's like elevated to godlike. Yeah.
Okay, I have a question that I know a lot of people wanted to ask you, which is a few days ago, Toyota came out and said they took apart the Model Y. First of all, why didn't they pay you guys to do that? And then they said, oh my God, this is the greatest thing ever. Then Elon and Tesla said, this is great. Come on, give it to him. Give him the mic. Give him the mic.
Not a chance. No, here, I will tell you one thing. The day that Toyota with a D got sacked or pushed aside, whatever you want, and Sake-san showed up, that was the day that I changed my mind on. I figure that VW's got a lot of issues. I have no idea how they're going to pull out. I don't know how they're going to get any success. That's one. Toyota was right behind him with his stupid hydrogen shit. And when, what's his name came along, oh my gosh, I didn't realize there were so many anti-hydrogen. Yeah, anyhow. Anyway, you look this way, and now Sake-san is going, we're going that way. And that guy, because Toyota turns much faster than they're the biggest car company on the planet, and they can turn really, really quick. And so I'm expecting that now you're going to see, at least I'm going to predict 3. Number 1 is Tesla. Tesla is going to be kicking ass. Number 2, right now anyways, is Ford. Number 3 is Toyota. And then there's a bunch of other pretenders that are underneath.
Number 3 is not. Who? Wow. Kia
and Hyundai, they're in that group, but they're in high up. So Rivian, Kia, Hyundai, and Geely, who owns Volvo, Polestar, Lincoln, what's it?
Lincoln Co.
Lincoln Co. And any other one, can't remember. Oh?
Lucid.
Next question.
Okay, well, first of all, I'm shocked, but I
Don't
cannot
buy Lucid.
argue with Sandy. I did not think that Toyota will survive, and let alone be number 3. But, sorry?
I got something to add on the Toyota
go
thing.
ahead.
So think of the context of the statement from Toyota. Yesterday, they're marveling at the Model Y.
Yeah.
Model Y, their work of art. And today, Tesla announced their next generation vehicle, which will be 50% the cost of the current Model 3. Think about what that means. Tesla's making a step change improvement to cut their cost by 50%. And we costed a Model 3. And you remember what it cost when we costed it? $35,000.
$35,000, yeah.
That's what our should cost was. And in 2022, Elon Musk said the cost of their Tesla Model 3 was about $35,000.
Right.
So we predicted what it should cost Tesla to build their Model 3 back in 2018. 50% of $35,000 is what? About 17 grand, 17.5.
Yep.
You can sell a $25,000 vehicle if it costs $17,500 to build.
And make more money than everybody else. Because at the end of the day, no one on the planet makes more money per car than Tesla.
Okay, can you guys give me and Farzad an exclusive? Say something that we haven't heard yet. Will you please give me a prediction of which car company do you think will go down and go bankrupt first?
I got something in my eye. Corey is in my eye. This is kind of like
Okay, I'm not allowed to ask you that. My boss just told me I can't ask you that. Sorry.
Oh, good. Thank you so much. Thank you. Let's move on. Hey.
Why not?
How about them taggers? Yeah, right. Okay.
All right, fine. I can't ask you that question. Sorry.
No, we can't do stock predictions. Now, if I was
You just
like
did.
Hindenburg,
You just said
no,
when
no.
you walked up here, you said $1,000 in 2 years.
Andy, this is
Yeah.
on the internet. Remember?
Yeah, I know. So here's the
years.
thing. That's why we have to move away from that. So I would like to tell you that's the cutest dog in the whole place. Yeah, there you are. But you know what's really pisses me off? And I can't stop? Why is it that Hindenburg can destroy a company and sell short? Why is it that they can get away with that? But if you encourage somebody to buy in a stock, you get thrown in jail. So you've got some clout. You got congressmen and senators. Ask them, phone them up and say, hey, before I write this check to whether you're a Democrat or Republican or communist or Nazi, I don't care which. Before you write a check, ask them, are you going to do anything about short selling? Yeah.
Can we have the panel members
So
here?
Corey
Christian,
is getting very unhappy. So
Christian,
I'm gonna pass-
Xander, and Jeff, can you guys ask a question? You want to ask them? You've got them on the panel here. Go ahead. What have you been burning to ask Sandy and Corey a question?
No, I love the discussion. I love the interview you did with Corey, very insightful. I love Sandy's humor. You're cracking me up tonight. I love it. So I guess the question I would ask is, so tonight you've seen a lot without giving any trade secrets away. We know Tesla's way ahead, and Corey just talked about costs going down, from 35 to 17,500, which is incredible. Do you see? And this is just a general question. Do you see with the reduction of the sales price that Tesla has announced, do you think that their gross margins will hold up with the cost of the car coming down and the efficiencies they made in the new factories? Do you see the gross margins holding up where they were last year, or do you see more of a dent in those margins? I would love to know that.
Sandy,
See it.
Sandy's gathering his thoughts.
Yeah, I was listening when they were talking. I just don't. I was writing an awful lot, but I can't remember where it was. But it doesn't really matter because when you drop the price by 30%, and that's kind of like the number that I've got stuck in my mind. I can't remember anybody's name, but I do remember numbers and I do remember designs. And I think that what they said was they're decreasing the cost of the Model 3 and the Model Y by about 30%. When you decrease the price, the cost by 30%, and then you come back and you say to the general buying public, hey, you know what? We'll toss you a bone, and it's still going to be more than everybody else. It's still going to be 30%. I mean,
Sandy, I've been sipping on that the whole hour. He comes up and you've been sipping on your beer the whole day, and he's like, takes here, it's seconds. He just finished it. Anybody else? You guys, Xander or Jeff, you want to ask him a question?
Go ahead, Jeff.
Yeah, I was going to ask if Corey would chug a beer. No, I was going to ask if you saw anything related to the construction or individual components of the Cybertruck that were surprising or different than what you perceived before the tour.
there was nothing super different. We saw that it had air suspension, and we knew that before. The lines look a lot crisper. This is a pre-production kind of a car, so I'm pretty happy about that. We weren't allowed to get too close. They had a red rope and people in back of it that were bigger than me. So actually, Here's a little funny story. I told I talked to the guy and I said, really what I want to go and see is I want to see how you've implemented the Hydra presses. And he says, well, we're not going to give that in this part of the tour. And I said, come on. I said, where is it? He says, well, it's over there. And I said, well, how about if I just strolled over there and, you know, and the guy said, I don't think that would be recommended. So I said, well, why not? He said, well, you see those 4 big guys over there? They could kick your ass. Okay, fine. So and they were big. They were a lot bigger than where I was. So Corey could have taken them, but then he would have ran away and left me. And that's true. You think I'm just jerking you around, don't you? That is exactly the conversation. I couldn't get over there, so I would have loved to have reported on that.
Did it have a
Yes, it did.
wind wiper?
It had one window wiper, one huge one,
It is there.
along the driver's A-pillar.
Okay.
The rearview mirrors were little triangles.
Yeah, little triangles.
I posted a picture on my Twitter.
Yeah, and that's all you really need, because eventually you're going to be ripping them off, because sooner or later, the guy in Nishta that says we have to have rear view mirrors, because back in '54, when I got my job, we had rear view mirrors, and I don't want to lose my job until I get retired or died. And that's the only reason we have rear view mirrors, because they don't have them in Europe. Why have we got it? What's wrong with a little teeny camera that you can actually see, that'll never frost over? On and on. Oh, go ahead.
Okay. Can you settle a debate? So I've been saying that the Gen 3 platform, the robo-taxi specifically, the dedicated robo-taxi, is going to be built on a Cybertruck platform, not the 3 and Y. Am I wrong?
Yes.
Or am I right?
No, they mentioned it today. They slipped it in.
What they slip in?
They said the next-gen platform, and then they said the variant for the robo-taxi. It was
Yes.
very subtle. I remember it.
I heard that, yeah.
So they mentioned next-gen, not Gen 3, next-gen and robo-taxi. So I think it's going to be on that platform.
The 3 and Y?
No, the next-gen.
Which is what platform?
I think it'll be smaller.
It's going to be a new platform?
So there I have a question, Corey, because in the interview with Herbert, you said it will be a better decision to go for the van than for a compact car. Do you still have that impression tonight?
I still do have that impression, because when you're trying to move a lot of people, you don't want something that's small like a Model 3 or even a Model Y. Sandy and I have been driven around the whole time we've been here, which is really nice, but every time it's a Model 3, you know, you kind of jam in there. A Model Y is better and a Model X is amazing. So having something even bigger will actually be more ideal for moving people, especially for people who are either older in age or have disabilities. You want something that's larger. I think
You still think there's a bigger one first before the compact?
I don't think it'll be first. No.
I think that Elon Musk is a greedy guy, and I think you'll have both, and they'll probably show up at the same time. Yeah. So
All
there
right.
you go.
I'm going to put my hand over these guys. You guys clap. How much do you guys like Corey? How much do you guys like Sandy? Oh, you got work to do, Corey.
Yeah, I know.
You're not going to work? It's not going to happen?
But the thing is, I mean, I'm old. I'll die pretty soon, and
Oh.
Corey will take over completely. Yeah.
Whoa!
I'll retire then. How's that? Yeah.
Oh, no!
Okay, good. My wife will like that answer better anyway. Yeah. So there you go.
We can't have you retire. You're too important to this community. We don't know the information you know.
You know what? Pretty soon, you believe it or not, I truly, strongly believe that in the not too distant future, the other guys will be looking for, like everybody else that isn't here tonight, they'll be looking for a hero, somebody to bring them back to the Ice Age, somebody that'll, you know, talk about the good old days. And the crowd for Tesla will be basically everywhere. What's not the Duke of, the Dukes of Hazzard, you know, but you got to worry about, what was the name of that girl with the, Daisy Duke. If
Daisy
she
Duke.
shows up, then the whole thing's off. Yeah.
Yeah.
Are you shitting me?
Yeah.
Okay.
What is it?
Stand up.
This is the guy.
This is Corey Steuben,
Yep.
and he sorted it out. He sorted it out before anybody figured it out.
Yeah.
Right there.
It's
right there.
It's body side in outers in racks, and I even found an image on the internet of exactly what they look like, not all darkened out. I posted it on my Twitter, and it got like 1 million views. And essentially, it's very clear. It's just racks of body side hours. But what they were trying to say, if you look at his shirt, it's supposed to imply the massive scale, because each one of those racks holds anywhere from 8 to 12. So just that image, or the image on our invitation, represents 1 day's worth of production.
So,
Yeah.
Corey, that is a side panel, right? So what about all of us who are wishing and hoping that there's going to be a single stamp, and you guys have said no, Elon has said no, this doesn't make sense.
So think of the tonnage of the machines. Currently, they have a 6,000-ton press that makes the front piece and the rear piece,
Yeah.
total of 220 pounds, about 100 pounds each. You're going to need a press that can cast even more than that, probably 600 pounds.
People think that that's what was sent to China.
So you'll need a press even bigger than 9,000, because the amount of tonnage you need to fill up a part that big is astronomical. The machine
sense.
doesn't exist right now. So unfortunately, I just don't think that physically it's possible, but the machines don't exist
Even
right
for
now.
a compact car, because people are saying that that's why they saw the Gigapress being sold to China. They go, it's red, so it must be for Tesla.
I think you could get maybe 3/4 of a car, maybe the front and then most of the rails, where we have 2 gigacastings that connect, but I don't think you can get the whole thing yet.
And it seems the opposite to what we saw, which is instead of one cast, they said, I'm going to make a bunch of modular parts that are connected together.
Well, that's what GM is doing. They're getting into casting, but they're using semi-permanent green sand kind of molds. Those aren't my first choice. They didn't want to spend the big money. And you were mentioning China. China, they bought, so Hydra Press, the guys that Tesla uses, they didn't get that order, and it was a Chinese press company that owns Hydra. They got them, and now they're scrapping them out, and they're putting in, what's the name of those things? Anyways, the guys from Switzerland, they're using their presses, and they work really well. So Hydra and the Swiss company that I can't remember, what the hell's their name?
I don't remember.
B. Anyways, those 2 guys are, they make the presses that can make things happen, but only Hydra can make a 9,000-ton press and an 8,000-ton press reliably. So there you go.
All right, everybody. So this is Cyber Bulls. We have a regular video podcast every Tuesday on my channel, Brighter with Herbert, and you can see how the most important people show up, and we have great debates with stocks and investment, and of course, we all love Tesla. So thank you guys very much. This was a great show. Thank you for helping us pump us up.
Hey, no problem.
Thank you very much. Thank you.
And you're going to promise that I'm going to have a time with Sandy, my interview one-on-one?
Oh, yeah, he wants an interview with you.
Yeah, well, come on.
Okay.
Before you retire, come on.
Yeah, he's a good interviewer.
Yes, thank you.
Are we done? Are we done?
No, not now. Oh, another day.
No, I need refreshments. That's not water.
Don't mind us, Herbert.
Hello. How's everybody feeling tonight, man? How cool is this? How cool is this? All right, so here's the deal. Most of the folks on the next panel are almost back from Giga, so we're going to give them a couple more minutes. And then in the next probably like 15 minutes or so, we'll start our next panel. In the meantime, use the restrooms, get a drink, and then we'll get started in about 10, 15 minutes for our next panel. Sound good? All right? Perfect. All right, we'll see you in a little bit.
network. So. Oh, it is working. Can you hear me?
There you go. Can you hear me now?
There you are.
I can hear you, but I don't know how I'm hearing. Oh.
That's good.
Did they move the video village out?
No, I still see it.
I'm wondering why I heard you.
Josh, super
Might want to turn the video off. I might still send some things out. I thought I was hearing you from. I'm hearing myself back.
What do you might send?
It must be the goofiness I did with my audio. Okay, let me try that. Testing 1, 2.
I can hear you.
I'm getting my feedback. About 15 seconds away.
That's interesting.
Testing 1, 2. I don't know how feedback. Is that your feedback or is that video village?
Shouldn't be me.
Probably video village. There's another I offered to send in traffic.
Okay, but no speakers in Zoom?
Oh, there we go. I had. Yeah, I got you now. I had to.
There's another round table and you have Zoom back.
Yes, we had the first meeting with Sandy. To it.
And a fantastic discussion.
It's too much breaking though. We lost our audience.
Yeah.
conversation.
Well, it seemed like they were bringing the faders down.
Yeah, all of them. I sent several messages.
Well, that's not creepy. Are they building each other?
Watch how the accuracy with this drill is. Yeah, we're okay. I think we're safe. I don't think they got the simulcast. I checked all the other channels. None of them had a straight. Although they may for this round table is what they're advertised. So I'll let you know if I need to go to radios. All right, getting audio back.
What are you using for your super source?
I was
Are you
using
local?
OBS.
Your local machine there?
Yeah.
Okay. Didn't know if you were getting excited using your cloud assets.
Not with questionable. Well, that was fine. But that audio coming through me.
We should have original sound from them.
Hey guys. Matt again, sorry to interrupt the party. I got to make a quick announcement. I just got this dropped off. So there's a previous Tesla employee that's been a 30-year artist, and he made bull shirts, Tesla bull shirts. These are going to go on a 70-foot wide section at St. Elmo coming up. He's going to be building the mural, and we have an exclusive. It's going to be on Farzad's Twitter, and I've got the QR code here. If you want to be the first people to own something that's on the side of a Tesla building, these t-shirts are going on sale right now. So if you want to take a snapshot of this and send it out there, go for it. I'm going to leave it up here. And that is all. Enjoy.
Check. Dave Lee, please report to the principal's office. Dave Lee, thank you. Corey Steuben, please report to the principal's office. Thank you. Corey Steuben, please report to the principal's office. Sandy Monroe, please report to the principal's office. Thank you. Sandy Monroe, please report to the principal's office. Thank you. We'll see. I don't know if we'll do Q&A or not. We'll see how much time we have left. Yeah, thank you. Check, 1, 2, check. Hello. Are you guys ready for the main event? Yeah? You guys ready? Are you guys ready? Okay, good, good. All right, so we got 6 very special panelists today. I think all these folks have been at the Gigafactory, so it's going to be very interesting to see what they have to say. So let's bring up our first panelist. This is a gentleman that is an analyst for ARK Invest. Please welcome Sam Corris. Sam Corris to the stage. Thank you very much. Next on deck, from Monroe and Associates, Mr. Corey Steuben. Come on, sir. Next up, from New Street Research, please welcome Pierre Ferragut. Next up, from Retail, please welcome Rob Maurer. Next up, from Retail, please welcome Dave Lee. And last but not least, the greatest mustache in the history of the world. Please welcome back Sandy Monroe. Okay, so for those that follow my channel, you know I like to keep these very conversational. We're just going to try to explore different topics and really see where the conversation goes. I'll start with Sam. So Sam, you were at Giga. You kind of saw a few things there. Tell us how did you feel after you saw the presentation, and more importantly, after you saw the tour? What were the kind of feelings that were going through your mind? And maybe put it within context of other companies that you follow and what you saw at that facility today.
Is this, there we go. Yeah, so the Gigafactory, all of the Gigafactories are very impressive just in terms of the scale. And I feel like the presentation today was very detail-oriented. And the vibe, you know, obviously I'm checking Twitter during the presentation, and it seems like the overall expectation from the crowd was they wanted a big announcement, they wanted a shiny announcement of a next generation vehicle. But if you take a step back, it's like, what did people want? It seems like they wanted a photo of what the car would look like. And instead, what Tesla gave was, you know, nearly 3 hours of the meat and potatoes of how they're actually going to bring that car to market at that price point at scale. So I think it was a lot of these little nuggets that really make it all come together that, you know, I feel like the reaction on Twitter wasn't necessarily grasping all of those details coming together. And then seeing the factory's, you know, incredibly impressive, especially how quickly it went up. You know, they had the dry battery electrode rolls going, and you see this process going. So overall, I would say a very, very impressive day.
Okay. Thank you. Yeah, so, and I was talking briefly with Pierre as well beforehand, and it seemed like you shared some of those sort of same thoughts where there was a lot of detail that was shared that you thought was interesting. Maybe can you elaborate more on what you saw, Pierre, that was kind of maybe eye-opening or helps you think better about how to model Tesla and its potential in the future?
Yes, that's really what I liked a lot about today is the level of transparency of the company, like taking us through the fab, getting views on how many robots do you have on the assembly line, how many robots do you have on the body in white part of the fab, what's like the length of the paint shop. All this information to me is very, very rich, very valuable, because that's what I'm using at the end of the day to try and figure out how Tesla is taking costs down, how like the gross margin is building up over time. So I thought that was very, very interesting. And then in the presentations, that's the same thing, you know, like getting into the details of how much silicon carbide you will get, like in the Model 2. That's very, very interesting to me. That's very interesting to understand, and having the ability to speak to Colin, to understand what's the new architecture, the new inverter, all these things are extremely extremely rich. And I think the one thing that really blew me away is to see this, like the dry coating at industrial scale. So that's real. I still wasn't sure it was real. I saw it. And so you see this machine that is maybe the size of that space, and it's like rolling the film that will get into the battery cell, and it's going relatively slowly. And at some point, it's going to go 10 times faster. And when it goes 10 times faster, it's going to be producing 10 times more batteries. And the unit manufacturing overhead of each battery is going to be divided by 10, because the cost of doing it is the cost of using the machine. And so I think it's really, really impressive to see that, like, a couple of years after the battery day, they have delivered what they say they would deliver.
That's great to know. Maybe Rob, did you find the same level of sort of insight that Pierre did? Did anything else stand out to you that was kind of eye-opening from your tour?
Yeah, I think Sam is not on. Is it on now? Sweet. Hey, everybody. I think Sam and Pierre put it pretty well. You know, one of the things we were talking about going into the events, we were kind of having an investor meeting before, and the question came up about, okay, this next generation platform, Tesla's talked about cutting costs by 50%. How do they actually get there? And I think people are just kind of hoping that there's some like magic thing, like, oh, they're going to cast the entire vehicle, and that's gonna be the thing that does it. But I think what we really heard from Tesla today is, you know, it's sort of like death by 1,000 cuts, right? Like Tesla is focused all the way through their like tier 3 suppliers and how they can go out to those companies and help them scale their business in a cost-effective way, all the way up through delivering the vehicle to customers, and then even beyond that through Tesla Insurance and service. They're just entirely focused through the entire process about how to keep costs low, because they know that they need to do that. And that's such a contrast versus, I was laughing at this during the presentation because I always kind of make fun of Toyota, but when you're sitting there and you're listening to Tesla present about this stuff versus a company like Toyota, and they're sitting there and kind of scratching their heads like, should we make a dedicated EV platform, or like maybe not, I don't know. And then Tesla's like, not only a dedicated platform, but entirely dedicated through the entire supply chain about, you know, making this cost effective. So I think for those that follow the company closely, you heard a lot of good things that you wanted to hear today. And if you're someone that was going into the event looking for something that was a little bit more flashy, like an unveiling of some sort, you know, we got the Mexico factory a little bit afterwards. But I think if you're going into it, you're probably disappointed with like an unveiling. But for those that are a little bit more longer term focused, I think we learned a lot of really interesting and beneficial stuff. And it gives me confidence that Tesla has a good grasp of the problem and how to solve the problem as well.
Okay. So, yeah, right. It's okay. So we're getting some requests if we can maybe keep it. We're going to try to pump up the volume, but it's hard to do unless maybe the crowd gets a little bit quieter, maybe. But just make sure, yeah, we're going to try our best to get the volumes right. Thank you all very much. So, Sandy, when you hear Rob talk about this sort of death by 1,000 cuts, or like, you know, this process where Tesla's going down and really honing in on all these different things to really get the cost down, how much of that is like a moat, and how much of that is tied to, is it a cultural thing? Is it hard to replicate? Like, is it just like why can Tesla do it so well versus its peers? Oh, you don't have a mic, okay.
The reason it Okay, so every major company on the planet knows what's right and knows what areas they have to attack. The problem is that there's so many internal politics, so many internal politicians that get in the way of progress. And so I only worked for one major OEM, Ford Motor Company. I was there for 10 years. Luckily, I was on the technical ladder, not the management ladder. And I got all the way up, and you had to take management classes. And basically what they teach you is to be a little on the cutthroat side. You got to try and figure out how you're going to survive at the expense of some other department. And I think that what Tesla's done, and he said it many, many times, they work as teams. They want to take the manufacturing engineering, the product design engineering, the HR people from the factory floor, and finance, and bring them all into the same team to work on a common problem so that they can get a solution that's good for the company. And it just dawned on me when I said that. They're working for the betterment of Tesla, and most companies look for the betterment of the person. And that's what's different about Tesla.
Yeah, that makes sense. That makes perfect sense. Dave, what's one thing that was maybe surprising, or anything that was, after you toured the factory or the information that was given, is there anything that really stood out, even if it was covered here? Like, what was something that really stood out from your time today at Giga Texas?
Yeah, hello. Hey, guys. Hey, what's up? Hey. Yeah, I wish everybody could have gone on the factory tour. It was probably the best factory tour I've seen. I've been to Fremont a few times, and I saw the Austin, the Giga one last year. But this time around, the factory was just bustling. It was just pumping out cars. Every station, everyone knew what they're doing. It's just well laid out, like start to finish, compared to Fremont, which is very just kind of scattered a bit. And the thing that was the home run for me was the very end, where they showed the dry electrode machine. So they said they have 5 of them right now, and they say they're on generation 6. And the latest generation is in Austin. Generation 5 is in Fremont right now. So Texas has generation 6. They have 5 of them, and this thing they're saying is rolling out this electrode material like constantly. It's just and it's completely automated. It's like pretty much, there's some people maybe doing a little stuff, but it's automated. And they have this roll, and they have the roll in front where they showed all of us, and it was probably about 6 feet wide and probably like 3 feet or so in diameter, and it's this big electrode roll that they've rolled. And you don't need any drying time. It's just, they're whipping it out almost instantly. And then they cut this thing into like, I think 16 parts, what was it? They cut it into 16 parts, and that goes into the batteries straight. And it's like, I think Tesla is actually like way ahead of what most people think they are in terms of battery technology. They actually have this thing working. It's more about, I think, optimization and constant improvement. And they said that they're working on generation 7 right now of the machine, and they hope to have that out later this year. So there's a lot that Tesla isn't publicly announcing with what they're doing, but it ends up in the product, and that's the reason why they're able to do what they're able to do. And so, yeah, the 4680 electrode, that's just mind-boggling.
Wow, okay. Corey, how hard is that going to be to replicate? Would you consider that to be a moat? Does it really create that much of a separation between Tesla and everybody else? How do you think about that technology?
It's a huge separation, and it's a huge separation. It's a huge separation because what Dave just explained to us, they called it the mother roll. And Sandy and I asked, how long is that mother roll? And they said, it's like 1.5 or 2 kilometers long, and then they cut it into 16 pieces. The amount of vertical integration you see in the Gigafactory is incredible. Most other OEMs are outsourcing their battery manufacturing. And every time you outsource anything, there's profit margin built into that tier 1, tier 2, tier 3 supplier. So every time Tesla vertically integrates any process, they're automatically realizing the cost savings of the profit margin that they're not being charged by a supplier. And it's just mind-blowing to walk by not only the battery production, they're stamping the cans for the battery, and they have their seat line. So Sandy famously says that the seats are the most comfortable seats in the world, and they're manufacturing them in the plant. This is a cultural difference. Tesla has a cultural difference in the way that they go about designing the vehicles and manufacturing the vehicles. And one of the most amazing slides I saw was how they're going to get to that 50% cost reduction. They highlighted it was 3 things. It was the vehicle design for 1/3, it was the battery and the powertrain for the other 1/3, and manufacturing. Manufacturing is typically ignored by a lot of OEMs because it doesn't make up a large percentage of the cost. If you look at the total cost to manufacture the vehicle, it's not that much of a focus for traditional OEMs. But Tesla is intent on focusing on being able to manufacture at scales that are beyond what a lot of traditional OEMs are focusing on. So I was actually pretty impressed because Sandy and I are really focused on the technical details, and I thought today's presentation was very technical. So a lot of the investors in the crowd seemed like their eyes were glazing over, and Sandy and I were pretty giddy.
So maybe this question's for Sam and Pierre. Maybe Pierre, do you think institutionals are well equipped to understand that type of information that was shared today? Like, is there a lot of complexity there that maybe it's so different versus every other maybe car maker or type of company that reports that kind of thing? Do you think there is anything that Tesla could do better, or is it just they're so maybe ahead is the wrong word, but are they just approaching it so differently that might be hard to grasp? How do you think about that question?
So on the first part of your question, you have to know that there are 2 types of institutional investors.
Okay.
You have my clients and others.
Okay. Fair enough.
So my clients are doing all right. They get it.
And yours are the smart ones. Okay.
They are well educated. They have access to the right research, and that's perfect. For others, it's a struggle. If you know some of them, send them to me. I have the good word.
Fair enough.
No, more seriously, so the one thing I love about Tesla is that that's really the name for which you have more knowledge in the retail community than in the institutional community, which is fairly impressive. It's definitely true that there is a deficit of education with institutional investors about what Tesla is. And this is not, these guys are totally fine. They are very smart people. But the real difficulty is when you are an institutional investor, and I'm not talking about everybody, of course. Some of them are my clients. Remember, the difficulty for these guys that they have like a fiduciary duty. They manage the money of someone else. And when you manage the money of someone else, you have to frame a lot what you do. So you need to be somewhat capable of putting things into a box. And so Tesla, is it a car manufacturer? Well, it doesn't look like it is, okay? And is that like a smartphone manufacturer? No, definitely not. And so they don't know what Tesla is, and they don't know how to think about it. It's very easy for an institutional investor to understand that a software company is going to do something magic nobody else can do. But when you try to explain them, these guys do a car in a way that nobody else can do, and I think like what Sandy said about like the way they work together, the way they're more integrated and then can deliver like very, very significant innovation at a very high pace thanks to that. These are not things institutional investors are used to listen to hear, and so it's taking time, yes. So the retail is ahead of institutional on this name.
Sam, same question to you.
Yeah, I think the Tesla community is great at educating everyone. So keep tweeting, keep doing the podcast. Like that's terrific for all investors. And I think what's kind of interesting is Tesla is incredibly good at telling you exactly what they're going to do. It's just what they tell you they're going to do sounds crazy if you come in with preconceived notions. And so I think a lot of times what happens is they'll come out and they'll say what they're going to do, and then people just don't listen because, as Pierre was saying, maybe it doesn't fit into their box or their, preconceived notion of what is possible, and then they go ahead and they do it, and that's that. And then the next thing comes and they say what they're going to do, and then everyone says, no, that's not possible, and then they go ahead and they continue to execute on that. And so I think we're kind of at this next point in that phase where, they came out originally, right? You go back, no one said they were going to be able to scale Model 3. right? And just yesterday, someone from Toyota tears down the car and they say, "Wow, this is pretty good manufacturing," right? That's very different from saying, "What are you going to do when Toyota starts to manufacture an EV?" And now we're at this next phase of growth here, where they're looking for this next generation platform. They come out and they say, here's a permanent magnet motor with no rare earth metals. It's going to cost $1,000, right? So they say that, and it's like, that alone, maybe that doesn't mean anything, but then you go ahead and you do the math and you say, 75 kilowatt hour battery pack with a $1,000 motor that's efficient enough to use, iron phosphate cells so you can keep cutting those costs. And then all of a sudden you have a drivetrain that's, $6,000-ish dollars, and 25% of the cost of the car. That's like a rough rule of thumb for how you get to the drivetrain. And all of a sudden you're at a $25,000 vehicle. And Pierre put out slides on this breakdown in more detail, but it's like they've laid it out in very simple steps. And so it's a question of, do you believe that they can execute on this, or do you think that they're making it up? And I think it's pretty clear that they've been executing on what they've said they'll do.
So maybe that's great. That's phenomenal. Yeah. So let me maybe ask this question to the panel. $25,000 compact car, is that real or not, based on what you saw? Is that a legitimate hypothesis that Tesla will release a compact car for $25,000? Is that legitimate, do you think?
I think if you were listening, they announced the cyber sedan and people just weren't listening.
Yeah, so 50% off of a Model 3 is $17,500, and you can sell a $17,500 cost vehicle for $25,000 and make enough profit to sustain the business case. And I was actually interviewed a couple of months ago, and I said a $25,000 vehicle is really not what the American consumer deserves. I feel like we're expecting too much, but with everything that Tesla showed today, I feel like they've forged a plan forward where that can become a reality.
I'll tell you, what I think is that when you start looking at the next generation of car buyers, they want an electric vehicle. They won't have enough money. As a matter of fact, I don't know who it was, but somebody came along and said, "Hey, my 12-year-old daughter wants to become an engineer because of what's going on with the car industry." And I think that the next generation, or the generation that isn't in this room, not represented in this room, they're the ones who are going to want that $25,000 car. And I'm telling you what, they're going to make money on every one of them. Everything that we've ever seen from Tesla makes a higher gross margin than anybody else on the planet. Now that they've got volume, there's no question in my mind that they're going to kick ass and take no names.
So I think like the $17,000 bill of material is probably a stretch. That's like their internal target. But to sell like a $25,000 MSRP car, that means on average you make $27,000 per car because you have options and things like that. And Tesla doesn't leave any money on the table with dealers or anything like that, so that's a net revenue for them. So if they can pull together a car at $21,000, we're talking a 20% plus gross margin car already. When you look at the gross margins the industry is making on a Corolla, it's like in single digits. So we have already a very, very high level of confidence Tesla is going to sell a car for $25,000 and is going to be very profitable doing that. So that's one thing. And I don't even need to believe in the 50% cost reduction to believe in that. Then the second thing is, in terms of affordability, a $25,000 car that is electric, that has a drivetrain, that doesn't need maintenance for 1 million miles, that is insured by Tesla, and that is very cheaply insured because it's very safe. It's actually, we did the math on a full timeline, like on a 12-year full ownership cycle. It is actually the same total cost of ownership as a $17,000 car, IC car. So anybody who can today afford a $17,000 car is going to be able to afford a $25,000 Tesla. And that means 80% of the market is up for grab for Tesla.
Farzad, can I ask a question?
Please. Yeah.
Okay, I want to ask the question to the panel. This is just a quick survey question, just a quick answer. Do you think the next gen car, the 25 whatever thousand whatever car, will it be a cyber sedanish, like a cyber small car, or will it be a regular stamped small car? Let's go from Sam, and don't worry about explaining it. I'm just curious hearing your gut answer here.
I'm really getting thrown all the first questions over here. I think the next generation platform will be cyber.
Yeah, I think the next generation platform is less about what it'll look like and more about the core architectural elements. So I think that the powertrain development is going to be common and carried throughout not only the small vehicle, but backwards compatible to the 3, the S, the X, the Y, the Cybertruck. And then the battery technology has been improving over time. So when they say next generation, I think if you look at how Tesla made backwards compatible the Model 3 and Model Y powertrains into the S, the X, and even the Plaid, I think that it's more about the core architectural elements and less about whether it looks like a Cybertruck or looks like a cyber sedan. And I think they're really focused on the core architectural elements.
So if you had to choose one, which one would it be?
Answer the question.
I think it'll look like more like a Model 3, less like a Cybertruck.
Yeah, I think in terms of look and feel, it's to me definitely going to be like a smaller Model 3 or a smaller Model Y, because it's going to be a very high volume car. It's going to be like a 10 million units kind of car. So you can't afford an extreme look like the Cybertruck. In terms of architecture, I think it's going to be a 1,000 volt powertrain, and I think the casting will go very high from back to bottom, so it will be very similar to the Cybertruck in terms of architecture for the body and for the powertrain.
I'm also on Team Model 3 aesthetic. Not necessarily that, but non-cyber, I guess.
Sandy.
Not me. Okay, so what I think they're going to do is they're going to create a box, a $25,000 box, and that box is going to be geared toward the next generation of car buyers. It's going to look kind of totally different than a Tesla. And the reason for that is because they're geared toward the kid that's going to college, or they're geared toward someone who needs transportation from here to the what do you call it? The what's the drugstore or whatever. This is going to be for old and young people, and that's where the $25,000 car is going to be, and it's going to be made in Mexico, and they're going to make a shitload of them, and it's going to be a ton of money. That's I don't think it's going to look anything like a 3, an S, or a Cybertruck. It's going to be something that's going to be for the masses. Yeah, there.
I think.
Wait a minute. What's your answer,
Yeah,
David?
what's your answer?
Come on, let's go.
I think it's gonna be a small SUV. Probably not cyber. I think they'll skip the sedan. I don't think there's a big market for small cars. I think the small SUV has like at least 5x bigger market. So yeah, that's my gut right now.
And so when you're thinking about the number of units they'll sell every year, is this 10 million units a year, 8 million units a year? How are you guys thinking about when it's fully ramped? Like what percentage of the total business that Tesla's going to sell is going to be this compact car? And how do you guys think about robotaxi on top of that as well? Here.
Like 50%. 50%.
Mic check. Mic check.
50%. Yeah, I think the potential of, if you look at affordability, and if you think Tesla, is like the price of the Model S, the Model X, the Model Y, and the Model 3 will remain in the ballpark of where they are today. I think Tesla is probably maxed out in high single digits on these models, like so 8 million units maybe. And then you add the Cybertruck, and everything else will have to be the Model 2, like the next-gen car.
Okay. Any other thoughts? Go ahead.
Yeah, I would say.
Mic check. Mic check. You have it on?
Check. All right. I would say the development of FSD is going to determine a lot of the outlook, right? They asked today, how many models do you need? And if they can achieve full self-driving, as we think they can, as Elon thinks they can, then I think that really changes the outlook of what type of vehicles you create. Because if you have an autonomous vehicle, then all of a sudden, who cares compact, who cares sedan, who cares SUV? It's like you're going to optimize to the robo-taxi form factor, which is going to be, I think, different than everything we have today. And I think autonomous itself and the work from Tasha Keeney, suggests that autonomous should lead to a lot of form factor diversification as well. So I think that development alongside the traditional electric vehicle path is going to determine, what the next 5 years look like.
Okay. Any other thoughts around number of? Go ahead.
Yeah, I think when you think about it, if Tesla can make a car for $25K and it could drive itself, I don't understand what other car people want to buy at that point. So if there's some 80-something million cars sold every year, wouldn't at least half the people want a car like that? I mean, yeah, I think it comes to a point where Tesla can sell everything they can make. I think they could easily sell 15 million of these cars every year if they could make that, or even more. But what's interesting also is Tesla's vehicle engineering team, they focus on something for a couple years and they move on to the next project, right? So it was the Model 3, then the Model Y, and then it's this next-gen vehicle. So the question is, what's after the next-gen vehicle? What are all of these vehicle engineers going to be working on? And I think the bigger picture is they're going to revisit these vehicles to basically do a step change. So the first $25,000 vehicle in 5 or 10 years is going to have a completely different manufacturing approach and process, efficiencies. And so, yeah, it's just going to get better over time. And so that's good. This is going to be, I think, Tesla's main vehicle, probably 75% or more, of their sales.
Go ahead, Sandy.
Hello? Yeah. Okay. All right. So a lot of you folks have kids, and they may be the kind of kids that you like. A lot of parents don't care for their kids. But anyways, if you like your child, you have an option. You have the option of either buying them a used car for 25 grand so they can go to college, or you can have the option of a $25,000 Tesla, which will have self-driving, which means that your idiot kid, even if you don't like them, they do grow out of it. Anyhow, so even your idiot kid, if he's got self-driving, you can switch it on or something like that and keep them out of trouble. And basically, if you've got a $25,000 car, you can either buy that or an old Pontiac, which is a gas guzzler. And you know what? The kids aren't going to go for that. They don't want that shit. So here's the thing. A $25,000 Tesla is going to sell a shitload of cars. Think about it. What are the biggest selling cars in history? Volkswagen Beetle and a Model T. Guess where I'm putting my money? I want that $25,000 car that looks like a brick that I can buy for my kid. And if I've got 3 kids, holy shit, that's 75 grand. Everybody here is going to make a shitload more money. Yeah. I'm old, so I must be right.
So let me ask you this question then. Maybe it's for the panel. Okay. I've been a Tesla investor since 2012. I'm a bull. I'm somebody who's very optimistic about the company. But the way this this story starting to unfold is that all the different hypotheses around if Tesla were to do this, if Tesla were to come out with this $25,000 car, it would put the car market upside down. It would kill the value proposition of every other car that's out there, especially in markets where the lower price levels are underserved. So it sounds like when this car comes to fruition, is Tesla just going to have a market all to its own? Will they have no competition? How should we think about that equation?
I think their biggest issue will be how can they produce enough to satisfy demand. That's really what it is. And right now, they only have enough factory space to build 2 million vehicles a year. They just said it today. So they're going to have to online that Mexico plant and other plants in other areas of the world to serve the entire world. Because I think small cars and $25,000 vehicles are better served for the entire world. Europe, Southeast Asia, even China, smaller cars will sell better. In the US, people still want that mid-size SUV, the 3-row SUV. So if Tesla was only focused on the American market, they'd be manufacturing a 3-row SUV to compete with the Explorer, the Telluride, the Grand Cherokee. But if they're focusing on small car, that's a global focus.
And that's why I hired Corey, because he's absolutely right.
Yeah, so off of Corey's point, I was talking, after the presentation, I was asking a Tesla exec why they chose Monterrey, Mexico as their next Gigafactory. Why didn't they just, double Austin and, why Mexico? And he was saying that Mexico is not for the US. They're not looking to make cars and send it to the US. Mexico is for new markets. And Mexico is for Latin America, for South America. But then as I was driving here, I'm like, wait a minute. It's like, that means that that factory really is for the next gen vehicle. It's not for any current, Tesla vehicle. So if you think about it, they're making a factory, they're starting the factory right now, or they're gonna be building it. The factory capacity, who knows, 2 or 3 million or something. It's gonna be for the next gen vehicle. When is this gonna happen? Well, how long does it take to build a factory, and then to, start the production of the next vehicle. Anyways, long story, basically Tesla is launching their next phase of their growth right now. And Monterrey, Mexico is their next gen vehicle, factory for a whole nother part of the world that they're not serving right now. So interesting stuff.
So as I always say, listen to David, he knows what he's talking about.
Any other thoughts from the panel on this topic? No? Okay. So is the Gen 3 car the biggest takeaway from this presentation, or is there anything else that popped out to you so that we discussed 4680, we discussed Gen 3. Is there anything else that was mentioned that you thought was worth highlighting that hasn't been talked about?
How about the thing they didn't mention? And that was the motor. And I kind of knew that this was going to be coming down the road, but 30% more power at basically a less cost by going to a hairpin motor is huge. And they didn't say anything. But you know what? Look at that video. Look at that video. You're going to see where they're welding the tops, laser welding the tops of all those hairpins back together. I'm telling you what, I was sworn to secrecy, but even Corey can't keep me shut on this one. This is a big deal, folks. A huge deal. Huge. And they showed it on the video.
Sandy, you're fired. I'm kidding.
Actually, now I can retire.
Go ahead, Corey.
Yeah, and then what they didn't show at all in the presentation was that inverter we saw that they were working on in that quality cell. It had 24 discrete MOSFETs, which was more than the 18 that are in the Model 3, the Model Y, the Model S, the Model X, the Plaid. And I think it's the discrete chip that they have to thermally control in the inverter. So they need a lot of them to convert the DC to AC so you can drive. So the battery is DC, roughly 400 volts, 350 nominal. You have to have the inverter convert that from DC to AC. So you have 3 sets, typically 3 sets of 6, they're actually growing from 3 sets of 6 to 3 sets of 8, which means you can handle a much higher voltage because you need more of them to handle voltage for the switching from DC to AC. We tear down every single EV not in the world, at least in the US. And when Sandy and I saw that through that test cell, we went over there and we started asking them questions. And we're like, hey, what's this for? Why is it different? Why is it a different form factor? So the way that they were thermal cooling it, the look at the form factor of it, the shape of it was all different. Never to be seen on a Tesla that we've ever torn down. So this was new. It was like either a prototype or already in production, rolling around on the road. But Sandy, what do you think?
There's nobody on the planet that's got 24 IGBTs. Or actually, they're called different things in different. So you might not recognize that word IGBT, but you probably might have heard of MOSFETs. And MOSFETs, IGBTs are slightly different, but kind of the same. That allows you to move from the mundane to the extraordinary. And when Corey told me, hey, there's 24 IGBTs on that cell over there, I kind of turned around and I said, oh, Corey's smoking dope again. But it wasn't. It wasn't. I looked over. I could not believe my eyes. I had to count it twice because something's wrong with my eyes. I'm dyslexic and want to. Anyways, I had 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 24. I about shit my pants. and then we saw the casing is sitting there. And I said, I'll be right back. And I walked right up there, and the guy that's in charge, I don't think you should be doing that. I pretended like I couldn't hear. If you're old, you can get away with anything. I mean, anything. So I went over, I had a look. I counted them up when I was nice and close, and I could tell what was going on. And then I started looking at casing. And we have a sketch.
Yeah.
Corey made a sketch of the casting.
Let me summarize this. The big deal is we already think that the Tesla powertrain portfolio is world-class leading. But the question is when can other OEMs catch up? This is another step change forward. If they're developing a new powertrain platform, then they're going to actually move even further ahead of the competition. Only days after Toyota says that the Model Y is a work of art. So now they're leaping further ahead in the future. They will actually most likely use their powertrain platform on all their vehicles because they're currently using, I think, the Generation 3 on the 3, the Y, the S, the X, and I thought the Cybertruck, based on what they showed when they revealed the Cybertruck in the past, but I think it's going to be on everything. Maybe, I don't know.
Plaid Plus, the question. Go ahead.
So one of the biggest, probably the biggest takeaway was this whole new assembly process for the next-gen vehicle, where instead of assembling the car at one point, you're breaking it apart into different sections where you can assemble them separately all to the finish point and then just sticking them together at the end. It makes complete sense, and this is pretty much at the core of this new generation of manufacturing. The question.
Talk about the painting.
Oh, he's being told a secret right now.
The painting. Actually, I'll let you talk about that painting. The question I have is, Tesla is giving away their secret for the next-gen vehicle. Is any automaker listening? Are they even going to try it? How long is it going to take them to really copy this, you know? And my hunch is they're not going to do anything about it for the longest time until years after the next-gen vehicle comes out. They're getting slaughtered, and they're going to start to do something, but it's going to be like years and years late. Anyway, Sandy, what about the painting?
I thought you were going to mention what they're going to be doing is they're going to be painting the lay-down side. There's a bunch of different terms that I'm going to use that probably nobody cares about. But anyways, they're going to do the lay-down body side ring, and they're going to paint that. Then they're going to paint the hood, the doors, and everything. And they're going to do them all separately because anybody that's got a brain knows, why would I want to put all the doors on, then I want to take them off, then I want to put them on later on? Why is that? That's just plain old stupid. But you know what? If you can take all of the major components and paint them and then put them together once. Think about it. I put the doors on, I paint it, I take the doors off, and then I put them back on. That's 4 processes. What about this? I get the body side done, and then I put the door on. One time. I mean, this doesn't take rocket science, okay? Anybody with a brain knows that it's easier to do it if you only do it once. And that's really what that was the crux of the thing with with painting and whatnot. This is a brilliant video. I think every kid, 12, actually, we've had some genius kids that are about 7. Every kid should be watching this to know what the future is, to know what you know, what a genius we've got in our midst with Elon Musk.
Pretty amazing. He's pointing to, there's a looping video of a Tesla bot, the Tesla bot video on there. I don't know if we can throw it up on the main screen, but let me ask this one question, and then we're gonna do a little bit of Q&A in the crowd. So if you do wanna ask a question, do line up here. We'll do like 3 questions. We'll start with Sam, and then we'll go down the line. After today's presentation, are you more confident, less confident, or right about where you were about your trajectory for Tesla's future and its valuation?
Check. All right. So I'd say more confident. I think that, again, I'll say, you know, Tesla's been telegraphing what they're doing for a long time. And I think they've gone into more detail and kind of shed some light on what's going to happen. And I think all of that detail leads to some more comfort and confidence in their trajectory.
I think I'm slightly more bullish because I feel like Tesla has shed their imposter syndrome. For years, they're the little kid on the block that the big OEMs kind of dissed and ignored. But now they're looked at as the leader in the market, particularly for EVs. So what I sensed was an air of confidence among all the presenters today that they no longer need to defend what they're doing because they're leading, because they think that what they're doing is right, and they don't need to prove anything to anybody anymore.
So now what I saw today got me a bit worried, and I'm concerned that maybe Ford is going to take over Tesla. So I don't know, I'm not sure. I just wanted to check if people are listening, and nobody is listening.
There's at least 4 people listening, yeah.
Yeah, 4 people listen. No, so what I saw today, you were asking, you know,
more confident, less confident, yeah.
The one thing that made me very confident today is how much flesh there is around things I look at with a spreadsheet and doing analysis. And by flesh, I mean the team. So you had like 15 people on the contributing to the presentation. I would say the average tenure is close to 10 years. So this kind of idea that there is a lot of churn at Tesla, you realize it's not really true. These people have been like in the whole story for the last 10 years. And they are like really, really motivated. They're motivated by the mission. And they work together, like as Sandy mentioned, nobody else in the world works together like the way they do. And in reality, today, I got worried for like other car manufacturers, to be honest. The more I see, the more I learn about Tesla, the more I feel like I don't really know how others are going to be able to adapt to that.
Rob?
Yeah, I would say I am still confident. I think I'm usually pretty confident in Tesla, and I think this is an event that really just reinforced a lot of that feeling. You know, I think Tesla demonstrated that they have a clear goal and they have a clear path to get to that goal, as we so often hear from them. And as Sam kind of kicked it off with, usually the things that Tesla talks about, they can accomplish. I think you can set autonomy in its own little bucket, and I think that's a sort of a different problem set. But when it's come to the engineering, you know, pretty much 100% hit rate from Tesla on hitting their targets on things. So yeah, sometimes it takes a little bit longer than all of us would like, and yeah, we would have loved to see like a new car today, but whenever it comes, you know, next couple of years, I think it's going to be an amazing product, and I think everything that Tesla talked through today just made that, very clear. And to Pierre's point about like competition, no one's thinking about the problem in the way that Tesla is thinking about it. And if you're not starting with the right problem or starting with the right questions, you're not going to get the right answer. So it's pretty clear that Tesla's got the right answer.
For me, I would say I am more excited. I wouldn't say less or more confident. I'm pretty confident of Tesla's future regardless. But today was about the details of how they're going to drop the cost of making a car by 50%, which sounds incredible and almost unbelievable. And I think before today, most people, especially maybe some Tesla investors, give the benefit of the doubt to Elon and say, oh, they'll figure it out somehow to drop the cost 50%. But today was the actual details of here's how we're going to do it. And I think at the crux of it is this new assembly paradigm. And I think this is just the beginning. I really think we're going to have to think about this deeper because it's really a revolutionary change in the assembly process of a car. And also the whole 4680, where they're already pumping out the dry electrodes and making the cans and everything. You just stick these pieces together, and you've got Tesla showing us exactly what their next-gen vehicle is going to be like, but it's in full detail now, And I like how they didn't completely lay it out where you have to kind of put together the pieces, connect the dots, and you'll get it. But if you're not thinking, then you still probably won't get it. You kind of have to use your brain a little bit to put everything together. So, anyways, it's definitely a good event.
Sandy?
Okay, I'm twice as old as anybody here on the panel, and I've seen everything, pretty much. I'm going to tell you right now that Tesla is going to crush, and I mean that sincerely, crush the rest of the automotive industry. And the reason for that is because of one person, Elon Musk. If that guy disappears, then I might change my mind. But at the end of the day, I'm going to tell you simply, you've made a wise choice in buying that stock. And I am going to tell you right now, nothing, absolutely nothing or nobody is going to get in the way. So I'm a little less wishy-washy than everybody else. And the reason for that is because I'm old. I don't give a shit. I can say whatever I want. Cheers.
Not financial advice. Okay. 3 quick questions from the crowd. Who wants to ask a question here? Okay.
Yeah, good evening. So this is kind of a question that may impact Austin. From an engineering and a supply chain, like Mr. Farzad over here, standpoint, do you see some kind of integration of a Tesla tunnel between Gigafactory and the Huda railhead? Because essentially, legacy auto, usually the older factories had railheads built into the factories. So would this be viable from a cost benefit and for probably a per unit standpoint and cost per mile drilling? Thank you.
Sandy, this one is for you.
You prick, I can't believe it.
No, I feel too young to take that
question.
question.
Film. Actually, I don't see any problem with Tesla finding people. I don't see any problem with Austin becoming a gigantic center for automotive. Maybe they'll turn into the new Detroit. I'm not sure. But I guarantee you nothing is going to get in the way of the progress that Elon's put in place. Nothing. Zero. I am 100% in back of everything I saw today. I was already a fan, but at the end of the day, nothing is going to get in the way of Tesla. Nothing. Zero.
Next question.
We talk a lot about cars, but did you hear anything new today about the energy business that will let you model better? Because we don't cover that much.
Energy, questions around energy.
I think that's the first time Tesla gave like a guide for the size of the market, like the the amount of batteries that is necessary to like transition the whole world to sustainable energy. And they gave that number, and so they estimated that we need 240 terawatt hours of batteries to move the world to sustainable energy. And to put that into context, they expect to sell 1 terawatt hour of battery packs, of mega packs. So yeah, that means, you know, on 2030, 2035 horizon, the battery pack business could be a third of the size of the auto business, something like that.
And then the other thing that they highlighted is just from the strategic angle of being able to pretty much not be afraid of having too many battery cells, right? So if you're just a EV maker, you know, you want to match your cell supply to the vehicles you're making, because if you have too many, then that just goes into inventory. If you have an energy business, then any spillover can go into the stationary energy storage business. And they highlighted that, you know, at the right price point for a utility, there's a huge amount of, you know, existing demand out there. These batteries can replace peaker plants. And so there's this kind of this sitting demand waiting to be fulfilled. So if you have that spillover, you can go right there.
I think one thing that was interesting, it's not anything really new, but I liked how Tesla presented it. They showed that slide of like cumulative energy storage deployed, and I think it was 16 gigawatt hours. And when you just see that graph up to 1 terawatt hour for, you know, 2030 or around that time frame, it just shows how early that business is, even though it's still a multi-billion-dollar business already. So I think that, you know, just gives us a real sense of where it's at so far. And then you think about Lathrop, it's a 40 gigawatt hour facility, and you know, they talked about converting a JCPenney warehouse in under a year. So I think that has just a good way of presenting why a lot of people are really excited about the energy business. And it doesn't really get its due, for sure. But I think it's, you know, we're going to start entering the curve where it starts to get more attention and more credit for the business that it's become.
Okay, one more.
How's it going, guys? I'm the Kilowatts. My name's Ryan Levinson. A little bit of a hardball question for you guys. Historically, we've heard a lot about autonomy, and Rob Maurer kind of alluded to this. What are your thoughts on why autonomy wasn't as talked about today? Why didn't we hear more about FSD's impact on the financials? I mean, today could have almost been manufacturing day rather than investor day when you exclude FSD. So for anyone, why did we not hear as much about autonomy or FSD today?
You need to subscribe to my research. It's because robotaxi, I have doubts. And I think I convinced Elon. He has doubts as well. No, that's not true.
I've got a different take, but I think it's because we just had AI Day.
And Sam agrees with me.
They spent a good amount of time talking about it, so I think they had Ashok up there, and you know he kind of gave the summary version of it. But I think they've talked quite a bit about it recently, and I think it's kind of as simple as that. It's my perspective.
No.
Go for it. Oh yeah, I'd agree with that. You know, they just had the big discussion about it, and I think it was given equal time. You know, they went through each division and said, you know, here's what's happening. They gave the update on full self-driving, and I think the great thing about full self-driving is you get the update, you know, every time they release it. So I think it's the most talked about, most discussed thing, and definitely, you know, from our perspective, that's where the asymmetric upside can be.
One thing that I thought was kind of interesting that I don't think probably got much attention yet, and I think Pierre will probably be happy about this, is that I did notice that when they were talking about the next generation platform, they mentioned that they'll have robotaxi variants of it, and that they would talk a little bit more about that, you know, at a later date. So I think prior to this, there's been some uncertainty, and Tesla's kind of communicated that the next generation platform would just be a dedicated robotaxi. So today was kind of the first time I felt like they shifted a little bit back towards this is just going to be a product for consumers that they can drive, and eventually they'll hopefully evolve it into a robotaxi and get there. But I think that will give people a little bit more confidence in being able to model out growth beyond the Model 3 and the Model Y, where you don't have to count on autonomy, you know, being level 5 or something like that to take Tesla to a higher market cap. So I was pleased to see that from an institutional perspective. I think that's going to make a little bit of a difference, at least.
So if you actually listen carefully to what Zach said, Zach talked about robotaxi and said something very interesting. He talked about the long-term financial model of Tesla, and he said, I'm going to continue to take OPEX down as a percentage of revenues. I'm going to maintain gross margin at healthy levels. And then after that, he said, and if FSD comes to fruition and changes the economic model, then it will have like a very significant impact on our economic model. And I thought it was a very, very good way to present what this opportunity is. It's still like something that is, as you said, a very asymmetric potential upside, something that could work. I have personally my doubts. That's not something I bet on. When I model out Tesla and when I look at what Tesla could be worth, I don't have anything about robotaxis. If it happens, it would be an additional upside in the way I look about it. And I was very happy to hear that that's the way Zach is running the business. He's not counting on it, basically. It doesn't mean it's not going to happen, but he's not counting on it.
So one way to think about that question or answer is AI Day last year was Elon Musk saying, you know, we win. AI, we're just way ahead. It's going to make our cars profitable and more basically efficient, more sustainable, all that. But then perhaps he got some feedback from some people and institutional investors who say, we don't believe it. You know, when is it going to come? And so perhaps today was Elon Musk saying, forget it. Even without FSD, if you don't believe it, we still win. Even with just even with just drivable cars, you know, with nothing FSD, we still win. And here's how we do it. So whether you believe in FSD or not, you know, either way, you know, it's kind of a two-pronged approach, I think, by Tesla.
Okay, so I'm just going to say something quick. We've looked at everything about everybody. Very few people have taken apart everybody's car. And I believe that Tesla's about, I'll look over here at Corey, somewhere between 6 to 8 years ahead of everybody else in self-driving. The software is better, the controller systems are better, the ADAS system, which is the module that you have inside, is better. I don't see anybody catching up anytime soon because they're stuck in the old paradigm of, well, I got to do this and you got to do that, and don't you try and get into my silo, and on and on. So again, I don't know how anybody's going to catch up to Tesla, but if they do, it'll be like only because all the plants burned down the same day.
All right, we're going to do one more. Can I get a lady? We're going to get a lady. Here we go.
Hi, everybody.
Oh, no, don't give her the microphone. No, no.
Sandy. Hi, everybody. Just a quick question. Did they talk about any incorporation with SpaceX or the Boring Company or Neuralink or anything under X Holdings?
No.
Okay, so here's the deal. I'm the only guy on this floor that actually has worked on rocket ships, and it's in my resume. You can find about it. And I'm telling you what, any idea that we ever had for L'Oreal or Boeing or Lockheed Martin or anybody else on the planet has been implemented already. SpaceX, they've already, Corey and I toured that place. I looked at their rocket motors, which actually...
you can talk about that.
Yeah, can I? Okay, so actually, I actually made suggestions, and Elon Musk said, hey, that's a good idea. Haven't we done that before? Okay, so when we were down there, I walked through their whole system, where everybody else used these machined, stupid-ass, what do you call it?
Titanium.
Beehive system, and a whole bunch of rivets and horse shit. And I would say, why don't we just weld this? You're only going up once. And that's what everybody else did. They're welding it. Everything that Tesla does in SpaceX, or let me rephrase that. Elon Musk does on SpaceX, is absolutely brilliant. Like I said, I can't say enough about him. He's the Einstein of our age. That's fact.
Well, actually, we're actually out of time. All right, everybody. Thank you very much, Sam, Corey, Pierre, Rob, Dave, Sandy. Thank you all so much. Thank you, everybody who came tonight. Thank you, everybody at home watching on remote. Thank you on our back. Matt, you guys want to say any last words?
I'm surrounded.
Hold on, we're gonna do a picture before we go. Randy, the DJ, we're gonna celebrate our 10-year anniversary of the Tesla Owners Club. Let's pump up the beats. Let's go, DJ!